Google Cloud Platform provides a range of services for developing, deploying, and managing cloud-based applications. Its significance comes from the fact that it allows for a dependable, scalable, and innovative platform for businesses ranging from startups to enterprises. GCP enables organizations to leverage cutting-edge technology and global infrastructure, ensuring efficiency and growth in the digital era. So join us as we explore the role of GCP in transforming how we use the power of cloud. On that note, hello everyone and welcome to this video on the GCP Architect Full Course by Edureka. For aspiring GCP architects, this course is your chance to become the master of designing and implementing cutting-edge cloud solutions that drive businesses to digital success. But before we begin, let's take a moment and outline the agenda for today's session. Let's start by understanding cloud computing basics, then explore Google Cloud Platform and learn the steps to become the GCP Cloud Architect. Next, we'll guide you through creating a Google Cloud Platform account. We'll then dive into specific GCP services like Google Cloud App Engine and creating a VM instance in Google Cloud and using Google Kubernetes Engine. Following that, we'll cover important topics like Google Cloud Storage for secure and scalable cloud-based storage for your data, and also cover GCP Database Services such as Google Bigtable and Google BigQuery for effective data handling and analysis. We'll discuss GCP networking services including Google Cloud Networking, and then cover GCP security services. And then, moving forward, we'll explore the introduction to Google Cloud Machine Learning, followed by the insights into Google Cloud IAM and GCP Terraform. We'll look at practical GCP projects, hosting a website on Google Cloud Platform, and also hosting a WordPress website on GCP for free. Additionally, we'll compare AWS, Azure, and GCP. And finally, we'll check out the top Google Cloud certifications. As we wrap up this full course, we'll go through some frequently asked GCP interview questions to ensure that you're well prepared for the real-world scenarios. But before we begin, please consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, visit the Edureka website for GCP certification training course, the link to which is in the description box below.
What is cloud computing? Everything nowadays is moved to the cloud, running on the cloud, accessed from the cloud, or may be stored in the cloud. So what exactly is the cloud? Simply put, cloud computing, often referred to as the cloud, is a service that allows people to use online services that are generally available through any device with an internet connection. This means that the user does not need to be at a certain location in order to access certain data. From computing and analytics to secure and safe data storage and networking resources, everything can be delivered within no time thanks to the cloud. The goal of cloud computing is to deliver these services over the internet in order to offer faster innovation, flexible resources, and economies of scale. Have you ever realized that you probably have been using different cloud-based applications every day? Whenever you share an important file over OneDrive with your colleague through the web or use a mobile app, download a picture, binge watch a Netflix show, or play an online video game, it all happens on the go. The best part? It saves you a lot of money and time. You don't have to buy any machinery or install any kind of software. Everything will be handled by the cloud platform which is running these applications, whether it's Google, Microsoft, or Amazon. Many such tech giants have already switched from traditional computer hardware to more advanced cloud architecture. Not just that, these companies are also the most popular cloud service providers in the market today. As more and more companies undergo strategic digital transformations designed to utilize the power of the cloud, they need more IT professionals and leaders with the expertise to extract the best business results out of their investments.
What is Google Cloud Platform? Offered by Google, it is a suite of cloud computing services that runs on same infrastructure that Google uses internally for its end-user products, such as Google Search, Gmail, file storage, and YouTube. Along with a set of management tools, it provides a series of modular cloud services including computing, data storage, data analytics, and machine learning. For organizations with large amounts of data to store or analyze, Google Cloud Storage prices are up to 20% cheaper than AWS, and the price of database services also compares favorably. While there is no difference in the price of container services, Google Cloud is an industry leader in the field and is also investing heavily in AI and machine learning technologies. Many small and large enterprises are increasingly adopting Google Cloud Platform since it engages things and makes them more secure at reasonable costs. Let's now understand different products that Google Cloud Platform offers. We can divide Google Cloud products and services into five major categories, that is, compute, storage, networking, big data, and machine learning. So let's first understand what compute does. The secure and customizable compute service lets you create and run virtual machines on Google's infrastructure. These are the subcategory of products provided in compute. So first in the category is Compute Engine, which offers platform to run your virtual machines, your virtual servers on Google Cloud. So suppose if you have a server sitting in a house and if you want to deploy a similar server on Google Cloud, okay, you would use Compute Engine to do so. So next is Google Kubernetes Engine, which provides a managed environment for deploying, managing, and scaling your containerized applications using Google infrastructure. The Google Kubernetes Engine environment consists of multiple machines grouped together to form a cluster. Moving on App Engine, as the name suggests, it is an application engine where you can deploy your web applications, your large-scale applications without any headache of managing the back-end infrastructure. Now moving on to the last category in compute, that is Cloud Function, which allows you to trigger your code from Google Cloud Firebase and Google Assistant or call it directly from any web, mobile or backend application via Hypertext Transfer Protocol. Moving on to storage, this is the USP of Google Cloud because ever since Google came into the market, its storage and how it deals with the data has always been its USP. So these are the subcategories under storage. The first major product provided under storage is Cloud Bigtable. So it is a NoSQL database. For people who don't know what is NoSQL database is, it simply means it's a database where you cannot apply concepts of traditional relational databases. So data which is not structured, which is big data, which is sparsely populated, all such kind of data can be stored under Bigtable. You can simply consider the second category, which is cloud storage, as a C or D drive on your laptop. It is an object store where you can store all kind of objects like images, videos, documents, etc. It is a concept of buckets. So within storage, you have multiple buckets, like you have folders in your drive, right? And within those buckets, you can store your files, just like you store files in your folders, in your hard drives, right? In your laptop. So moving on to the next one, that is Cloud SQL. So Cloud SQL is a relational database product. It's very efficient if your database is not very large, and it's very good for database analysis. It is a fully managed database service which makes it easy to set up, maintain, manage, and administer your relational databases on Google Cloud Platform. Cloud Spanner can be considered as a big brother for Cloud SQL. So Cloud Spanner is a relational database with big data capabilities. So you can consider it as if you combine Cloud SQL and big data capabilities that make Cloud Spanner. So Cloud Spanner is similar Cloud SQL with massive scale and massive capabilities to run big data loads with SQL support. Now moving on to the last one in this category, that is Cloud Data Store, which is a subset of Bigtable because what Bigtable cannot provide is somewhat provided by Cloud Data Store. So Cloud Data Store sits on Bigtable technology with a slight SQL support. Although it is a NoSQL database, it still gives you some flexibility of using SQL and doing your analysis. Now coming to the third category, that is networking. So Google Cloud Networking has tools that make it easy to manage and scale your networks. And these are the subcategories under networking provided. So first in the category is cloud load balancing, from which you can scale your applications on Compute Engine from zero to full throttle with no pre-warming needed. It is a fully distributed software-defined managed service for all your traffic. Now moving on to Cloud CDN, extended as content delivery network, it offers connectivity to more users everywhere. And next is Cloud DNS, a service which provides you a network of DNS servers, DNS extended as domain name servers. You can easily manage your DNS records through its interface. Now moving on to the next one, that is Cloud VPN. VPN is extended as virtual private network. So Cloud VPN securely connects your peer networks to your virtual private cloud network through an IP secure VPN connection. Now moving on to the last one in the category, that is Cloud Interconnect. So Cloud Interconnect establishes private connectivity from your data center, office, or co-location environment to reduce your network costs, increase bandwidth throughput, and provide a more consistent network experience than internet-based connections. So moving on to the fourth one in the major product, that is big data. So it is natural, if you see, to host a big data infrastructure in the cloud, because the Google Cloud Platform provides multiple services that support big data storage and analysis. So these are the subcategory under big data. So first in the category is BigQuery, which is a Google Cloud Platform's data warehouse solution where you can run your data analytics and data loads, and you can like store your massive amount of data under data warehouse. So whatever data warehouse or data lake needs you have, you can get it fulfilled by BigQuery. So next is Cloud PubSub, which is a technology which is used to ingest streaming data into Google Cloud Platform. It is a middleware which sits between source and Google Cloud Platform. Okay. Now moving on to the next one, that is Cloud Dataflow, which can simply be considered as an ETL product. This helps you in extract, transform, and load data. It helps you extract batch data and streaming data in the same time, and you can create data flows within Google Cloud Platform. So you can process your data and massage your data and load it into the targets. Okay, so this is pretty much what Dataflow does. Next is Cloud Data Prep, which is an intelligent cloud service to visually explore, clean, and prepare data for analysis and machine learning. So now moving on to the last one in the category, that is Cloud Data Prop, which is a fully managed and highly scalable service for running Apache Spark, Apache Flink, Presto, and 30 plus open source tools and frameworks. So use Dataproc for data lake modernization, ETL, and secure data science at planet scale, fully integrated with Google Cloud at a fraction of cost. Now moving on to the last major product, that is machine learning. So Google Cloud Platform provides several machine learning tools and products for developers, data scientists, and data engineers to take their projects from ideation to deployment that too quickly and cost efficiently. So all the products under this are based on different auto machine learning models which are developed by Google Cloud Platform and are readily available. These are the subcategories of the products provided under machine learning. First in the category is Google Cloud ML Engine, which is a hosted platform to run machine learning, training jobs, and predictions at scale. Cloud ML Engine automates all resource monitoring for running the jobs. Okay, so it can also manage the lifecycle and deployed models and their versions. So moving on to the next one, that is the Natural Language API. Like this is a very famous product to do sentiment analysis. Okay, now moving on to the next one, which is like Cloud Vision API. So Vision API and machine learning model helps you read images. So if I upload an image under Vision API, by just reading that image, the Google Cloud Platform can help you identify the data points which can relate it to the particular image. So it's very efficient for image data processing. Next is Speech API. So this gains helps in converting your speech. So suppose someone is speaking and at the same time you want a particular speech to be converted into a text. Okay, then in that case, this particular API and ML model comes handy and it helps you do that analysis. Now moving on to the last one in the category, that is Translate API. So this helps you convert one particular language to another. Suppose you have something written in Japanese and you feed that in Translate API and it can get converted into English or any other language of your choice. Okay. So all these machine learning models need data to train itself. Remember that. Okay. Any machine learning model cannot work unless it has a training data, and based on that only it can run those statistics and come out with some predictive analysis. Okay, I hope it's clear now, the products and services. So now let's move on to understand why we should prefer Google Cloud Platform. So now that you have a brief idea of what is cloud computing is and what is Google Cloud Platform, let's understand why one must go for Google Cloud Platform. We all know how big is the database of Gmail, YouTube, and Google search is. And I don't think in recent years Google server has gone down. It's actually one of the biggest in the world. So it seems an obvious choice to trust them, right? So now let's take a look at some of its features of Google Cloud Platform, what really gives it an upper hand over other vendors. So first one is it has a better pricing than its competitors. It is highly scalable and it uses auto scaling to automatically adjust the sum of virtual machine instances that are hosting your application. So what it does is it allows your application to adapt to different varying amounts of traffic. Now, if you see the third one with custom machine types, you can create compute engine virtual machines with optimal amounts of virtual CPU and memory. Now coming to Google Cloud's IoT Core, which is a fully managed service to easily and securely connect, manage, and ingest data from globally dispersed devices. Google Cloud APIs, if you see, like they allow you to automate your workflows by using your favorite language. So this Google Cloud API ecosystem consists of compute API, storage API, big data analytics API, networking API, and several others. Now moving on to the sixth one, it is like big data analytics. So Google Cloud Smart Analytics solutions are fully managed. This multi-cloud analytics platform empowers everyone to get insights while eliminating constraints of scale, performance, and cost. Big data analytics use real-time insights and data apps to drive decisions and innovation. With Cloud AI, GCP Cloud Functions is the easiest way to run your code in the cloud. So moving on to the last one, that is serverless, Google Cloud Platform is highly available and fault tolerant. Let's now look at some popular advantages of Google Cloud Platform. So first one is customers gets higher uptime and reliability. If a data center is not available for some reason, the system immediately falls back onto the secondary center without any service interruption being visible to users. Moving on to the next one, economic pricing. So Google's economies of scale let customers spend less. So it works in a way like Google minimizes overheads and consolidates a small number of server configurations. It manages these through an efficient ratio of people to computers. Now, moving on to the last popular advantage, that is, of course, the higher security. So, Google's investments in security to protect customers. So, customer benefit from process-based and physical security investments made by Google. So, Google hires leading security experts. That's how Google provide a higher security to its customers. So, let's take a quick demo now on Google Cloud Platform. Okay, so just simply go to Google Cloud Platform. What you can do is you can just directly go to the console. If you don't have an account on Google Cloud Platform, then create one because it's a good platform to have your account on. And it will ask for your credit and debit card details while creating the account just for the verification purpose only. Let me first introduce you to the platform that the Google has to offer to us. Okay. Before that, remember one thing, like Google Cloud Platform provides you like a free trial for like 90 days. Okay. And it has certain limitations also, but if you like need the complete package and need complete access, then you can like go for a paid version also. So that's how it starts. This is how the interface looks like. You can see there's a project information is here. Like when you create the account, there will always be a inbuilt project will be there. But you can like go here to my first project, and here you can like go to new project, and you can create a new project with whatever name you want to give. Okay. Now coming to the dashboard. So I have like explained you previously, right? Products and services. So here are like products and services provided as of networking and of storage and of compute. Okay. So let's see how to create an instance in Google Cloud Platform. So just go to Compute Engine and you can go to VM instances. It will take a little time. Okay. So you can create an instance from here. You can like name your instance, whatever name you want to give to the instance. Okay. Then you can fill in the details. If you want to do some customization, you can do from here, and you can then just go as per your requirement, create it. So the instance will be created. It will take a little time, but it will be created. So the instance is being created. So remember one thing, like as I've told you, like I have a free trial, so it has a little limitation, right? So here limitation is that I cannot create an instance for Windows from here. Okay, I have a like Windows OS, so for Linux OS only, that's the limitation. So if you want to get it for the complete access for Windows also, so you can go for a paid version. Okay, so right now I'm just deleting this. You can just go here and delete the instance. I'm not able to launch it here. We can go to some other service and we can use that service of Google Cloud Platform, not if not the instance thing. We can go for the other one. First it gets deleted, let it get deleted. Takes a little time. So you can just go out of Compute Engine. We can use the service of storage. Okay, like we can store files or whatever kind of files you want to store. We can use the storage for that. Okay, cloud storage. So yeah, remember I have like explained you about storage. There is this a bucket system in cloud storage. If you remember, like we have the drives in our laptop, right? That we have folders and we can store files in that. Similarly, here is the bucket system. So you can create a bucket from here. And remember that while naming the bucket, its name should be globally unique. Okay, if like there's a similar name of any bucket is there, like anywhere in the world, they have created with the same name, then you can't create that. Okay, use some unique code for that. Okay, like I'm using here bucket 6622. Okay, continue. So you can see like there is no bucket name 6622. Here you can like choose the accessibility for it if you want to access for multi-region, dual region, or single region. So here I'm choosing single region, and then I will just create it. It takes a little time. Yeah. Okay, done. So remember that here you can like create folder, upload folder, just like your hard drives. Okay, or you can upload files. So let's upload a file. So this is like an exe file, this is an image file, whichever file you want to upload, you can upload. So yeah, let's upload a exe file here. And any kind of file like video file or any CSV file, TXT file, whatever kind of file, you can upload any kind of file here. Okay. Yeah, so it got uploaded. And remember that this is the life cycle thing. Okay, so what you can do is retention, permissions, everything is there. So in life cycle, what you can do is while you are storing a file or anything, any kind of file, but you feel like you want to delete it after 15 days or 30 days or any kind of days, any number of days. So you can go to life cycle and you can like choose its time period. Okay, so what happens is if you forget like you want to delete it, it will automatically get deleted after some days. If we are given for 30 days or 15 days, it will automatically get deleted. In also you can delete it from here, like you can select it and you can delete it from here, or also you can download it if you want to download. Whenever you want to download, you can download it from the download option. Now we are deleting it, so yeah, it's permanent action, so it's permanently got deleted. Okay, also if you want to like delete the bucket also, you can just go back here, the bucket section we can go, all the buckets are given. So here we have created this bucket, we can just go select this and delete it. All you have to do is just type delete here, just delete it.
So starting at number 10, we have simplicity. Now Google has made setting up an account and using the Google Cloud services very easy. Just by creating a Google account, you can access the whole Google Cloud platform. Now if you already have a Google account, which I think most of you might be having, just go to cloud.google.com and tap on the Try for Free button. And you'll have the freedom to choose any of the services of the Google Cloud platform. There are no upfront costs required to use these services. You get a $300 worth credit, which you can use over a time period of 12 months. Now, for startups, it's beneficial to work, play around, and get to know the Google Cloud Platform services before investing heavily in it, as they provide $100,000 worth credit for startups and $500 in credit for developers as well. Coming up to reason number 9, we have variety and versatility. So once you get started on the Google Cloud Platform, there are tools for everyone and for everything in the IT industry. Now you can use all these products for development, like the Developers Console, Web UI, and the command line interface tools to work for the command line, be it the Windows, Mac, or the Linux environment. Now you also have the option to use the RESTful APIs. Now Google has its own set of managed APIs that can be used in different applications for different purposes. Now needless to say that these APIs are very easy to work with. Coming up to reason number 8, we have the Google Cloud, which is the G Cloud. Now G Cloud is basically the set of Google services that can be integrated with one another to create applications and run websites. Now they are very easy to work with. You can use them separately as well as together for different types of applications according to your needs. Now Google stands out when compared to other cloud providers here, as they specialize in modularity. Now you can use these different pieces of the Google Cloud into various products, and you can mix and match these pieces according to your requirements. Now at number 7, we have the flexibility. So custom machine types is a feature of Google Compute Engine that lets you easily create a machine type customized to your needs. With custom machine types, you can create virtual machines with the optimal amount of CPU and the optimal amount of memory required for your workloads. Now you can create a machine type with as little as one virtual CPU to as much as 64 virtual CPUs. With Compute Engine, you are getting infrastructure as a service, and with App Engine, you're getting platform as a service, all under one roof of Google Cloud. Now the flexibility of the Compute and the App Engine allows to create a fully managed, customizable machine, which can be scaled up or down according to the traffic it receives or according to our requirements. So we can say that they are breaking down the barriers of the infrastructure as a service and platform as a service by bringing them together, all along making things simpler for us as well. Now coming to number 6, we have the big data, machine learning, and the artificial intelligence services. The Google Cloud Platform provides fully managed data warehousing facility with batch and stream processing, along with added Hadoop and Spark-specific configurations. Now GCP has an IoT-specific intelligent platform that unlocks business insights from your global device network. Google Cloud's artificial intelligence provides modern machine learning services with pre-trained models and a service to generate your own tailored models as well. Their neural net-based machine learning service has better training performance and increased accuracy as compared to other large-scale deep learning systems. And with the introduction of TensorFlow, everything we do on the machine learning engine is taken up to a whole another level. Their services are fast, scalable, and very easy to use. Now, major Google applications use cloud machine learning, including the photos, we have image search, the Google app, which is the voice search, we have translate, and inbox reply, which is the smart reply. Now, coming up to reason number 5, we have storage and database option. Now, Google Cloud Storage is a set of various storage services offered by Google for different domain scenarios. It allows worldwide storage and retrieval of any amount of data at any time. Now, you can use these cloud storage services for a range of scenarios, including serving website content, storing data for archival and disaster recovery, or distributing large data objects to users via direct download. Now, here we have so many options like the Cloud SQL, the Cloud Bigtable, Cloud Data Store, Persistent Disk, Cloud BigQuery, and there are many other more options. The Cloud SQL is used for MySQL and PostgreSQL. Bigtable is used for scalable NoSQL databases. Now, Data Stores is the document-oriented database as a service. Persistent Disk is a high-performance block storage, which is very suitable for the virtual machines and the container storage. Now, BigQuery is Google's fully managed low-cost analytics data warehouse. So you can say here that Google has mastered this storage domain and no one can defeat them here. Now, reason number 4 is pricing. This is another domain where Google is way ahead than other cloud providers. They have no upfront cost required to set up an account or use these services. They also provide lots of free credits to explore these services. On an average, it is 60% cheaper as compared to the other cloud providers. Plus, if you use the services for a longer period of time, Google also provides discounts. The billing is done on a per second basis, which is how a cloud service should work. Now, finally, the most amazing feature is the price calculator, which you can use to find out the estimate of the services that you are going to use, so that there aren't any shocking bills or invoices later. So coming down to the top 3 reasons, at number 3 we have scalability. You can easily scale up or down your machines depending upon your requirements. Everything is made simpler by Google. Plus, the Google VMs are auto-scalable. They have autoscaler which scales up or down your instances according to the traffic it receives, all along saving money for you and making tasks simpler as well. Now, this is really a cool feature as it decreases the overhead and also the engagement effort required for this job. At number 2, we have the certifications. Now, Google provides lots of certifications that are very important and very useful if you are looking for a good certification in the cloud department. They provide 4 types of cloud certification, which are the Professional Cloud Architect, the Professional Data Engineer, the G Suite Administrator, and the G Suite. Now, these certifications are very good for people who are working in the cloud industry. Apart from these certifications, they also provide the Google Qualified Developer certifications. So in order to get certified, you need to clear these 4 exams, which are the App Engine exam, the Cloud Storage exam, the Compute Engine exam. Now, clearing all these exams will certainly provide you with an upper hand over the others while applying for a job anywhere. Now, coming down to our top reason, come on, it's Google. We all know how big is the database of Gmail, YouTube, and the Google search. And I don't think in the recent years, Google server has ever gone down. It is one of the biggest company in the world, and their worldwide network is phenomenal. You get everything you expect from Google, its reliability, scalability, their infrastructure, and lots more. You get everything under one roof, and managing services is really, really easy. You can think of it as working alongside the world leaders in innovation and technology. So as I mentioned earlier, they are so cost effective and reliable. And also they are serverless, which means you do not need to manage the servers. Everything is taken care of by Google. And most importantly, being a little new to this cloud market, their annual growth rate are off charts already, and it's over 100%. Now you can also relate it to the amount of services provided by Google for its normal Gmail users, which is YouTube, the Google Mail, the Google Drive. We have Maps, Sheets, Translates, Hangouts, and the list goes on and on. So you need not worry about the quality of the services provided by Google.
Who is a Google Cloud Architect? A Google Cloud certified professional cloud architect enables organizations to leverage Google Cloud technologies. Through an understanding of Google technology and cloud architecture, the individual designs, develops, and manages robust, secure, scalable, highly available, and dynamic solutions to drive business objectives. The cloud architect should be proficient in all aspects of enterprise cloud strategy, solution design, and architectural best practices. Also, the cloud architect should be experienced in software development methodologies and approaches, including multi tiered distributed applications which span multi cloud or hybrid environments. Now that you have understood who is a Google Cloud Architect, let's understand why there's a need for a Google Cloud Architect. First of all, let's look at the market trends for Google Cloud Platform. If you see for the first pie chart, in this you can see like the data is for quarter one of 2021, where we can see the top three cloud service providers. Like the first one, you can see the AWS for 32% market share, and then Microsoft Azure for 19%, and Google Cloud for 7%. And then there are various others and like a lot of cloud service providers, which constitutes to 42% of the market share. Now, if you see, AWS is actually the biggest cloud player because it was launched like way back in 2004, and after that Microsoft Azure, and then after that Google Cloud in 2010 was launched. But if you see, like initially it wasn't that much growing, but if you see in the last 3 years, if you see this second graph from quarter 1 2018 to quarter 4 2020, you can see that AWS has 28% surge in market, and then Azure has 50%, where Alibaba Cloud has 54%, and the highest you can see is of Google Cloud, which is 58%. And Google Cloud is that's how grabbing the market like aggressively. It's because of its various services like ML and AI also, and of cloud AI, like various BigQuery services. These are like the unique services which Google Cloud provide. We will talk about it later on. Okay. Now let's talk about the need of Google Cloud Architect certification. So Google Cloud certification validate your expertise and showcase your ability to transform with Google Cloud technology, and it enables organization to leverage Google Cloud technologies. Also, like 87% of the Google Cloud certified individuals are more confident about their cloud skills. And Professional Cloud Architect was the highest paying certification of 2020 and 2019. More than 1 in 4 of Google Cloud certified individuals took on more responsibility or leadership roles at work. Also, one of the major factor of a Google Cloud Architect certification, it helps in getting the candidate shortlisted in the company which is looking for a cloud architect. So this, first of all, they what they see in a resume is whether you have a Google Cloud Architect certification or not. If you have it, then you will get shortlisted for sure. That's the major needs of a Google Cloud Architect certification. Now let's look at the job trends for Google Cloud Architect. So if you look at the IT sector, 86% of the enterprises have more than a quarter of their IT infrastructure running in cloud environments. And according to the study done by Gartner, the public cloud services market will like hit about $331.2 billion by 2022. And 52% of the enterprises spend more than $1.2 million annually on public cloud, as well as 26% of the enterprises spend more than $6 million, which is like really huge. Now let's look at the salary or say pay scale for a Google Cloud Architect. So according to global knowledge, the average pay for a Google Cloud Architect in India is 15.3 lakhs, whereas in US it is 175,000 US dollars, which is, you can understand, like a very high scale salary has been provided to Google Cloud Architects. Now let's understand why Google Cloud Platform is in great demand. We all know how big the database of Gmail, YouTube, and Google Search is, and I don't think in recent years Google server has gone down. It's actually one of the biggest in the world. So it seems an obvious choice to trust them, right? So now let's look at what really gives Google Cloud an upper hand over other vendors. So first of all, the major advantage Google Cloud has is of Google Cloud's IoT core. which is a fully managed service to easily and securely connect, manage, and ingest data from globally dispersed devices. Also, Google Cloud has a better pricing than its competitors, which means it's cost effective. Third, due to serverless computing, it is highly available and fault tolerant. With Cloud AI, Cloud Functions in GCP is the easiest way to run your code in the cloud integrated with machine learning technologies. Also, it is highly scalable as it uses auto scaling to automatically adjust the number of virtual machine instances that are hosting your application. So, what it does is it allows your application to adapt to different varying amounts of traffic. Lastly, Google Cloud Smart Analytics solutions are fully managed, means big data analytics solutions. This multi-cloud analytics platform empowers everyone to get insights while eliminating constraints of scale, performance, and cost. It uses real-time insights and data apps to drive decisions and innovation. Now let's look at the job description of a Google Cloud Architect. So you can see here the job description of a Google Cloud Technical Architect of Accenture company, and the location you can see is Gurugram, Haryana. So now let's understand what type of work will be required by the company and what skills will you be performing on a regular basis. So the work experience, first of all, is required 4 to 6 years, a minimum of 4 years of overall hands-on experience in programming and data structures. Then strong cloud expertise in delivering data solutions, especially like database services and big data services on the Google Cloud platform. Also, Google Cloud Architect should be experienced in integrating cloud native services. Cloud native services are the like unique services for that particular cloud service provider. Means unique services which are in Google Cloud platform. The Google Cloud Architect should know about it and should know how to work on it and how to execute and make an output through it. So Google Cloud Architect should be like integrating cloud native services into secure, efficient, and scalable solutions. Also, Google Cloud Architect should know how to design data pipelines using cloud native data technologies. Means cloud native data technologies can be like storage accounts, Cloud SQL, Bigtable, BigQuery, Dataflow, Dataproc, etc. Also, the Google Cloud Architect should have a deep knowledge of RDBMS as well as of NoSQL for like database programming and other non-technical or say professional attributes that the Google Cloud Architect should carry is analytical thinking and attention to details, good time management skills, and the ability to work to tight deadlines, and then capacity to work under pressure. These all things are required by a Google Cloud Architect. You can see the emphasis as the main of data solutions, cloud native services, data pipeline, and cloud native data technologies, also of RDBMS and SQL. Now let's understand the roles and responsibilities of Google Cloud Architect, which he performs on a daily, weekly, or monthly basis. So the Google Cloud Architect should know how to design and deploy applications on Google Cloud Platform, which are dynamically scalable and available, fault tolerant, and also like it should be very much reliable and secure as well. Also, if the Google Cloud Architect is going to deploy an application, then he should know what kind of Google Cloud services should be used for it for that kind of a deployment based on the given requirements. Especially, he should also know like how to migrate application, also like multi-tier applications, say the databases and a heavy database also on Google Cloud Platform. One more thing is he should make a strategy of how to work on Google Cloud Platform with the most optimization and cost saving techniques, and he should also know how to coordinate if there are new things are coming. He should be easily adaptable to the changes. Okay. Also, he should know how to implement multiple Google Cloud services and use multiple products of Google Cloud platform in a way that it shouldn't cost much to the company or say organization. That means he should be well aware with the cost optimization techniques in Google Cloud platform. Now let's understand the skills required by the Google Cloud Architect. So first of all, let's see the programming skills required by the Google Cloud Architect. So he should have an hands-on experience of SQL as well as NoSQL, which are like majorly required for database programming and database migration and for querying purposes. He should also know the Python programming language, maybe not to the expertise or in very advanced level, but at least at an intermediate level, so that he can create, analyze, and organize large chunks of data. As well as it's very useful for using ML and AI products like natural language processing and means natural language understanding and auto ML products. For these purposes, Python is very much required. Also, for the application development purposes, he should know the Java programming language. Also, for web development purposes, he should carry a good knowledge of HTML, CSS, and JavaScript. Now, let's see the operating systems, which the Google Architect should be well aware of and should have a good knowledge of, like Linux, Solaris, Ubuntu, Windows, Unix. But preferably, I would say he should have a good knowledge of Linux as it brings the features like open source, security, customization, and is adopted by different cloud platforms as well. He should also have a very good knowledge of security and identity fundamentals in Google Cloud Platform, like identity and access management, like how to provide certain access management to certain users. If an employee is working under him and if he is handling any team, then he should know what kind of access he should provide to that person, to that employee, I mean, and what are the roles and policies of identity and access management. Also, you should be well aware of cloud compliance techniques. So, cloud compliance is like the principle that cloud delivered systems must be compliant with the standards their customers require. And cloud compliance ensures that cloud computing services meet compliance requirements. Lastly, he should be well aware of data privacy. If he is uploading any data on cloud or if he is extracting any data from the cloud, import, export, everything. So, he should be well aware of the data privacy and how to protect and secure data from exploitation. So Google Cloud Architect is also required to have a good knowledge of networking as well. Means networking in Google Cloud Platform. Like you should have a very good knowledge of Cloud CDN, which is a cloud delivery network for service web and like video content, and also of Cloud DNS, which is a domain name system for reliable and low latency name lookups, as well as of hybrid connectivity options for VPN, peering, and enterprise needs. On a whole, Google Cloud Architect should know how to design networking ways to make sure the network is responsible to user demands by building automatic adjustment procedures. Lastly, he should be very well aware of cloud storage techniques in Google Cloud Platform and especially like usability and accessibility through cloud storage, how easily cloud storage can be used and accessed. Secondly, he should ensure the security for storage. If he is storing any data, he should be ensuring that how he can use security techniques to secure the data. And whatever services he is combining with cloud storage, it should be cost efficient, as well as the service he is using, like cloud storage service, if he is using, he should be able to optimize it in a way that it should cost the least to the organization. As well as he should be using it that it's very portable or you can say like very easily usable, so that will be convenient for the organizations and for the client. Also, he should know how to automate the data he is storing in cloud storage, and the data should be synchronized with the multiple devices, or we can say with the lead device of the organization. And also, he should be well aware of the disaster recovery in cloud storage, so that if the data gets lost, then it can be backed up later on. Now, when we come to data storage, so there are like four types of storage. So the first is standard storage, which is good for hot data that's accessed frequently, including websites, streaming videos, and mobile apps. Second is nearline storage, which is like for low cost, good for data that can be stored for at least 30 days, including data backup and long tail multimedia content. Then there's cold line storage, which has a very low cost, good for data that can be stored for at least 90 days, including disaster recovery. Then there is archive storage, so which has a lowest cost, good for data that can be stored for at least 365 days, including regulatory archives. Now, these are the non-technical skills required by the Google Cloud Architect, that he should be flexible in working and he should have leadership skills as well to lead a team, and he should be business oriented, that how to profit the organization. If he is working on any project or something, he should know that how to extract out the maximum leads, or you can say the maximum profit for the business. Also, he should have very good communication skills so that he can lead a team or he can connect multiple teams or he can easily handle the clients as well. Now, let's understand how one can become a Google Cloud Architect. For becoming a Google Cloud Architect, you should know Cloud Native Services, means which are the unique services, you can say like Firebase, Firestore, App Engine, or Google Kubernetes Engine, Cloud Run. You should have a good hands-on experience, or say a very deep knowledge of these Cloud Native services. Also, you should be well aware of database programming, like both SQL and NoSQL, so that you can handle SQL databases as well as NoSQL databases. Like there's a Cloud SQL, and then there is a Cloud Bigtable, Firestore, also like Memory Store, Cloud Spanner. All these are database services provided in Google Cloud Platform. Also, you should be well aware of big data solutions, so that big data services in Google Cloud Platform can be easily managed, like BigQuery and Dataproc or Cloud PubSub or Dataflow. These all big data solutions you should be well aware of. Also, you should carry very fine analytical skills. Also, you should be well aware of application development. Like you can use App Engine in Google Cloud Platform for developing the applications. for deploying purposes also. Also, you should know the automation process in Google Cloud Platform. Like there is a free Google Cloud Platform automation software from Park My Cloud. So Park My Cloud is a tool for scheduling non-production instances on Google Cloud Platform that helps companies reduce their cloud computing costs, also improve their IT governance, increase accountability, and optimize their cloud computing resources as well. Also, you should be well aware and have a good knowledge of DevOps products and integrations so that you can build and deploy new cloud applications or store artifacts and monitor app security and reliability on Google Cloud. There is a cloud build and artifact registry. Like cloud build, you can say it defines custom workflows for building, testing, and deploying across multiple net environments. And artifact registry is used for storing, managing, and securing your container images and language packages. All these things you should be well aware of. Also, you should be flexible enough to work in a fast-paced environment as well. Also, you should be well aware of the compute services as well. Like there's Compute Engine where you can run virtual machines in Google's data center, and also there is a Google App Engine, which is a serverless application platform for apps and backends. Also, like cloud GPUs and preemptible virtual machines and shielded virtual machines, you should be well aware of, and should also have a hands-on experience also. Other than that, there are also ML and AI services, which is very unique in Google Cloud, and Google Cloud is actually famous for its ML and AI services. So that is something you should be you should have a deep knowledge and a hands-on experience, and you should really be well aware of it. So you can see there are certain services like Auto ML, Vision AI, and there's cloud translation for language detection, translation, and there is a cloud natural language for sentiment analysis, and video AI is also there for video classification and recognition. This is for deep learning. All these things, this is something you should have an hands-on experience and you should know really, really well. This is what companies are targeting for. Then lastly, you should know how the Google Kubernetes Engine work, and you should know about the architectural working of Kubernetes Engine. So there are two modes of Google Kubernetes Engine, means there are two modes of operation in Google Kubernetes Engine. They are standard and autopilot, and there's also podding, cluster auto scaling in it, and there is pre-built Kubernetes applications and templates are also there. Also, a container native networking and security is also being provided by GKE Sandbox, means Google Kubernetes Engine Sandbox. So these are some of the concepts you should be well aware of. Other than that, you should also have a very good communication skills to handle clients and handle teams and multiple teams as well. Now let's see the Google Cloud certification provided by Edureka as well. So you can see how I have explained you step by step. Google Cloud certification training is designed to meet the industry benchmark. It's of course the industry relevant course, and then there are multiple batches for it. Right now there is a July 31st batch which is filling fast. There is also August 28th batch. They are monthly batches. You can register for them. As I have explained you step by step how Google Cloud certification is needed and why you need to be certified Google Cloud architect. You can see I have explained you compute services for virtual networks, all these things, and compute services and security and identity fundamentals. As I've explained you, the identity and access management and cloud compliance and data privacy things. Other than that, data storage services, and these are the fundamentals. These services you should actually be knowing, and how where you should implement these services for what requirement. This is how the industrial event Google Cloud Platform Architect course is being constructed by Edureka, and it can surely help you in also cracking the Google Cloud Platform exam that we are going to talk about. Then there's, you can see I have explained you DevOps, automation, everything I have explained you. So as I have told you how these services are very much important, and these are the services you should target for. So you can register for Edureka Google Cloud Platform Architect certification. So this was all about how to become a Google Cloud Architect. Now let's understand how to crack Google Cloud Architect exam. If you don't know much about Google Cloud Architect exam, it is valid for 2 years and it's a 2-hour exam. When you are prepared for it, you can actually apply for it. That you can look at the documentation part of a Google Cloud platform. For cracking Google Cloud Architect exam, you should know how to design and plan a Google Cloud solution architecture, like designing a solution infrastructure that meets business requirements, and consideration for that includes business use cases and product strategy, cost optimization, supporting the application design, integration with external systems, movement of data, as well as design decision trade-offs and build, buy, modify, or depreciate. Also the compliance and observability as well. Other than that, designing a solution infrastructure that meets technical requirements like high availability and failover design, scalability to meet growth requirements, and performance and latency. And while designing in network storage and compute services, you should consider integration with the on-premises or multi-cloud environments, choosing data processing technologies as well, and choosing compute resources and mapping compute needs to platform products. Then also creating a migration plan, that is documents and architectural diagrams, for which the considerations include integrating solutions with existing systems, migrating systems and data to support the solution. Also for software license mapping and network planning, also depending management planning, and envisioning, especially envisioning future solution improvements, considerations for that include cloud and technology improvements and evolution of business needs and evangelism and advocacy. Second thing is you should know how to manage and provision a solution infrastructure. So for that, you need to configure network topologies, and you should consider extending to on-premises environments and extending to a multi-cloud environment that may include Google Cloud to Google Cloud communication. So one more thing is there while configuring network topologies, that is security protection. Also, while managing and provisioning a solution infrastructure, you should configure individual storage systems, and you should consider data storage allocation for that and data processing, as well as compute provisioning and security and access management, as well as data growth planning. Also, you should configure compute systems as well while managing and provisioning, and you should consider compute resource provisioning for that and compute volatility configuration as well. The third thing is you should know how to design for security and compliance. While designing for security, consider identity and access management, also resource hierarchy and data security, and separation of duties and security controls like auditing VPC, service controls, etc. And also managing customer managed encryption keys with cloud key management services and remote access as well. And second thing under designing and security of compliance is designing for compliance. For that, consider legislation and commercial as well as industry certifications and audits as well, including logs. So the fourth step is analyzing and optimizing technical and business process. So while analyzing and defining technical process, consider software development lifecycle and continuous integrations or continuous deployment, as well as troubleshooting and testing and validation of software infrastructure. Other than that, service catalog and provisioning and business continuity and disaster recovery as well. Second step is to analyze and define business processes. And for that, you need to consider stakeholder management, change management, team assessment, decision making processes, customer success management, cost optimization, resource as well. Third thing under analyzing and optimizing technical and business processes, developing procedures to ensure reliability of solutions in production. Like you can take, for example, chaos engineering and penetration testing. Fifth step is managing implementation. So that can be done by advising development or operation teams to ensure successful deployment of the solutions. And for that purpose, you need to consider application development, API best practices, test framework, and data and system migration and management tooling. So implementation can be managed also by interacting with the Google Cloud programmatically. And for that, you need to consider Google Cloud Shell, Google Cloud SDK, also cloud emulators, means Cloud Bigtable, Data Store, Spanner, PubSub, and Firestore as well, etc. So the last step is ensuring solution and operations reliability. And for that, you need to consider monitoring, logging, profiling, alerting solutions, as well as deployment and release management, assisting with the support of deployed solutions and evaluating quality control measures.
What is Google Cloud Platform? Now, Google Cloud Platform is basically the cloud computing suite offered by Google. So, this suite basically consists of various cloud computing services that run on the same infrastructure as all the other Google services run on. Like, for example, let's say Google Search, Gmail, and YouTube. All of these services internally have certain structures and certain services that they run on. And Google Cloud Platform has enabled us to basically use the same services that they use internally, right? So next up, we come to various products and services that Google Cloud Platform has to offer. Now, there are various products and services such as compute, storage, networking, big data, and machine learning. So out of the compute products and services that there is Compute Engine, the Kubernetes Engine, the App Engine, and the Cloud Functions service. When it comes to storage, Google Cloud Platform offers its users the Cloud Bigtable, Cloud Storage, Cloud SQL, Cloud Spanner, and finally the Cloud Data Store. When we're talking about networking, there are various services that are there, such as the Cloud Load Balancing, Cloud CDN, Cloud DNS, Cloud VPN, and finally the Cloud Interconnect, right? And when it comes to big data, there are services such as BigQuery, PubSub, Dataflow, etc. And finally, we have the machine learning services such as the Cloud ML, the Vision API, the Google Text to Speech API, and other such services, right? So these are the various products and services that are present in Google Cloud Platform. Next, we talk about Google Cloud Free Tier. Now, free tier is basically something that is accessible to users, which allows users to use various services free of cost for a certain time limit. Now, there are over 20 free services and there is $300 in free credits for every user. Some of the services are the Compute Engine. Now, the free tier limit for Compute Engine is 1 E2 micro instance per month. Next, we come to cloud storage. Now, free tier limit for cloud storage similarly is 5 GB month standard storage, right? So for each month, there is 5 GB free storage with Google Cloud Storage. Next up, we have BigQuery. Now, with BigQuery, it basically allows you to have 1 TB queries per month. And it being a big data service, it has to have a lot of queries and a lot of analytics and insights every month. So it allows every user 1 TB queries per month. And then we have basically the Cloud Kubernetes Engine. And this Cloud Kubernetes Engine will basically have a free tier limit for one autopilot or one Zodon cluster per month. So these are the basic free tier limitations for some of the services that are present in Google Cloud Platform and the basic gist of what Google Cloud Free Tier has to offer its users. Next, we come to creating your own Google Cloud account. So basically, when you type Google Cloud Platform on Google, you get something like this. Go on the first link, and this is what you get. Now, what you need to do here is just click on Get Started for free. So basically, when you click on this, you'll get this page, and here it asks some basic information for you, like your country and what you need to do. Now, if you need organizational needs, or mid-sized company, or is it your own personal project, so you want to basically say something like that, and just click on continue, and basically just go ahead, add your number and click on continue again, right? So what you have to do here is just add your method of payment. Now this is the part where you have to basically add the payment information, and let's just say put the card details in here, right? And just select these. So basically, once you've done with your card details and you've made the transaction, there'll be 2 rupees deducted from your account. That is basically the basic amount of money that Google has to make for verifying that it is you who's basically making the transaction. And so finally, when you've actually made the payment, what you can see is you can log into the console, and this is what the dashboard looks like. And what you can do here is you can go to APIs and services, go to library, and check out the various services that Google Cloud Platform has to offer. Let's check out, let's say, for example, Compute Engine. Right. So this is a Compute Engine API, and I can just manage this and try and enable this. So what you have to do basically is try and enable any API that you use, and that is how you basically use Google Cloud Platform in general, and this is how you create your Google Cloud Platform account. What is Google Cloud Functions? Now, when we talk about Google Cloud Functions, we need to know that Cloud Functions is an API which is provided by Google Cloud Platform. So this is basically a serverless execution environment for building and connecting cloud services, right? So it's scalable and pay as you go. So you need to only pay for the amount of time that you use the function for. So it is basically a function as a service that is provided by Google Cloud Platform, which allows you to pay as you go, which basically means that you only have to pay for the amount of time and the amount of data and resources that you use for your cloud functions and nothing extra. Next, we talk about the fact that you do not need to configure the software and manage the servers as well. It is basically allowing you serverless management, and you can basically integrate single purpose functions with other events and APIs as well. So this is basically a brief overview of what Google Cloud Functions is. Next, we talk about the different kinds of cloud functions that are present. So there are basic two different kinds of cloud functions present, namely API cloud functions and event-driven cloud functions. So basically, API cloud functions are invoked from standard HTTP requests. Event-driven cloud functions handles events from the cloud infrastructure and basically can be invoked apart from HTTP requests as well. Then we see that the TLS certificate is automatically provisioned to invoke securely, which is basically for API cloud functions. Now, when it comes to event-driven cloud functions, it is divided into background functions and cloud event functions. Now, these are the two basic types of cloud functions. Next, we see the basic infrastructure of cloud functions. We see that the event providers provide you with a trigger, which then goes and gets stored in the data, and this trigger will then send you a response according to your function that you have, and that is basically how cloud functions work. Okay. Next up, we see why use cloud functions at all. Now, here we talk about most of the things that are the features of cloud functions, or why do we need them at all? What does cloud function have to provide us with, right? So the first and the most important thing we see is that you do not need server management. No server management is necessary, or containers as well, to run or deploy your code. Next, we see that configuring software is extremely important. So you can configure cloud functions, built-in configuration options to control the behavior of your functions. So you can basically configure it based on whatever you feel like is the best for your function. Next up, we see the automatic provisioning of resources. Now, the user does not have to provision resources manually. Cloud functions automatically provisions resources for your cloud function, right? So next up, we talk about the simplified developer experience that Google Cloud Functions provides us with. Now, Cloud Function has a simple and intuitive developer experience. Just write your code and let Google Cloud handle the operational infrastructure. So you do not need to think about all the operational infrastructure that is there. You just have to write your code and basically develop faster by running small code snippets that respond to various events that Google Cloud Functions provides, right? Next up, we see that it is a pay-as-you-go model. So you are only built for the function's executing time metered to the nearest 100 milliseconds. So basically, you pay nothing when your function is idle, right? So Cloud Functions automatically spins up and back and down with the response to events. So basically, whenever you use your function, that is the only time where you are charged, and you are not charged if your Cloud Function is inactive. And finally, we see that you can avoid lock-ins. So basically use open source FAS, which is basically function as a service framework, to run functions across multiple environments and prevent lock-ins. Supported environments include cloud functions, local development environment, on-premises, etc. Right? So you can avoid lock-ins using cloud functions with open technology. So this is why you should use cloud functions and the various features it's providing. Next up, we talk about the integration with other APIs that Cloud Functions has. So the first integration we talk about is the BigQuery integration with Cloud Functions. So BigQuery remote function will let you create a BigQuery SQL functionality and software outside BigQuery with the help of Cloud Functions, right? So the serverless execution environment basically allows BigQuery to do this and make remote functions as well. So this is one of the integrations that Google Cloud Functions has. So next up, we talk about the integration with Firebase. Now, Google Cloud can be integrated with Firebase, provided that basically you use it for the serverless framework and it lets you automatically run backend code in response to events and triggers. So these triggers are provided in the format of HTTP requests or API requests or something like that. So basically what Firebase does with Google Cloud Functions is that you can interact with Firebase using HTTP triggered cloud functions, right? So this basically requires the first kind of cloud functions, that is the API kind of cloud functions, not the event-driven ones when it comes to interacting with Firebase. So next up, we talk about Vision API integration with cloud functions. Cloud Vision API is another API that provides us with facial recognition and photographic recognition, optical character recognition, and all of that. And if you want to check out more on Cloud Vision API, you can check out Edureka's video on Vision API as well. Now, when it comes to cloud functions with Vision API, we can see that when it comes to optical recognition of characters, which is basically something that in layman terms can be explained as reading the text that is present in images and then printing that out, right? So you can basically read whatever image that you have, and if it has some sort of text, optical character recognition will basically print that text out to you, right? So this is what Vision API integration with Cloud Functions is used for. Next up, we come to the pricing of Google Cloud Functions. So when it comes to pricing, we can see that pricing is based on various things such as invocations per month and the price per month. So for the first 2 million invocations, the price is free. And if you go beyond 2 million invocations, the price is $0.40 per month. So apart from all of this, we can see that pricing is also based on the compute time provision, the price per 100 millisecond, and the virtual CPUs present. So 128 MB compute time will be priced at around $0.0000231, whereas virtual CPUs required will be 0.0833, right? So similarly, it is exactly the double of what 128 MB needs for 256, right? So the virtual CPUs required in the 256 MB compute time provision will be 0.1666 virtual CPUs required. So next up, we see a demo on Google Cloud Functions. So I have a GitHub repository with Python code which will go for Google Cloud Platform, and let's just copy this repository and try and include it on our system, on our local system. So to do that, what you need to do is git clone and copy that here. So you can see that this repository is already cloned in my system, and all I need to do is find the path for it. So let's go search for the path for it. And this is basically my path for my repository. Just copy this path. So once you copy that path, basically all you have to do is cd and paste that path here, and you will basically go into your directory, right? So this is how you change the directory. Now once you've changed the directory, you can see that your file that you've downloaded, the GitHub repository that you've downloaded, has various files in it. So what you need to do is open up the Python file into your VS Code, right? So open up the Python file in your VS Code, and as you can see, this is the Python file, which is the app.py, and this is the main function, which is the main.py, right? So what you need to do now is test it on your local system, right? So you have the Python file, you have the repository, all you need to do is run Flask, right? So this is basically running. Let's try it out again, just one last time. Right, it is running on this local machine, local host, right? So what we need to do is let's check it out. So go to Postman, and Postman basically allows you to see that if your HTTP triggered functions is working. Right. So when you go to Postman, you basically type in this trigger that you have, the URL, which is basically this. It's running on this localhost. You can just go back to Postman, copy paste this to this, and you can see hello world out here. So this is running on my local host. Now let's try doing this on Google Cloud Functions, right? So once you go to Google Cloud Functions, you can basically just open up Cloud Shell, and since you now have the GitHub repository in your system, you can just check the directory. So this is the directory that we have, and our repository is called Python doc samples, right? So Python doc samples. So we can just move into the Python doc samples part, and now we're in. We'll check out the files in here, and now we need to do is go into the repository with the code, right? Now, once you've moved into the repository with the code, check out the files in it and move into the folder with the function in it, and check out the repository again. Move into Python part. Now you moved into Python part, check out the repository, and you have main.py here, right? So once you've found your main.py file, what you need to do is basically create a function with a trigger, an endpoint, and all of that. So just this is basically the code for creating a cloud function with the runtime, the trigger, and the unauthentication specified. So what happens if you basically do not specify that unauthenticated functions will be available is that every cloud functions that you create will be authenticated if you don't disallow authentication in general. So let's just try deploying this, and it will basically ask you for authorization. Right. So it is deploying. Now this basically takes a bit of time for you to deploy a cloud functions, maybe around 2 to 3 minutes. Right. So once you've deployed your cloud function, you can go check it out on this URL, right? So this is basically showing me hello world right now. This is an HTTP triggered cloud function that allows you to take arguments in. So what we can do is we have our code here, and if you go into the app.py thing, we can see it is hello name, right? So let's just go back to Postman here and try something out. So what we will be aiming to do here is that we'll be aiming to change the arguments that we give in and see if our HTTP triggered backend is still working. So these are not, let's say, if you go back to this, so this is not really a web page. This is basically a serverless backend, right? So this is the basic difference. And let's check it out on Postman now. Right. So Postman is up, and all we need to do is take in this, put it in here, and check if it's working. Right. So right now it shows me hello name, but this is a function which allows you to take in arguments. So let's just give it an argument like name, and this can be Edureka, right? So let's just check it out now. So basically what happens is, if we can see, this is the argument that we gave in, and go back to Postman, change this and paste this, change it. It says hello Korak because I've put in arguments here which has name and value of Korak. Now let's change this to, let's say, Edureka, and check if it's still working. Right. So it is working, and this is basically how you create an HTTP triggered cloud function. Now, with that, we come to the end of the demo. So the last thing we talk about is the different use cases that Cloud Functions has with different integrated APIs. So we'll be talking about two use cases here. So the first use case we talk about is the real-time stream processing. Now real-time stream processing is PubSub will basically trigger a function. Now this function will basically process the uploaded image and detects the offensive images if they are there. Now, this offensive image detection is done using Google Cloud Vision API, and if there is some offensive content, Google Cloud Vision API sends a Cloud Function a request to blur the image out, and this is then stored as a blurred image in storage. And finally, we talk about sentiment analysis. Now sentiment analysis is basically understanding the requirements or the behavior of the user in general. So basically what we do here is we see a text message, and with that text message we use Twilio, which is basically a chat SDK. And with Cloud Functions, BigQuery and MLP, what it basically does is that it adds sentiment analysis and intent extraction capabilities to your application. Right. So there is a lot of natural language processing involved here. So there is an integration with BigQuery and NLP API as well.
So you might be thinking what an app engine is. So let's have a little introduction to App Engine. It is a fully managed serverless platform for developing and hosting web applications at scale. You can choose from several popular languages, libraries, and frameworks to develop your apps. Then let App Engine takes care of provisioning servers and scaling your app instances based on demand. Now let's understand App Engine service provided by Google Cloud Platform, that is Google App Engine. If I talk about Google, then we all know that it provides an enormous range of tools, products, and services. In the running market, Google has scored high percentile and left a footprint in the list of world's top 4 companies. So Google App Engine, by the name only we can recognize that Google has created an app engine. The name is similar to a search engine, but its purpose is of course different. App Engine is a service and cloud computing platform employed for developing and hosting web applications. It is a platform as a service cloud computing platform that is entirely managed and utilizes inbuilt services to drive the apps. Once after downloading the SDK, that is software development kit, you can instantly start the development process, but for this, it is mandatory to use technical knowledge. If you don't know the technical terms, then there is no need to take tension, okay? As there are many IT industries in the market that are providing Google App Engine development services. App Engine lets you build highly scalable applications on a fully managed serverless platform. Also, you can scale your applications from 0 to planet scale without having to manage infrastructure, okay? Also, you can free up your developers with zero server management and zero configuration deployments. You can even stay agile with support for popular development languages and a range of developer tools with Google App Engine. Now let's look at some key features of Google App Engine. If you see the programming languages, the platform supports PHP, C, Java, Python, Go, Node.js, .NET, and Ruby applications. And apart from this, it also supports other programming languages through custom runtimes. The App Engine serves 350 plus billion requests per day. Now, if you see like how Google App Engine is actually open and flexible, so custom runtimes in Google App Engine allows you to bring any library and framework to App Engine by supplying a Docker container. So you can customize runtimes or provide your own runtime by supplying a customer Docker image or Docker file from the open source community. Then you can see like Google App Engine is actually fully managed. So Google App Engine's fully managed environment, which makes it easy to build and deploy an application that runs reliably even under heavy load and with large amounts of data, and which lets you focus on code while App Engine manages infrastructure concerns. Let's now see the architecture of Google App Engine. So this is how a simplified architecture looks like. Among the main services and structures available are Google Load Balancer, which manages the load balancing of the applications. Then we have Front-End App, which is responsible for redirecting requests for appropriate services. Then we have Memcache, that is a cache memory shared between instances of a Google App Engine, generating high speed in the availability of the information on the server. And task queues is used, which is like task queues. If you see, that is a mechanism that provides redirection of long tasks to backend servers, making front-end servers free for new users requests. In addition, Google App Engine also has static and dynamic storage solutions. The static storage solution provides the file storage service called Cloud Storage, whereas the dynamic storage solution provides relational database services such as Cloud SQL and no relational NoSQL such as Cloud Data Store. Now let's see the development cycle of Google App Engine. Here, if you see, test, build, and deploy is the software development kit, means SDK. So SDK is a set of software development tools that allows the creation of applications for a certain software package, software framework, hardware platform, computer system, video game console, also operating system or similar development platforms. The next one in the cycle is manage, which is an app engine administration control. And then we have upgrades, like all the updates are being provided for deployment to software development kit. Now let's look at the components of an application. The App Engine application is created under your Google Cloud project. When you create an application resource, the App Engine application is a top level container that includes the service, version, and instance resources that make up your app. When you create your App Engine app, all your resources are created in the region that you choose, including your app code, along with a collection of settings, credentials, and your app's metadata. Each App Engine application includes at least one service, the default service, which can hold many versions depending on your app billings status. The following diagram illustrates the hierarchy of an App Engine application running with multiple services. In the diagram, the app has two services that contain multiple versions, and two of those versions are actively running on multiple instances. So let's understand service inside is. So you can use services in App Engine to factor your large apps into logical components that can securely share App Engine features and communicate with one another. Generally, your App Engine services behave like microservices. Therefore, you can run your whole app in a single service, or you can design and deploy multiple services to run as a set of microservices. For example, an app that handles your customer request might include separate services that each handle different tasks, such as API requests from mobile devices, internal administration type requests, backend processing such as billing pipelines and data analysis. Each service in App Engine consists of the source code from your app and the corresponding App Engine configuration files. The set of files that you deploy to your service represent a single version of that service, and each time that you deploy to that service, you are creating additional versions within that same service. Then we have versions. Having multiple versions of your app within each service allows you to quickly switch between different versions of the app for rollbacks, testing, or other temporary events. You can route traffic to one or more specific versions of your app by migrating or splitting traffic. Then we have instances. So the versions within your services run on one or more instances. Okay. By default, App Engine scales your app to match the load. Your apps will scale up the number of instances that are running to provide consistent performance, or scale down to minimize idle instances and reduces costs. For more information about instances, see how instances are managed. Okay. I will explain you that in the demo. So now that you have a theoretical understanding of Google App Engine, let's implement a simple app through Google App Engine. So you can just go to Google Cloud Platform, open it. We have console and we have documents also. Open the console also. Yeah, remember that if you don't have an account on Google Cloud Platform, it's a very good platform to have your account on. Just create your account. It will ask for your some basic details of your name and phone numbers and address, and it will also ask for your credit and debit card details. It will just deduct ₹1, and that will also be refunded within a while. And free trial, you will get $300 credit for 90 days, and you can use that credit for, like, I'm showing you some exercises inside Google App Engine. You can perform those exercises using those credit. Okay, so you can just we have opened the dashboard, and let's go to the documents part. Inside this, we have to go to the compute product. Under compute, we have App Engine. So here it is, compute App Engine. Then go to standard environment, to Python. We are going to implement a simple app of Hello World using Python. Quick start. These are the table of contents for how we are going to implement the app. Okay. So inside this, the first step is you have to create a project in Google Cloud Platform. This is how the dashboard of Google Cloud Platform looks like. And you go here. This is the demo, means it's written because that's the name of my project. These are the same number of projects have been here, but you can also go to new project and create. Okay. So let's go to here. Second step is, remember, when you are creating the project, ensure that billing is enabled for that. Okay. Then the third step is just open it from here, enable the API, open this and just enable the API. Then we just remember the next step, additional prerequisites, it's not required. Okay. So yes, then we go to the Hello World app. So what we have to do is we just have to go to the App Engine here. Remember, I explained you the application components inside which we have services, versions, and instances. This is the same thing. When you create an app, the services will be provided and the versions will be created, and also the instances will be created for that. So what we have to do is just open the Cloud Shell from here, activate Cloud Shell. So what we have to do is go to the documents part. Remember this, these steps are here. Download the Hello World app. Yeah, how we have to implement it? You have to copy this. You have to clone a GitHub repository. Okay, inside which the Hello World program is already present. So yeah, just have to clone it. So just paste it here. Just enter. Then we can go to the editor here. So yeah, we have to go to the Hello World program. So we have to go to the Python docs samples. Then we have to go inside this to App Engine, then to Flexible, and then the Hello World program. Where is yeah, Hello World. Yeah, in Hello World we have main.py. Yeah, this is the Python program. All the we are going to use Flask for it. So using Flask we are creating this. You don't have to code of it. We can just use it like this only. It's just a simple demo. And then we have app.yml file with all the specifics are being given here. So what you can do is you have understood the path here. Okay, so we can just go back to the terminal. The repository we have already cloned. What you can see here is that the repository is already cloned. But the thing is, when you're going to do it for the first time now, the directory won't be existing. So it will clone and it will take a little time. So it will get cloned. Okay. Mine is already showing that it already exists because I have already tried the demo here. Okay. So yeah. So what we can do is we can type here for, we have to input the path, right? So for inputting the path, we can just type ls, then cd. What was the location? Python docs, app engine. The further path will be given by again ls cd flexible. Sorry, hello world. Then we just have to deploy the app. So just give the command gcloud app deploy. Just authorize it. What happened here is it's asking for me to continue. But if you are going to do it for the first time, it will ask you to select your project. Like my project name is demo with the billing enabled. So remember that there will be a certain list of projects. So you have to select one project, and then there will be another option of you like press enter after that. By selecting the project, it will ask for the region. So you have to select a region. Okay, like my region is Asia South. So you have to select your region, and then it will ask for you to continue. So you just have to type the Y here. It doesn't usually take this long, but today I think there's a little server problem. That's why it's taking this long. I hope you have understood till now the theoretical part also, and also the like this implementation also till now. Remember those codes which I have told you, right? For the path one and also for the cloning one. Cloning one will be given. For the path one, you have to remember that. Okay. So you can see here, services and versions and instances are given. When you create this project, a service will be created, and yeah, this is a single service is being created. Inside that, the versions will be created. So I have created a new version in that, like this one through Cloud Shell. I have created a new version. This one it is, which is serving right now, right? It's show has stopped. This I have already ran before. This one is ours, 2021. This 5441. This is the version we have created. Okay, so in instance, this is not showing right now, but this shows when it's get implemented now. When this app starts running, it shows all the information regarding that. Okay, so yeah, dashboard. So yeah, the service is updated. Yeah, it's almost done now. Yeah, so what you can do is, yeah, here is the link. You can just copy the link. Go to the app. Yes, we got it. Hello world. So now let's first understand what infrastructure as a service, that is IaaS, is. So infrastructure as a service are online services that provide high-level APIs which are used to dereference various low-level details of underlying network infrastructure like physical computing, resources, location, data partitioning, scaling, security, backup, etc. A hypervisor, which is nothing but a physical host such as Zen, Oracle, VirtualBox, Oracle VM, KVM, or VMware, runs the virtual machines as guests. So pools of hypervisors within the cloud operational system can support large number of virtual machines and the ability to scale services up and down according to customers' varying requirements. Typically, IaaS involves the use of cloud orchestration technology like OpenStack, Apache, CloudStack, or OpenNebula. This manages the creation of a virtual machine and decides on which hypervisor to start it, which enables virtual machine migration features between hosts. Also, it allocates storage volumes and attaches them to virtual machines and track usage information for billing and more. Now let's get an overview of Google Cloud's compute engine. So Google's compute engine is Google's infrastructure as a service virtual machine offering. It allows customers to use virtual machines in the cloud as server resources instead of acquiring and managing server hardware. Google's compute engine offers virtual machines running in Google's data centers connected to the worldwide fiber network. The tooling and workflow offered by the compute engine enable scaling from single instances to global. Google Compute Engine enables users to launch virtual machines on demand. Virtual machines can be launched from the standard images or custom images created by users. The Google Compute Engine users must authenticate based on Auth 2.0 before launching the virtual machines. So what Auth 2.0 here is? So if you see, Auth is an open standard for access delegations, commonly used as a way for internet users to grant websites or applications access to their information on other websites but without giving them the passwords. The mechanism is used by companies such as Amazon, Google, Facebook, Microsoft, Twitter to permit users to share information about their accounts with third-party applications or websites. Now going back to Google Compute Engine, which can be accessed via the developer console or RESTful API or command line interface. Now let's have a look at some of its applications. So first one is a virtual machine migration to compute engine. So what it do is, as you can see in the diagram also, how it works. So it provides tools to fast track the migration process from on-premise or other clouds to Google Cloud Platform. If a user is starting with the public cloud, then they can leverage these tools to seamlessly transfer existing applications from their data center or AWS or Azure to Google Cloud Platform. Users can then have their applications running on Compute Engine within minutes while the data migrates transparently in the background. That's how virtual machine migration works. Then we have genomics data processing, as you can see in the chart that how it works. So processing genomic data is like computationally intensive process because the information is enormous with vast sets of sequencing. So with the compute engine's potentials, users can process such large data sets. So what it do is it processes petabytes of genomic data in seconds with compute engine and high performance computing science solution. So Google Cloud's engine's scalable and flexible infrastructure enables research to continue without disruptions. Okay. Also, like competitive pricing and discounts help you stay within the budget to convert ideas into discoveries or hypotheses into cures and also like inspirations into products. Then we have BYOL, also known as bring your own license images. So in this, how the normal host and then we have a sole tenant node. You can see how this chart is given for its working. So what it do is a compute engine can help you run Windows apps in Google Cloud Platform by bringing their licenses to the platform as either license included images or sole tenant images as shown. So after you migrate to Google Cloud, optimize or modernize your license usage to achieve your business goals. Take advantage of the many benefits available to virtual machine instances, such as reliable storage options, the speed of the Google network, and also like auto scaling. Now let's look at some of the key features of Google Compute Engine. So first is machine types. It describes the virtual hardware that is attached to an instance, which also includes RAM and CPUs. There are like two types of machines. First is a predefined, and second is a custom machine types. So predefined machine types are like there are pre-configured virtual machine templates that can be used to set up the virtual machines. The configurations have been pre-optimized by Google and like meet most of the requirements. So the predefined machine types are further divided into four subcategories. So they are like standard virtual machines, which are like balanced between processing power and memory. And then we have high memory virtual machines. In this, like emphasis is put on memory over processing power for tasks that needed accessible non-disk storage quickly. Then we have high CPU virtual machines. So high CPU usage for like high intensity applications that require processing over memory. Then the fourth subcategory, that is the shared core virtual machines. So if you see a single virtual CPU backed by a physical CPU that can run for a period of time. These machines are like not for use cases that require an ongoing server or significant power. So the second main category under machine types is custom machine types. In this, the virtual machine can be configured manually for a compute engine virtual machine instance. So users can like select the number of CPUs and memory provided they are within Google's set limits. So the second one is a local SSD. So Google Compute Engine offers always encrypted local solid state drive block storage, which is physically attached to the virtual machine running it. It improves performance and also like reduces latency. Now the third one is persistent disk. So these are durable high performance block storage for virtual machine instances, which can be created in hard disk or SSD formats. So users can take snapshots and create a new persistent disk from the snapshot. If a virtual machine instance is terminated, the data is retained by the persistent disk, which can be attached to another instance. There are two types of persistent disks. First is shared, second is SSD. Then we have GPU accelerators. So GPUs are added to accelerate computationally intensive workloads like machine learning or virtual workstation applications, etc. Also, the fifth one is images. So an image contains the operating system of the root file system that uses leverage to run virtual machine instance. So Google Cloud Platform provides two main types of images. First one is public image and second is custom images. So public images are like collection of open source and proprietary options. This is the starting point for most virtual machine instances and come packaged with only the operating system. The second one is the custom images. So public images, if you see, are a good starting point, but they are designed to be built upon and turned into custom images to match the needs of the customers. Custom image has the software needed along with all the scripts necessary for the instance to work automatically without administrator intervention. These are automatically brought up and shut down for load balancing or recovery needs. So the last one is global load balancing. So it helps in distributing incoming requests across pools of instances across multiple regions so that users can achieve maximum performance, throughput, and availability at a cost. Similarly, there are many other features like Linux and Windows support container reservations, OS patch management, live migration for virtual machines, and many more. Google Compute Engine has many pros such as the input-output like access, like smooth integration with other Google services, and few cons as like most components are based on proprietary technologies and the choice of programming languages is limited. So now that you know the applications and features of Google Compute Engine, let's now look at some major advantages of it. Okay. So the first is storage efficiency. So the persistent is support up to 257 terabyte of storage, which is more than 10 times higher than what Amazon Elastic Block Storage can accommodate. The organizations that require more scalable storage options can go for Compute Engine. Then we have costs, as it is cost effective. So within the GCP ecosystem, users pay only for the computing time that have consumed. So the per second billing plan is what used by the Google Compute Engine. Then we have stability. Google Compute Engine offers stable services because of its ability to provide live migration virtual machines between the hosts. Also, Google Cloud Platform has a robust and inbuilt and redundant backup system. So the Compute Engine uses this system for flagship products like Search Engine and Gmail. Also, coming to security, so Google Compute Engine is the most secure and safe place for cloud applications. So now that you have a theoretical understanding of Google Compute Engine, let's practically try our hands on it. So you can just directly go to Google Cloud Platform. Just open it. First, let's go to the documents part. So in this, also you can open the console also. This one, this tab only we can open. Okay. So for support purpose, you can just go through this documentation part. Though I'm going to explain you, still if you need any support, you can go to this compute part, and here the compute engine is given. From here you can like much more understanding of Google Compute Engine. So let's come back here. We have opened the console. This is how the Google Cloud Platform dashboard looks like. You can either go from here to Compute Engine. From here we can open, or you can just search here Compute Engine. Okay. So these are the virtual machine instance templates. So these are different kind of virtual machines are given. Then we also have storage. Under that we have, just a minute, we have this snapshots or images. As I have told you, like there are built-in images also, and there are like custom images also. So here's the disks. These are the disks which have already been created, and then we also have snapshots. One of the snapshot is also there. So then we have images. So these are the built-in images. You can use any of them, or if you want to make your own custom type images, you can create image from here. Okay, now let's finally go to virtual machine instances, and let's see how we can launch an instance. So these are the two instances which I've already created. So let's go and create a new one. Okay, so you can name your instance here, and here whatever configurations you're gonna give now, the price will change. Okay, like I can show you just for showing purpose. I'm just showing you if you change it to 4 virtual CPUs, see the price has changed, right? And again go to the small one. Okay, so you can also add label here and give it key environment. Can give testing. Okay, or you can add much more label than okay, you can add more labels like app, or you can give the value for it like app. Okay, you have to do that, and then you can like save it. Okay, then we have like, see, I'm changing the configuration, that's why the price is changing. Okay, and then we have to see the region also. Under that region and zone you have to select, and under that we have different services. Okay, like right now the under this these services are there: general purpose, compute optimized, memory optimized, and GPU. Okay, like you can see in this E2 series we have, for general purpose we have series, and we have machine types of 4 CPUs and 8 GB memory and all this like that. Then we also have compute optimized also. Under this we have 4 CPU 16 GB, and then 8 CPUs we have 32 gig. For 16 CPUs we have 64 gig. These kinds of CPUs and memory is given. And if you come to memory optimized, these are the large ones. These are the ultra level ones. So there are like 96 CPUs and 1 4 TB of memory, also 40 CPUs and 961 GB memory. And then we also have GPUs for it for different machine types. We have these kind of GPU for 24 virtual CPUs, 170 GB memory, and this weight is given. But remember that you don't get it in every region and zone. Like I can show you. Right now it is selected as US Central 1 and US Central 1A, right? And if we change it to Europe West, okay, let's see if we change it to Europe West. See, now you can see GPU is already gone. If we see for C1, now even the memory optimized is also gone. So that's how it works. Okay, so let's go to the default one only, which V1. Yeah, okay. Then we have boot disk also. You can change this boot disk also, like you can go to change. You can like, select a public image or anything. For a different one you can use this, and then it has 07. Okay, let's go do it 50 also. We can do that, and then we can select it. Okay, or we can go to custom images. If you want to use any custom image of yours, you can use it here. If you have any snapshots taken, you can also use snapshots here. Also, if you have an existing disk, or like if you have made some existing disk from a previous virtual machines, then you can use it. But right now we don't have one. Also, I've shown this, so you can select it here. Okay, you can change it again. You can just go to Debian only. Okay, Linux is selected. Balance persistent disk or SSD persistent disk, which one you can select. Give it 10 only. You can just select it. This is the default setting we have done again. And then you can come to this management security disk network household tenancy. You can just select it. Let's come to the networking part. If you already have a network tag or something, you can select it here. Also, you can change the host name or whatever host name you have created. You can give a different one also. Okay, and then we have disks. It's like if you are creating a virtual machine, you can, if you delete a virtual machine also, you can retain your disk also. There is an option here, delete boot disk when instance is deleted. So you can just deselect it. So if a virtual machine is deleted, then also a disk will be like retained. So again doing it. So let's create it. Well, I think there is a problem. There is some problem. Create virtual machine instance and its boot disk instance. Yeah, okay, they don't support. What you can do is, this is something, there are certain limitations of, I want to say, for free trial, because this is a free trial. Okay, so you can buy one, or there are certain limitations, you have to follow those limitations. So you can like simply create a default one with default settings. You can, like right now I'm not doing any customizations and everything, so you can just create that for now. So it will take a few time because I've changed some settings now, that's why it wasn't able to run, and there are certain limitations. I hope you understand. Yeah, now it's been created. Also, let me tell you this, like suppose if you have created this instance and you have working on it, you have created this on server, we have created this virtual machine, I mean, and you're working on it for a long time, you worked, and then suppose a teammate comes and he sees that and he feels like, okay, this is a lot of mess up, so he deletes the instance. Now what happens is, it will be like, oh, your work is gone, all the work you have done is gone. But what you can do is, or you can go to disk only. Okay, so this is the instance too. What you can do is, you can create a snapshot from here. Okay, or you can just snapshot is created, it will be created here. Okay, like another snapshot is here for instance 1. If you created for instance 2, it will be created here itself. So while creating the instance, what you can do is, if you have taken the snapshot, okay, so what you can do is, from here you can change it and you can go and select a snapshot from here. Okay, like right now snapshot is given up, for instance 1 it is given. If you use it, all your work will be retained. So that's how it works. Also, you can, like, if you want to delete an instance, you can just go here and delete the instance from here. It will take a few seconds. Yeah, the instance got deleted. I hope you have understood now. This is the basic demo.
What is a VM instance? As we all know that a virtual machine is a digital version of a physical computer, right? So a virtual machine software can run applications, operating systems and all of that. So virtual machine being a copy of the physical machine, when it comes to VM instance, an instance can be defined as a virtual machine hosted on Google Cloud Platform infrastructure, right? Since we're talking about Google Cloud Platform machine instances here, so a VM instance is nothing but a virtual machine that is hosted on Google Cloud Platform. So the source virtual machine for any instance is always the image from which it is deployed, right? So VM hosted on Google Cloud Platform infrastructure is a VM instance. The source VM is always the disk image that is available, and the fact that you can choose your various machine properties that are there. So when you create a virtual machine, you get to choose the kind of properties your virtual machine will have. Let's say, for example, the kind of networking properties your VM has, or let's say the kind of storage capabilities, the instance type that you choose. All of these can be chosen by the user when you're creating a virtual machine instance on Google Cloud. So next we come to configuring your VM instance. Now when it comes to configuring your very own VM, there are many options that you have when it comes to configuration, such as you can configure the storage that your VM provides, the networking capabilities that your VM has, and also you can manage your instance overall. So storage options are various, and the most important thing is that when it comes to storage, boot persistent disks are there by default. So additional storage is always available to run apps. Next up, we have networks. Now, each network interface of an instance is associated with a subnet or a VPC unique network that you have. Now, that is basically the fact that when you create an instance, if you have certain subnet for a certain instance, your virtual private cloud will basically connect to that subnet that you have created before. So for this, you can use labels that you can have, that you can also add during your VM creation process. So another thing that users can choose to do is add different labels to the VM instances that they create. And finally, we come to managing your instance. Now, managing instances comes with the managed instance access during OS login, right? So you manage your SSH keys in the project metadata. Now these keys will basically help you log into and connect to your VM when it has been created. Now these keys are generally private keys, and basically if you want to log into your OS and access the VM, what you have to do is generate certain private keys that will be able to access your VM. So this is all about configuring your VM instance. Next up, we come to machine families. Now, what is a machine family? A machine family is nothing but a curated set of processor and hardware configurations that you have, which are optimized for specific workloads, right? So when you talk about Google Cloud Platform and the virtual machine instances that they have, there are various different machine instances that they provide because of the different machine families that they belong to. Let's say, for example, there are machine families such as the N1, N2D, and the N2 available. Now, each different instance is optimized separately for a separate workload, and the pricing will be based separately on that as well. So machine instances, when we talk about it, let's see that first we select a machine type from the instance family to determine the resources in the VM, right? And then we further categorize the machine family to types on the price to performance ratio that they have. And finally, the curated set of processor and hardware configurations is optimized for the workload that is there. So next up, we can talk about the different categories that are there. Now, the first category is the E2. Now, E2 has around 32 virtual CPUs, 128 GB memory, and the AMD EPYC ROM processor, right? Whereas when we talk about N2, we can see that compared to E2's 32 virtual CPUs, N2 has around 128 virtual CPUs, whereas there is around 8 GB memory per virtual CPU, and it is available on Intel Ice Lake. When we talk about N2D, we can see that compared to N2 and E2, N2D has 224 virtual CPUs. The 8 GB memory per virtual CPU is the same as N2, whereas it is available only on the second gen EPYC. Then we talk about the Tau T2D. Now the Tau T2D offers the users around 60 virtual CPUs, 4 GB of memory per CPU, which is different from the N2 and N2D, and third generation EPYC Milan. And the last one we talk about here is N1. Now, N1 offers you 96 virtual CPUs, 6.5 GB memory per virtual CPU, and it's available on the Intel Sandy Bridge platform, right? So these are the various machine instances and the categories that they have. And as you can see, these are basically different and can be used for different workloads and basis on the basis of which needs to be optimized. For example, you can optimize the amount of virtual CPUs, you can optimize the amount of memory, you can optimize other things as well, such as networks and all of that. So this is basically all about machine families. Next up, we talk about the pricing. When it comes to pricing, it's based on three major points. Basically, pricing is based on the billing mode, the instance uptime, and the resource which is based on. When it comes to billing mode, minimum 1 minute is charged for virtual CPUs. Afterwards, there are 1 second increments for whatever VM has been used. Instance uptime allows the compute engine to apply sustained use for discounts to all the predefined machine types that are there. And finally, there is the resource-based pricing model, which talks about the number of seconds between starting and stopping an instance, and that is how you determine the price of your VM, right? So this basically gives you an idea about the E2 standard pricing, where we can see that the E2 standard 2 has two virtual CPUs, 8 GB memory, and is around $0.067 per month. And the spot price is around 0.002. So likewise, it's the same for N2, where you can see that there are different virtual CPUs for the different types of N2 standard machine types, and these are the different prices. For example, N2 standard 2 has two virtual CPUs, 8 GB memory, etc. And finally, we can see the N2D standard pricing. Now, all of this is different for the different machine families that are there, right? So this is how you basically see the pricing for what VM you are using. Finally, we come to creating your first VM on Google Cloud Platform. So let's get started. So log into your console and make sure you go to Compute Engine. So this is where you want to go. Once you go to Compute Engine, you have to go to VM instances. Just try and go back here. Right. So once you go to VM instance, what you have to do is go to create instance. Now, as soon as you do that, so when you see you have create instance, you can name your instance, let's say instance one. You can add labels to it. So next we come to labels. Now labels will basically help you identify the whatever instance resources are there. So you can help manage labels. So the labels will help you identify the resources that are there. Let's say for example, so you've now added your labels. So let's check out the other things that we can do. Now the region, let's see the regions we can do. So this is US Central right now. You can change this to a lot of things. Let's change it to Europe and London. So if you change it to London, you can see here the different kind of machine configurations that you have. Now this has two to three hosted zones. Yeah, it has three hosted zones. And as you can see, there's a monthly estimate of you having around $32.71 per month, right? So machine configuration. Now this by default is set to E2. What you have to do here is check out the other ones that are there. Let's check out N1. So as you can see, the price has just gone down by a little bit, and you have to make sure that the prices for your VM are low so that you can have it free tier accessible. And the machine type that you have here is the N1 standard. So that is around $32 per month. You can change it to F1 micro. Let's see. Yeah, so once you do that, you can see that the monthly estimate is around $6.11 and it is free tier accessible. And the other things that you can do is the CPU platform and the GPU that is there. After that, if you don't have other things, you can check out the boot disk that is there. Now you can change your boot disk. Let's say it is by default set to Debian. You can change it to CentOS. And once you change it to CentOS, let's check it out. The pricing changes and it has changed to 7.31. So we don't want that. We want our VM to have the least possible cost. And we change it back to Debian. And here you go. So we're back to 6.11. All you have to do now is go to the advanced settings. So once you go to these advanced settings, you have to go to networking, and let's say you can add these tags, let's say the web tag that you had. So this networking tag will basically have any resource which has the web tag will have to be rerouted towards this network traffic. After this, let's just, so all you have to do now is create the instance. Right. So as you can see, your instance has been created. Now what you need to do is connect to your instance, and you can check out your instance details over here. Once you click on your instance, you can check out the different details of your instance, and you can check out the observability and all of that, the logs. So as you can see, this is basic information, instance one, instance ID, the type of instance, the status, all of that, which zone, and the templates. So let's go back and try connecting to our instance. So if you go to basic SSH, let's try this one out. So as you can see, the SSH terminal has opened up. So all you need to do is right now type in lsblk. So if you do lsblk, you'll basically check out the name and the size of your disk. And after this, just put into host name, and instance one is the host name. So let's now check if we can sudo into this. Yes, we can. So right now, after this, all you need to do is cat etc/os release, and you can check. the name of your Linux VM and the ID, the instance type, all of that. So this is how you check it with SSH, right? So what you can do now is try and check it with the others as well. You can check it in gcloud command. All you need to do is copy this and run in Cloud Shell. Right. So this is the command that you've used to connect to your Cloud Shell, and all you need to do is enter and authorize. Right. So this is basically your connecting to the instance, and all you have to do here is the same command cat etc os release, enter. Right. So once you do the cat.etc, you can see that these are all the names of the VM and the version and the ID that you have. So this is how you can connect to your VM instance using Google Cloud.
What is Google Kubernetes Engine? Google Kubernetes Engine provides a managed environment for deploying, managing, and scaling your containerized application using the Google infrastructure. The GKE environment consists of multiple machines, specifically compute engine instance, which are grouped together to form a cluster. Now, a cluster is the foundation of Google Kubernetes Engine. The Kubernetes objects that represent your containerized application all run on top of your cluster. Now, to understand GKE better, let us understand its architecture and its working. As you know, all Kubernetes objects that represent your containerized application run on top of a cluster. It is a foundation of GKE. A cluster consists of at least one control plane and multiple worker machines called nodes. These control plane and node machines run on Kubernetes cluster orchestration system. The control plane runs the control plane processes, including the Kubernetes API servers, scheduler, and core resource controllers. The control plane is responsible for deciding what runs on each and every node. This can include scheduling workloads like containerized applications and managing the workload's lifecycle, scaling, and upgrades. The control plane also manages network and storage resources for those workloads. Now all the interaction with the clusters are done via Kubernetes API calls, and the control plane runs the Kubernetes API server processes to handle those requests. You can make Kubernetes API calls directly via HTTP/gRPC or indirectly by running commands from the Kubernetes command line client, that is kubectl, or interacting with the UI in the Cloud Console. Now coming to the nodes. Now nodes are the worker machines that run your containerized application, which is your containers and other workloads. They run the services that are necessary to support the containers running in your workloads. Each node is managed from the control plane, which receives update on each node's self-reported status. Next, we have something called the user pods. Now, pods are the most basic and smallest deployment object in Kubernetes. It can contain one or more containers. So now when the pod runs multiple containers, the containers are managed as a single entity, and it shares the pod's resources such as networking and storage. They're connected to various GCP services such as VPC networking, persistent disk, load balancer, and other cloud operations. This was the architecture of GKE. Now let us understand its working. GKE works with containerized applications. These containers, whether for application or batch jobs, are collectively called as workloads. And before you deploy these workloads on GKE, you must first package it into a container. Now to create a continuous integration and continuous delivery pipeline, you can use Cloud Code to write your application, then send the code to a repository which launches a build process in Cloud Build. This build process builds container images from a variety of source code repository. These container images are stored in container registry and are ready to be deployed in the Google Kubernetes Engine. You can then create a GKE cluster using Cloud Console UI, gcloud command line interface, or the APIs. After this, with a few clicks, you can deploy your application on GKE. Now I guess you have some idea about Google Kubernetes Engine. Now let us move on to the next topic and see some of the advantage of Google Kubernetes Engine. With Google Kubernetes Engine, you gain the benefits of advanced cluster management features that Google Cloud provides. First is load balancing for compute engine instance. Google Cloud offers server-side load balancing so you can distribute incoming traffic across multiple virtual machine instances. Load balancer can scale your application, support heavy traffic, detect and automatically remove unhealthy virtual machine instances using health checks, and route traffic to the closest virtual machine. This is a managed service, which means its components are redundant and highly available. So if a load balancing component fails, it is restarted or replaced automatically and immediately. The next benefit is auto scaling. GKE's cluster autoscaler automatically resizes the number of nodes in a given node pool based on the demand of your workloads. You don't need to manually add or remove nodes or over-provision your node pools. Instead, you specify a minimum and maximum size for the node pool, and the rest is automatic. The next benefit is auto-updating. Auto upgrades will help you keep the nodes in your cluster up to date with the cluster control plane version when your control plane is updated. With auto update, you don't have to manually track and update your nodes when the control plane is updated on your behalf. It also provides better security by automatically ensuring that security updates are applied and kept up to date with the latest Kubernetes features. The next benefit is monitoring and logging. Google Kubernetes Engine includes native integration with cloud monitoring and cloud logging. When you create a GKE cluster running on the Google Cloud, cloud operations for GKE is enabled by default and provides a monitoring dashboard specifically tailored for Kubernetes. With cloud operations for GKE, you can control whether or not cloud logging collects application logs. You also have the option to disable the cloud monitoring and cloud logging integration altogether. These were some of the benefits of Google Kubernetes Engine. Now let us move on to a demo part and see how to deploy a containerized application on Google Cloud Platform. So in a demo, we are going to package a sample web application into a Docker container image and then run that container image on a GKE cluster. So for that, I've logged in into a GCP account. Now it is very simple to create a new GCP account. All you have to do is enter your debit card or credit card detail and give your address. Then you might be charged maybe ₹1 for it, but even that will be refunded later. Now as you sign into a new account, GCP will provide you $300 of free credit. You can use this amount to explore Google Cloud services. You won't be charged until you choose to upgrade, and it will be valid for 90 days. So first, let us create a new project. So we'll just go here, select a new project. We can name a project anything we want. So we'll just name it Kubernetes. Let the rest be same and we'll just create it. Now our project is created. We'll just select it. So for our demo, we're going to use Cloud Shell. Now Cloud Shell is an online development and operational environment. It can be accessed from anywhere with the browser. The reason we're using Cloud Shell is we do not have to install any command line tools for a demo. So we'll just click on Activate Cloud Shell over here. Then you can see a Cloud Shell terminal which is being created at the bottom of your screen. So the first step, as I've mentioned before, is to build a container image. For this tutorial, we're going to deploy a sample web application called Hello App, which is a web server written in Go programming language. It responds to all requests with the message Hello World on port 8080. But before we deploy the Hello App to GKE, we must package the Hello App source code as a Docker image, and to do that, we need the source code and the Docker file. Now the Docker file contains information about how the image is built. So first, let us download the source code and Docker file for the Hello App application. Git clone https github.com Google Cloud Platform Kubernetes Engine samples. So the Hello App application is available in this website. So we've just mentioned the website URL over here. Just click on enter. So it says that the directory already exists. So we get a message saying the directory already exists. So we'll just change the directory. Next, we have to set the project ID environment variable to the Google Cloud project ID. You can find the project ID over here. But I guess my project ID is the project ID environment variable. So let's just confirm it. So for that, we'll just type echo $. Next, you have to set project ID environment variable to your Google Cloud project ID. So for that, you have to type export project ID is equal to, you can find your project ID over here. So you can just copy it from here and paste it over here. The project ID variable associates the container image with your project's container registry. Now to confirm a project ID, we'll just type echo $project ID. Here you can see this is the project ID. After confirming the project ID, it is time to build Docker image for the Hello app. So for that, we'll type docker build space -t space gcr.io/$ project ID / hello app version 1. Now this is the name given to a Docker image, and GRE refers to the container registry. Oh, we just forgot one more thing over here. That is space a dot. Now it will ask you to authorize Cloud Shell. You can just select authorize over here. Now you can see a Docker image is being created. We'll just extend this. Now you can see our Docker image was successfully built. Now to just confirm if a Docker image was built, we'll just type Docker images. Now you can see a Docker image is built. It was created a minute ago and the size of it. After this, we have to push our Docker image to the container registry so GKE clusters can download it and run the container image. So for this, we are going to enable the container registry API. We'll just type gcloud services enable container registry dot google apis.com. Next, we have to authenticate to container registry by configuring the Docker command line tool. For that, we are going to type gcloud authenticate configure Docker. Now this is just a warning message saying that we have a lot of credential and it might be slow. So now we have authenticated our container registry. Now we have to push the Docker image to the container registry. So for that, we're going to type docker push the name of our Docker image. Now a Docker image is being built in the container registry. Now you can see a Docker image is pushed to our container registry. Now the next step is to create a Google Kubernetes Engine cluster. So for this, we're just going to minimize it and just go to Kubernetes. You can either select Kubernetes Engine from here, or you can just type Kubernetes over here. Kubernetes Engine. We'll just click on enable over here. Now this might take a couple of seconds. You can scroll down and read an overview about it. You can read about Google and the various other products which are offered by them. Now this is what the Google Kubernetes Engine console would look like. So it will ask us to first create a Kubernetes cluster. So we'll just go ahead and create one. Now we have two options over here. One is standard and the other one is autopilot. In standard, you manage your cluster's underlying infrastructure, which will give you node configuration flexibility. And in autopilot, GKE provisions and manages the cluster's underlying infrastructure. So we'll just go with standard over here and click on configure. So we can name our cluster whatever we want. We'll just name it cluster hello app. You can select any zone from here. These are the available zones. So we'll just select maybe US West one. Now you can select the zone which is nearest to you. You can select the version. We'll just go to static version and just create a cluster. Now creating a cluster might take a couple of minutes. So we'll wait for some time and refresh it to see if it is created or not. You can see there is a green tick over here, which means a cluster is successfully created. We have already pushed the Docker image to a container registry. The next step is deploying the sample application to Google Kubernetes Engine. For this step, you have to create a Kubernetes deployment to run the application on the cluster and also create something called the horizontal pod autoscaler, which scales the number of pods. It can be anywhere from 1 to 5 based on the CPU load. So for that, we'll go to workloads and click on deploy. We have an existing container image, so we'll just select it. Go to select. This is our project ID and this is the name of the Docker image. So we'll just expand it and select this. Our Docker image is selected. We'll click on continue. Now we have to configure it. So we can name our application anything we want. So we'll just name it demo application. We'll let the namespace be default. Next we have label, which is basically for identification. So we'll let the key be app and the value be demo application. We'll not make any changes in that. And this is our cluster on which the demo application is going to be deployed. Now when we see the IAM, okay, so we have an error here. We cannot use uppercase. So we'll just make it lowercase, demo application. Now when we see the YAML file, you can see two Kubernetes API resources about to be deployed into your clusters. The first one is deployment, and next is the horizontal pod autoscaler. Next, we'll just click on deploy, and our deployment is being created. Now this might take only a couple of seconds. Here you can see the CPU usage, memory usage, and the disk usage, but as of now there is no data available. Now if you go to details, you'll see a cluster name, the namespace which I have mentioned, when was it created and at what time, the labels, how many replicas were made. There were 3 replicas which were made. So after the deployment, we are going to expose the sample application to the internet. So for that, we have an option here called as expose. So we'll just click on this. In the target port, we'll select 8080. Now this is the port the Hello app container listens to, as I had mentioned at the starting of the demo. The service type, let it be load balancer itself, and we can name our service anything we want. Let it be demo application service itself, and we're just going to click on expose over here. Now a new service has been created and it is waiting for a load balancer with an external IP to be created. Now this might also take a couple of seconds. Now a service has been created. So when we go to details, you can see the cluster name, the namespace, when was it created, the label, the pods, the type load balancer, and external endpoint. So we'll just click on this, or you can just copy this and paste it in a new tab. So when we click on this, we are directed to a sample application. So here is a sample web application. Now you see our sample application is exposed to the internet through Kubernetes service. And here is the hello world message with the version and the host name. What exactly is Google Cloud Anthos? Anthos is a hybrid and multi-cloud application modernization platform. It was launched in June 2019 and can help in rapidly building hybrid and multi-cloud application without compromising on security as well as not increasing the complexity. Now if you're wondering what Anthos can be used for, here are a few cases where you can use Anthos. Firstly, it helps in provisioning infrastructure in both cloud and on-premises as well. Next, it provides infrastructure management tooling, security, policy, and compliance solutions. It can also be used for streamlined application development, service management, and workload migration from on-premises to the cloud. Next, one of the core functionality of using Anthos is to easily deploy container-based application in a hybrid or multi-cloud environment in an easy and consistent way. Clients can choose from various deployment options such as on-premises, bare metal, Google Cloud Platform, AWS, or Kubernetes clusters. Google Cloud Anthos allows developers to focus on innovation and create new features, software, or products for the company instead of spending time on managing complex hybrid environment. This will be taken care of by Google Cloud Anthos. Now I guess you have some idea about what Google Cloud Anthos can be used for. Now in order to understand Google Cloud Anthos better, let us take a look at its components. Basically, Anthos is a platform composed of several technologies integrated together rather than a single product. It is powered by Kubernetes along with other technologies like Google Kubernetes Engine, Google Kubernetes Engine on-prem, Istio, Service Mesh, and others. Now let us talk about each of these components one by one. Now the Google Kubernetes Engine and Google Kubernetes Engine on-prem are the main computing components which enables Anthos. Now, GKE is nothing but a managed environment for deploying, managing, and scaling containerized application using the Google infrastructure. Now, if a company already have the data center or the IT infrastructure, they can use GKE on-prem, which will provide them all the benefits of GKE like auto updates, auto node repair, and many more. Then to connect the on-premises data centers and workloads on GCP, there is Google Cloud Interconnect. Now, Google Cloud Interconnect is a service which provides direct connectivity between on-premises data centers and the workloads on Google Cloud Platform with consistent latency and high bandwidth. Now, Google Anthos Service Mesh enables fully managed service meshes for complex microservices architecture, which would include traffic management, mesh telemetry, and securing service communications. And with Anthos Config Management, you can create configuration which will allow you to easily and consistently manage your resources globally across clouds and data centers. Next, the GKE Connect allows you to register GKE on-prem based clusters to the GCP console. This can help in securely managing the resources and workloads running on them together with the rest of the GKE clusters. This can be enabled by installing the GKE Connect agent. Organization can simultaneously migrate the virtual machine applications to Google Kubernetes Engine with Anthos Migrate. So the apps can be run and managed through GKE with Istio Service Mesh capabilities. So now I guess you have some idea about Anthos components and what is Anthos. Let us move on to the next topic and see some of the features of Google Cloud Anthos. The first feature is Google Cloud Anthos integrates security into each stage of application lifecycle, from developing to building and running. Anthos enables defense in-depth security strategies with a comprehensive portfolio of security control across all the deployment models. The next feature is it offers a fully managed service mesh with built-in visibility. Google Anthos Service Mesh unburdens the operational and the development team by empowering them to manage and secure traffic between services while monitoring, troubleshooting, and improving application performance. The next feature is it provides container orchestration and management service. Google Cloud Anthos enables you to run Kubernetes clusters anywhere in both cloud and on-premises environment. Anthos can also run on your existing virtualized infrastructure and bare metal servers without a hypervisor layer. It simplifies your application stack, reduces the cost associated with licensing a hypervisor, and decreases time spent learning new skills. The next feature of Google Cloud Anthos is serverless computing. Anthos provides a flexible serverless deployment platform called Cloud Run for Anthos, which allows you to deploy your workloads to Anthos clusters running on-premises or on Google Cloud, all with the same consistent experience. Cloud Run for Anthos is powered by Native, which is an open source project that supports serverless workloads on Kubernetes. The next feature is migrating existing workloads to containers. You can use the Migrate for Anthos service that minimizes the manual effort required to move and convert existing application into containers. With Migrate for Anthos, you can easily migrate and modernize your existing workloads to containers on a secure and managed Kubernetes service. These were some of the features of Google Cloud Anthos. Now let us move on to the next topic and see some of the benefits of using Google Cloud Anthos. The first benefit is it provides various business benefits. Now, according to a Forrester Research Anthos report, which was commissioned by Google, it was found that overall Anthos business benefits include operational efficiency, developer productivity, and security productivity. On an average, organizations saw 4.8 times return of investment within 3 years of adopting the Anthos Cloud Platform. The developers can use this platform to quickly and easily build and deploy existing container-based application and microservices-based architectures. They can use Git compliance management and CI/CD workload for configuration as well as code using Anthos configuration management. It also supports for Google Cloud Marketplace to easily and quickly deploy functional software packages or products into clusters. The next benefits of Anthos is it provides enhanced security. Anthos protects apps with high standard for reliability, availability, and vulnerability from a security perspective. Anthos also offers a high level of control and alertness for your services' health and performance with a comprehensive view. Now, these were just some of the benefits of Google Cloud Anthos. Now, let us take a look at the pricing of Anthos. Anthos charges applies to all managed Anthos clusters and are based on the number of Anthos clusters virtual CPUs charged on an hourly basis. There are two types of pricing options for Anthos. The first one is pay-as-you-go pricing model, where you are billed for Anthos managed clusters as you use them. Now, if you want to try Google Anthos or use it infrequently, you can choose pay-as-you-go pricing model. The next type of pricing option is a subscription pricing, which provides a discounted price for a committed term. Your monthly subscription covers all Anthos deployment irrespective of environment at their respective billing rates. Any usage over your monthly subscription fees will show as an overage in your monthly bill at the pay-as-you-go price listed here. Now you can see in the image over here, there are three payment options. First one is pay as you go in an hourly basis. The next one is pay as you go in a monthly basis, and the subscription for monthly. And you can see the rates for each virtual CPU in various deployment models, such as Google Cloud, AWS, multi-cloud, on-premises, VMware, and on-premises bare metal. The good news is if you're a new Anthos customer, you can try Anthos on Google Cloud for free up to $900 worth of usage or for a maximum of 30 days, whichever might happen earlier. Now during this trial period, you're only billed for the applicable fees and then credited at the same time for those fees up to $900. But you're still billed for the applicable infrastructure usage during the trial. This was about Google Cloud Anthos pricing. Now let us move on to the next topic and see a case study on Google Cloud Anthos. So for a case study, we'll be talking about UPC Polska. Now UPC Polska is a Polish telecommunication arm of Liberty Global Europe, which offers cable television, broadband internet, and other services to roughly 1.5 million customers in Poland. The problem they faced was they needed to balance their existing IT infrastructure, which took them 2 decades to build, with a faster and more flexible infrastructure. So when they were looking for the solution, they decided to opt for hybrid IT, which would give them the speed to market they needed, as well as maintain the existing infrastructure, which they value. Now deciding about the hybrid approach, they thought Anthos was the best solution for the company's specific needs because of the consistent experience across environment, agility enabled by modern CI/CD, and the ability to set policy and ensure security at scale. Then they partnered with Accenture and focused on the cultural and organizational element involved in rolling out a new solution. When they opted for Anthos, it provided them with the following benefits. Their various teams could focus on the core responsibility rather than infrastructure management. For example, developers could focus on writing greater codes, while the operational team could use Anthos to effectively manage and run those applications anywhere. Also, the on-premises nature of the company's existing infrastructure made scaling and general maintenance difficult. By running Anthos in the data centers, the company gained the fully compliant Kubernetes experience necessary to avoid cluster orchestration and management issues, which included managing and scaling the containers. They also improved the scalability and resilience through containerized GKE clusters on Anthos. Now, this was a case study on Google Cloud Anthos.
What is Google Cloud Storage? Now, Google Cloud Storage is a set of various storage services offered by Google for different domain scenarios. It is a RESTful online file storage web service for storing and accessing data on the Google's infrastructure. Google Cloud Storage allows worldwide storage and retrieval of any amount of data at any time. You can use the cloud storage for a range of scenarios, including servicing website content, storing data for archival and disaster recovery, or distributing large data objects to users via direct download. So let's understand why we need Google Cloud Storage. First of all, it has a single API for all storage classes. The cloud storage's consistent API, latency, and speed across storage classes simplifies development integration and reduces code complexity. You can set custom policies to transition data seamlessly from one storage class to the next, depending on your cost and availability needs at the time. It is designed for 11 lines of durability. Google Cloud Storage is designed for 99.99 that are 11 nines annual durability. It stores the data redundantly with automatic checksum to ensure data integrity. With multi-regional storage, your data is maintained in geographically distinct locations. It is highly scalable and performant. Now, Google Cloud Storage is practically infinitely scalable. Whether you are supporting a small application or building a large exabyte scale system, Google Cloud Storage can handle anything. It is strongly consistent. When a write succeeds, the latest copy of the object is guaranteed to be returned to any get globally. Now coming to the zero carbon emission. You have many things to consider in the cloud platform you choose. First of all, it's the price, the security, the openness, and of course the products available. Now, Google believes you should consider the environment too. A sustainable cloud is not only good for the environment but also good for your business. By moving storage from a self-managed data center to GCP, the emission directly associated with your company's data storage will be zero. Now here you can see we have certain users who use Google Cloud Platform for their storage services. We have Spotify, Coca-Cola, Evernote, Motorola, Philips, and many more. Now let's have a look at the various Google Cloud Storage services provided by Google. We have the Cloud Storage, we have Cloud SQL, next we have the Big Table, the Cloud Data Store, and Cloud Spanner. We'll look into the details of each and every one of these services in this video. So let's get started with the cloud storage. Now, cloud storage is a scalable, fully managed, highly reliable, and cost-efficient object or blob store. It redefines what the industry can expect from online storage by providing a unified offering across the availability spectrum. From live data tapped by today's most demanding application to cloud archival solution, nearline and codeline. It has many features such as single API across storage, scalable to exabytes of data, very high availability across all storage classes. As we saw earlier that Spotify was one of the users of the Google Cloud Storage. Now Spotify uses Google Cloud Storage for storing and serving music. Using regional storage allowed them to run audio transcoding in Google's Compute Engine close to production storage. Now, working with cloud storage, there are two different methods. We have the console and we have the GSUtil tool. Now, console is provided by Google on the web page or the web UI itself, and GSUtil is a set of commands or tools which are used in the Cloud SDK. So let's go ahead and see how we can work with the Google Cloud Storage. First of all, you need to log in into your Google Cloud Platform account and you need to go to the console. In the left hand side in this toolbar, you can see we have the various services which are the compute, storage, networking, monitoring, and the development tools and the big data tools. So today we'll focus on the storage services. So let's go to the storage section. As you can see here, I have the option to create a bucket. So let's understand what is a bucket. Now, cloud storage lets you store unstructured data objects in containers which are known as buckets. You can serve static data directly from cloud storage, or you can use it to store data for other Google Cloud Platform services. So let's go ahead and create a bucket. So first we need to input the bucket name. Next we have to select the storage classes. Now there are 4 types of storage classes which are multi-regional, regional, nearline and codeline. Out of these two, the multi-regional and regional are based on the geographic regions, whereas nearline and codeline are based upon the usage. Now multi-regional is used for the data which is accessed frequently around the world. Regional is used for the data which is accessed frequently in only one part of the world. Coming on to nearline and codeline, nearline is best suited for the data which is accessed less than once per month. That means you can access it maximum once per month. Now codeline is best used for the data which is accessed less than once per year. So now I'm going to select the regional storage class. Next we have to select the regional location and just tap on the create button. And within seconds your bucket will be created. As you can see that there is nothing inside this bucket here. You can directly drop your files here from your PC or your laptop, and you have the option to upload files, upload a folder or create a folder. Let me just upload one file. Within seconds the file is uploaded and it's shown here. Now that you have seen how to create a bucket and upload a file, the same can be implemented using the GSUtil commands. For that, we need to download the Cloud SDK. Now Cloud SDK can be downloaded from Google. Tap on the first page and you'll be redirected to this page. Now you can install it for Windows, macOS, Linux or other operating systems. I have already downloaded, so I'll just fire up the Cloud SDK shell. Now just to create a bucket, all you need to do is type in the command gsutil mb, which is make bucket, -c, which stands for the class, the storage class, which I'm going to select as regional, -l, which stands for location, and -p, which stands for the project ID. And finally, you have to input the name of the bucket. For project ID, you can refer to the My First Project or whatever be your project. Just copy your ID from here, paste it, and then finally you need to input the name of the bucket. So now to list the buckets, all you need to type in is gsutil ls. As you can see, we have two buckets, which is Edureka bucket and the Edureka bucket 2. The same will be reflected on the website itself. As you can see here, Edureka bucket 2 is also here. Now, to list the contents of a bucket, you need to type in the commands gsutil ls-r and the name of the bucket. So as you guys saw earlier that I uploaded an image to the first bucket which I created, Edureka bucket. So let me list the contents of that one. As you can see, it's showing me the image which I uploaded. Now to delete a bucket, we have an easy command of gsutil rm-r and the name of the bucket. Here I am deleting the second bucket I created, and after that we'll list the buckets to see whether it was deleted or not. The same will be reflected on the website. Let me refresh this page. As you can see, we have only one bucket, which is the Edureka bucket. So now let's go ahead with Cloud SQL. Now Cloud SQL is a fully managed database service that makes it easy to set up, maintain, manage, and administer your relational, MySQL or PostgreSQL database in the cloud. Now Cloud SQL offers high performance, scalability, and convenience. Hosted on the Google Cloud Platform, the Cloud SQL provides a database infrastructure for application running anywhere. It is fully managed PostgreSQL database service and MySQL database service. The data is encrypted when stored in the database table. Now, Cloud SQL can be integrated with other services such as App Engine, the Compute Engine, and external services via the external IP. Now let's go ahead and see how we can work with the Cloud SQL. Go to the taskbar on the left hand side, tap on the SQL button, and here you'll be asked to create an instance which will be our SQL instance. Just tap on the button. Here you have the option to choose between MySQL and PostgreSQL. The PostgreSQL is in beta format, so I'll select MySQL. Now there are two options. First, we have the first generation and the second generation. Now second generation has 7 times the throughput and 20 times the storage capacity than the first generation. It is less expensive and it supports MySQL 5.6 and 5.7. Now in order to create your SQL instance, all you need to provide is the instance ID and set a root password. So the instance ID here is Edureka SQL 2 and the password. Now you need to select the region and the particular zone. And just tap on this create button and your SQL instance will be created within minutes. So now that our instance is created, let's go ahead and click on the instance ID. Now as you can see here, we have so many options like user, databases, authorization, SSL, backups, replicas, and operation. Now let's get to the user part. Here we can create a user account. By default we have a root user. So let's create a user. Just input your username and put in the password. And within seconds your user will be created. Now coming on to the database part, here we have the option to create a database. By default we have 3 databases, which are the information schema, MySQL, and the performance schema. Let me create a database employee. As you can see, creating a database is so easy. Now the database which we created and the instance we created can be accessed using the Google Cloud Shell as well as the Cloud SDK. So we'll see how we can access the same using the Cloud Shell. Now in order to connect your SQL instance to the Cloud Shell, all you need to type is gcloud SQL connect, the name of the instance and your username. The instance name is Edureka SQL 2 and the username is Crystal. As you can see, within minutes I was redirected to the MySQL shell of the instance. Now this MySQL shell works in the same way as any other MySQL. So let's first check the databases. So as you can see, we have the EMP database which I created just now. You can use this database and perform the same functions as a MySQL shell. Now, coming back to our services, next we have the Cloud Bigtable. Now, Cloud Bigtable is Google's NoSQL Big Data Database service. It is the same database that provides many core Google services, including search, analytics, maps, and Gmail. It provides massively scalable NoSQL database suitable for low latency and high throughput workloads. It integrates easily with popular big data tools like Hadoop and Spark, and it supports the open source industry-based standard HBase API. Now, Cloud Bigtable is a great choice for both operational and analytical applications, including IoT, user analytics, and financial data analytics. You can use Bigtable as the storage engine for large-scale, low-latency applications, as well as throughput-intensive data processing and analytics. Now, Bigtable provisions and scales to hundreds of petabytes automatically, and it can smoothly handle millions of operations per second. Changes to the deployment configuration are immediate, so there is no downtime during the reconfiguration. Cloud Bigtable stores data in tables, which contains row. Each row is identified by a row key. It is the same as any NoSQL database. Now, data in a row is organized into column families or groups of columns. A column qualifiers identifies a single column within a column family. A cell is the intersection of a row and a column, and each cell can contain multiple versions of a value. Now, working with Cloud Bigtable, there are two ways. We have the HBase, which is the shell-based tool, and we have CBT, which is the command line tool written in Go. Now, let's go ahead and see how we can work with Cloud Bigtable. Just go to the storage section, click on Bigtable, and here you have the option to create an instance. Just tap on that button, and here you can see you have to provide your instance name. Instance ID is automatically created. Now you have the instance type, which is either production or development. Now, production is not preferred unless and until you have a very high availability requirement with a minimum number of 3 nodes. Plus, it cannot be downgraded. Now, development seems to be the best choice if you want a low-cost instance for development and testing, though it does not provide high availability, but it can be upgraded to production later. Now we need to select the zone. You have to select the storage type, which can be either SSD or SSD. Now, SSD has a lower latency and higher read QPS, which is query per second. Just tap on the create button, and within seconds, your instance will be created. So guys, as you can see here that I have created an instance, which is Edureka-BT, the Bigtable instance. Now, let's go ahead and fire up this instance using the Cloud Shell. First of all, we need to enable the APIs, which is the Cloud Bigtable API and the Cloud Bigtable Admin API. For that, we need to select the project here. Let me select my project. Now, the APIs are enabled, and I've created the instance. All we need to do is open the Cloud Shell now. So guys, as you can see here, it automatically connects to the GitHub repository of the Google Cloud Platform. And now to connect our project to the Google Cloud Platform, all we need to do is type in the command gcloud-config set project and the project ID. Let me just copy the project ID. And now to start the HBase shell, we need to type in the command quickstart.sh. As you can see, it throws an error that you cannot perform this action because you don't have the permission to modify the Google Cloud SDK installation directory. But instead, they rerun the command with sudo. As you can see, it is scanning for the projects and downloading the projects from the Maven repository. It's building the quick start with the snapshots. And in a moment, you'll be connected to the HBase shell. So guys, as you can see here, now that we have entered the HBase shell, now we need to create a table with a column family CF1. All we need to do is type in this command, create the name of the table, which is EMP, and the column family name. Now to list it, all we need to type is list, and it will list one row in the table EMP. Now to put the value of any value in a row R1, suppose, using the column family CF1, and the column qualifier C1, all we need to do is put in this command. The row number, which is R1, the column family, which is CF1, column qualifier C1, and the value to be inserted. First of all, I'll be inserting a value. Okay, now let's insert another value. And to see the values inside a particular table, all you need to do is type in the command scan and the table name. As you can see here, in the R1 row, let me put in another value in the row R2 and scan again. You'll see that we have two rows, each of which have the values. In the column family 1, we have the timestamp and the value written as Edureka GCP2. Now to drop the table, there are two commands to be inserted, which is disable the table name. I'll put in as disable emp, and the second one is drop emp. Now when I list the tables, it will show me 0 tables. So the same can be implemented via the CBT, which is the command line using the go command. So let's go back to our presentation. Now next we have the Cloud Data Store. The Cloud Data Store is a NoSQL document-oriented database built for automatic scaling, high performance, and ease of application development. Cloud Data Store features include automatic transaction, which implies that operations will either all succeed or none will occur. High availability of reads and writes, massive scalability and high performance, flexible storage and querying of data. We have the balance of strong and eventual consistency, encryption at rest. The Cloud Data Store automatically encrypts all the data before it is written to the disk and automatically decrypts the data when read by an authorized user. Now, Cloud Data Store is ideal for applications that rely on high availability structured data at scale. You can use the Cloud Data Store to store and query all types of data. You can use it for product catalogs that provide real-time inventory and product details for a retailer. User profiles that deliver a customized experience based on the user's past activities and preferences. The transactions based on asset properties, for example, transferring funds from one bank account to another. Now, data objects in Cloud Data Store are known as entities, and an entity has one or more named properties, each of which can have one or more values. Entities of the same kind do not need to have the same properties, and an entity's value for a given property do not need to be of the same data type. Cloud Data Store supports a variety of data types for property values. These include the integers, floating point number, strings, dates, and binary data. Each entity in the Cloud Data Store has a key that uniquely identifies it. The key consists of the following components. Let us see. So first, let's select a location. Now, entities are nothing but data objects in the Cloud Data Store, as I mentioned earlier. Now it is setting the region, and we'll have to input the following identifiers for a particular entity. We have the namespace of the entity, which allows it for multi-tenancy, the kind of the entity, which categorizes it for purposes of Cloud Data Store queries. We have an identifier for the individual entity, which can either be a key or an integer. An optional ancestor path locating the entity within the Cloud Data Store hierarchy. As you can see here, we have the namespace, the kind, the key identifier, and the properties to be added. So let's input the name. The kind I'm entering is a demo, which will easily help me categorize it for future purposes. Now, key identifier can be numeric ID or a custom name. Just tap on the create button. Now you have two options, which are query by kind or queried by GQL. You can add properties such as, for the name, I'll enter type string. You can add another property. Just click on the save button. Now you have two options here, query by kind or query by GQL. You can filter the entities here, apply filter, which is the key ID is an integer equal to 500. Applying filters, you will get the following output. Now that we have seen Cloud Data Store, let's go ahead and have a look at the Cloud Spanner. Now, Cloud Spanner is a fully managed mission-critical relational database service that offers transactional consistency at a global scale, schemas, SQL, and automatic synchronous replication for high availability. Now, Cloud Spanner is the only enterprise-grade global distributed and strongly consistent database service built for the cloud specifically to combine the benefits of both relational database structures with the non-relational based horizontal scale. This combination delivers high-performance transactions and strong consistency across rows, regions, and continents with an industry-leading 99.99% availability SLA, no planned downtime, and enterprise-grade security. Now, as you can see here, the spanner gives a certain advantages over traditional relational database as well as traditional non-relational database. As you can see in the traditional relational, we cannot have high availability as well as scalability. And in traditional non-relational, we cannot have a particular schema and we do not use SQL. But in Cloud Spanner, we have the benefits of both the traditional relational and the traditional non-relational. Now let's go ahead and work with Google Cloud Spanner. Just go to the spanner. It automatically enables the Cloud Spanner API for your project, so you do not have to do it manually. So now let's go ahead and create an instance. You can write the instance name. You can select the configuration of regional or multi-regional. You can select the number of nodes. Just tap on the create button and it will create a Cloud Spanner instance for you. So Spanner is very easy. You just need to tap on create database button and it will create a database. You can add a table. You can add columns here. You can also add columns here. So suppose you want to add the ID also. You can set the primary key. Just tap on the create button. And Spanner will automatically create the database for you. You can monitor your database or you can change the database. You can also query in a database. You can run a query from here or you can add it just by selecting the particular database and you can edit the schema. You can either add a column or delete a column or you can add values. Now that we have seen the Cloud Spanner, here are some other useful cloud storage options. We have the persistent disk, Cloud BigQuery, and the Google Drive. Now, persistent disk is a high-performance block storage service suitable for virtual machines and container storage. It offers unmatched price to performance ratio. You only pay for the capacity and you are never charged for the provision IOPS. Additionally, persistent disk offers multi-readers, mounts, and on-demand volume resizing to simplify operations. Now, BigQuery is Google's fully managed low-cost analytics data warehouse. It is serverless and there is no infrastructure to manage, no need to guess the needed capacity or over-provision, and you do not need a database administrator. You can focus on analyzing data to find meaningful insights. Now, finally, Google Drive is a collaborative space for storing, sharing, and editing files, including Google Docs, with a 15 GB of storage space available for free accounts. Now that we have seen all the services provided by GCP, let's see exactly where and when these services are being used. As different applications and workloads require different storage and database solutions, Google offers a full suite of industry-leading storage services that are price-performant and meet your needs for structured, unstructured, transactional, and relational data. The image given here helps you identify the solutions that fit your scenarios, whether they are mobile application, hosting commercial software, data pipelines, or storing backups. Now you might be wondering what is Google Cloud Storage for Firebase. Now Firebase, mobile and web access to Google Cloud Storage with serverless third-party authentication and authorization. Now let us see when these storage are used and in which scenarios. First, if we want to store a blob type, we use the cloud storage to use images, pictures, videos, objects, and unstructured data. When we come to NoSQL, we have the Cloud Data Store and the Cloud Bigtable. Cloud Data Store is used for hierarchical data, and Cloud Bigtable is used for low latency read and write access and high throughput analytics. Coming to SQL, we have the Cloud SQL, which is the web framework for structured data, and Cloud Spanner, which is used for mission critical applications and high transactions. Now, cloud storage, the examples are storing and streaming multimedia, storing for data analytics load, and disaster recovery. Coming on to cloud data store, it is used for user profiles, product catalogs, and game state. Now, Cloud Bigtable is used for IoT, finance, personalization, recommendation, monitoring, and graphs. Cloud SQL is used for blogs, content management, websites, business intelligence application, CRM, ERP, and e-commercial application. Coming on to Cloud Spanner, it is used for financial service which are mission critical, global supply chain, and retail. Now we are left with the persistent disk. And persistent disks are used for virtual machines to share read-only access data across VMs. It is used as a backup of running VMs. Now BigQuery is used for large data analytical reporting, data science and analysis, and big data processing using SQL.
Why Firebase is used. Firebase is a Google-backed application development software that enables developers to develop iOS, Android, and web applications. When you will get into the depth of application development on any platform, you will realize that you have some great ideas, but you don't have the resources to make those ideas a reality. Consider this. You want to make a web page and you will need to host it at some point of the time, for which you will need a server. But building your own custom server is a lot of pain for a front-end developer. Not only will you have to buy and keep your server online 24/7, but also create and manage the databases. This is where Firebase comes to rescue. It not only takes care of all the problems that I just mentioned, but also provides you with lots of features that you can play with. Let's take a brief look at some of them. Firebase is based on a data structure used by the NoSQL database, which is vastly different from those used in relational databases. Some operations are faster in NoSQL than relational databases like MySQL. As developers, you don't need to worry about the server-side software. Mobile and web SDKs enable this. The main offering is real-time sync of data between client apps and Firebase via real-time database and Cloud Firestore. Using authentication, user authentication feature is easy to build, even if it involves third-party providers such as Facebook or Twitter. Messaging and notifications are efficiently done using Firebase Cloud Messaging or FCM. Unlike native apps updated via app stores, Remote Config can update Firebase apps without asking the user to update their installation. Using Crashlytics and performance monitoring, app stability and performance can be improved. There's a good integration with adverbs and admob. Even UI testing across multiple devices is simplified via test labs. Now that we know why Firebase is so extensively used, let's take a look at what is Firebase. Modern web and mobile apps are typically built with a mix of backend services and front-end frameworks. Wouldn't it be nice if there was a way for developers to focus on just the front-end and user experience and let someone else take care of all the backend requirements? It's exactly in this context that backend as a service has emerged, that is Firebase. Traditional app development typically involves writing both front-end and backend software. The front-end code just invokes the API endpoints exposed by the backend, and the backend code actually does the work. But with Firebase, your app accesses those servers directly or allows you to write APIs to handle that, if needed. Now that we know what Firebase is, let's take a look at the features of Firebase. First is built-in analytics. Google Analytics for Firebase is a free app measurement solution that provides insight on app usage and user engagement. After you integrate the Firebase SDK with your app, basic app usage data is collected automatically and is available in Google Analytics and Google Analytics for Firebase. You don't need to add any code to enable automatically collected events, such as how many first opens, session starts, or in-app purchases you've had. This lets you see how much time users have spent in your app, how many users were active during a certain period of time, and how often in-app purchases were made. Next feature is app development made easy. Firebase offers a suite of tools required for businesses to build powerful applications without having to worry about the management of infrastructure. It is designed to support backend developers at all stages of development and helps in improving the quality of the overall app development exercise. It provides a host of features and modules that an app developer needs as a service, thereby eliminating the need to create these from scratch. Firebase is in no way a replacement for backend development activity, but it is rather a platform to help backend developers and engineers enhance the experience of the app without stressful coding and architectural planning. Our next feature is growth and user management. When you link your ads account to a Firebase project, you can create mobile application marketing lists based on analytics audiences. You can create audiences in Firebase using any combination of events and user properties, and then use those audiences to run targeted ad campaigns. For example, you can create an audience of Android users who live in Canada and then run ad campaigns directed at the users included in this audience. Yes, it's that simple. Our next feature is emulator suites. The Firebase local emulator suite consists of individual service emulators built to accurately mimic the behavior of Firebase services. This means you can connect your app directly to these emulators to perform integration testing or QA without touching production data. We need the Firestore emulator to safely read and write documents in testing. Since all services are connected to the local environment, these triggers the event in each other's services. Now let's take a look at the Firebase interface. After you make a project, this is what your interface will look like. I'll be showing you how we got here, but for now, let's understand what all Firebase has to offer. First, what we see here is build. In build, we have authentication, Firestore database, and so on. First is Firebase authentication. Firebase authentication provides backend services, easy to use SDKs, and ready-made UI libraries to authenticate users to your apps. Normally, it would take you months to set up your own authentication system. And even after that, you would need to keep a dedicated team to maintain that system. But if you use Firebase, you can set up the entire system in under 10 lines of code that will handle everything for you, including complex operations like account merging. Let's click on authentication. We can see here users, sign-in methods, templates, and usage. Users are nothing but the number of people logged in to your database. Every single user has a unique ID, which we can use to change the rules. In sign-in methods, we can see a number of providers which we can incorporate in our applications, and it's really easy. All we have to do is add new provider and enable it. Let's take a look at the Firestore database. Firestore database is nothing but the Cloud Firestore, which is a NoSQL document database that lets you easily store, sync, and query data for your applications. Since this is a NoSQL document-oriented database, there are no tables or rows. Instead, you can store data in documents which are organized in collections. Each collection contains a set of key value pairs. We also have security rules here. Security rules provide access control and data validation in a simple yet expressive format. To build user-based and role-based access systems that keeps your users' data safe, you need to use Firebase authentication with Cloud Firestore security rules. All Cloud Firestore security rules consist of match statements which identify documents in your database and allow expressions which control access to those documents. Every database request from a Cloud Firestore mobile or web client library is evaluated against these security rules before reading or writing any data. If the rules deny access to any of the specified document paths, the entire request fails. Next is real-time database. The real-time database is really just one big JSON object that the developers can manage in real time. With just a single API, the Firebase database provides your apps with both the current value of the data and any updates to that data. Real-time syncing makes it easier for your users to access their data from any device. So let's create a database here. We can select the location as, let's keep it default for now. Click on next and we'll start this in test mode and enable this. So this will create our real-time database. Real-time syncing makes it easy for your users to access their data from any device, be it web or mobile, meaning it lets you sync your data on any platform. When your users go offline, the real-time database SDKs use local cache on the device to serve and store changes. When the device comes online, the local data is automatically synchronized. Its interface is similar to that of Cloud Firestore, consisting of data security rules, which we can change according to the need of our project. Next is storage. Firebase Storage is a standalone solution for uploading user-generated content like images and videos from an iOS and Android device as well as the web. Firebase Storage is designed specifically to scale your apps, provide security, and ensure network resiliency. Firebase Storage uses a simple folder or file system to structure its data. You can easily upload the required files from your system and it can be accessed from any device. We can also have rules here which play the same function as we saw in the Cloud Firestore and real-time database. Next is Firebase Hosting. It is a secure global web hosting CDN or content delivery network which is really good at quickly delivering static content like HTML, CSS or JavaScript. Next is Firebase Hosting. It is a secure global web hosting CDN or content delivery network which is really good at quickly delivering static content like HTML, CSS or JavaScript using servers that are close to your users. And you can get it set up quickly with or without your custom domain, along with a provisioned SSL certificate that costs you nothing. Hosting dashboard gives you information about the domains and the deployment status of your applications. Let's click on Get Started here. Click on Next. Click on Next. Continue to console, and this is what the console will look like later. Hosting dashboard gives you information about the domains and deployment status of your application. Okay. Next we have here is the Cloud Functions. Firebase Cloud Functions refer to a serverless framework that enables developers to execute backend code for responding to HTTPS and Firebase feature triggered events. Google Cloud is used for storing TypeScript or JavaScript code and can be executed within a managed environment. This reduces the requirement for scaling and managing servers. Cloud Functions are only available on the Blaze plan, and a user cannot try the service under the Spark plan. It is important to emphasize a free quota for Cloud Functions, but charges will happen under the Blaze plan as soon as the user exceeds the free limit. We will learn more about Blaze and Spark plans as the session progresses. For now, you just need to understand that to use Cloud Functions, you need to upgrade your project from Spark plan to Blaze plan. Next we have is Machine Learning. Firebase Machine Learning is a mobile SDK that brings Google's machine learning expertise to Android and Apple apps. It is a powerful yet easy to use package. Whether you are new or experienced in machine learning, you can implement the functionality you need in just a few lines of code. Let's move on. Under Release and Monitor, we have Crashalytics, Performance, Test Labs, and App Distribution. Crashalytics is a real-time crash reporting tool that helps you prioritize and fix your most pervasive crashes based on the impact on real-time users. Crashalytics can also be easily integrated into your Android, iOS, Mac OS, tvOS, and watchOS applications. Next is Test Labs. Firebase Test Labs have this amazing service called RoboTest. This allows us to test our app without having to write any test scripts. With RoboTest, we can have Firebase test your app completely, even fill in specific form fields and push buttons. Moving along, under Analytics, we have Dashboard, Real-Time Events, Conversations, and so on. Analytics surfaces data about user behavior in your iOS and Android applications, enabling you to make better decisions about your product and marketing optimization. In Engage, we have tabs like Prediction, A/B Testing, Cloud Messaging, etc. Under A/B Testing, this helps you improve your app by making it easy to run, analyze, and scale products and marketing experiments. Through Firebase, you can test your application's user interface features that you might have added. Let's move on to Cloud Messaging. Firebase Cloud Messaging or FCM provides a reliable and battery-efficient connection between your server and devices that allows you to deliver and receive messages and notifications on any device for free. Next is Remote Config. Remote configuration essentially allows us to publish updates to our users immediately. Whether we wish to change the color scheme for a screen, the layout for any particular section in our application, or show promotional or seasonal options, this is completely doable using the server-side parameters without the need to publish a new version. Now that we know the Firebase console, let's take a look at a little hands-on in which we will build a website from scratch and use Firebase functions on it. Let's take a look at the Firebase pricing plans. So Firebase has two major plans. One that is free is called a Spark plan, and the other one is called a Blaze plan, which is pay as you go. Spark plan offers 1 GB total storage, 22K writes per day, 52K reads per day, and 22K deletes per day. Blaze plan charges 0.18 per GB, which is 13 rupees per GB for database storage, 0.026 per GB, which is roughly 2 rupees per GB for application storage, and additional charges for database operations and data transfer. Firebase provides 10,000 authentications per month, and beyond that charges a different rate depending on our region. Cloud Firestore provides a total of 1 GB storage. In the Blaze plan, there is a charge for storage, space, and database operations are priced separately. The Firebase real-time database provides free and unlimited reads and write operations. Google hosts your Firebase app free in the Spark plan, and in the Blaze plan charges a modest fee per GB of application data stored and data transferred. Both plans provide free SSL and multiple sites per project. The Google Machine Learning Kit is available in Firebase for up to 1000 images per project and can be useful for a variety of image processing tasks. Google Test Lab is available 5 times a day for real devices and 10 times a day for virtual devices. Firebase provides the usage tab in its console, which shows the status of your payment and usage for various Firebase services. To sum it up, the pricing plan, that is the Spark plan, incorporates a limited free tier, and it's an excellent option for development and small applications. The second tier, which is the Blaze plan, works on a pay-as-you-grow model, and it's ideal for production applications. Now let's take a look at the companies using Firebase. Famous companies like Trivago, Duolingo, the New York Times use Firebase for application development, analytics, and other database features. One of the reasons why Firebase is so widely used is because Firebase needs minimal coding knowledge and recommends integration through its user interface. This feature eliminates the requirement for complex configurations and allows you to easily set up the platform. Now let's take a look at some of the use cases. Creates an onboarding flow. Firebase enables the developers to programmatically create dynamic links with custom parameters. Creating a tailored custom onboard UI for the user when he or she navigates to the application by clicking on the custom link. With open authorization on-auth feature, users can sign into your app via Facebook, Twitter, GitHub, or Google. This cuts down the hassle of manually inputting user details in the sign-up form. eventually improving the user onboarding rate by lots. Rolling out new features progressively. Development teams can roll out new features to a limited group of users, get user feedback, run a thorough testing, and when everything is fine, roll out the features on a larger scale. Follow the user journey across devices. We often or always use the same applications via mobile, desktops, and tabs, or any devices. Firebase facilitates a smooth management of user sessions and user activity across several devices. Optimize ads based on user behavior. With the help of Google Analytics, development teams can monitor the user behavior and accordingly display related advertisements in their applications. Manage third-party payments without setting up your own servers. To enable in-app purchases, Firebase helps developers streamline the third-party payment API integration process without any need for setting up and managing our own servers to run the payment feature.
Now let's have an introduction of database. First, let's understand why do we need a database. A good database is crucial to any company or organization. This is because the database stores all the pertinent details about the company, such as employee records, transactional records, salary details, etc. The various reasons a database is important are: it manages large amounts of data. A database stores and manages a large amount of data on a daily basis actually. This would not be possible using any other tools such as a spreadsheet, as they would simply not work. Second, its accuracy. A database is pretty accurate as it has all sorts of built-in constraints, checks, etc. This means that the information available in a database is guaranteed to be correct in most cases. Third, it's easy to update. So in a database, it is easy to update data using various data manipulation languages available. One of these languages is SQL. Fourth, the security of data. So databases have various methods to ensure security of data. There are user logins required before accessing a database and various access specifiers. These allow only authorized users to access the database. Fifth is data integrity. So this is ensured in databases by using various constraints for data. Data integrity in databases makes sure that the data is accurate and consistent in a database. Last one, that is easy to research database. So if you see, like, it's very easy to research and access the data in database. This is done using a data query language, which allows searching of any data in the database and performing computations on it. Now that you have understood the need of a database, let's briefly understand what actually it is. So a database is an organized collection of structured information or data typically stored electronically in a computer system. A database is usually controlled by a database management system. Together, the data and the database management system, along with the applications that are associated with them, are referred to as a database system, often shortened to just database. Data within the most common types of databases in our operation today is typically modeled in rows and columns. In a series of tables to make processing and data querying efficient, the data can then be easily accessed, managed, modified, updated, controlled, and organized. Most databases uses structured query language, means SQL, for writing and querying data. Databases are used to support internal operations of organizations and to underpin online interactions with customers and suppliers. Databases are used to hold administrative information and more specialized data such as engineering data or economic models. Examples include computerized library systems, flight reservation systems, or computerized parts inventory system, and many content management systems that store websites as collections of web pages in a database. Now that you have an overview of Google Cloud Platform as well as of a database, now let's understand the different types of GCP databases. So the first is relational databases. A relational database is a type of database that stores and provides access to data points that are related to one another. Relational databases are based on relational model, an intuitive, straightforward way of representing data in tables. In a relational database, each row in the table is a record with a unique ID called the key. Columns of the table hold attributes of the data, and each record usually has a value of each attribute, making it easy to establish the relationships among data points. In a relational database, all data is stored and accessed via relations. Relations that store data are called base relations, and in implementations are called tables. Other relations do not store data, but are computed by applying relational operations to other relations. These relations are sometimes called derived relations. In implementations, these are called views or queries. Derived relations are convenient in that they act as a single relation, even though they may grab information from several relations. Each relation or table has a primary key, this being a consequence of a relation being a set. A primary key uniquely specifies a tuple within a table. While natural attributes, I mean attributes used to describe the data being entered, are sometimes good primary keys. A foreign key is also there in a relational database management system. So a foreign key is a field in a relational data table that matches the primary key column of another table. It relates the two keys. Foreign keys need not have unique values in the referencing relation. A foreign key can be used to cross-reference tables, and it effectively uses the values of attributes in the reference relation to restrict the domain of one or more attributes in the referencing relation. Second is key value databases. So a key value database or key value store is a data storage paradigm designed for storing, retrieving, and managing associative arrays, and a data structure more commonly known today as a dictionary or hash table. Dictionaries contain a collection of objects or records which in turn have many different fields within them, each containing data. Okay, so these records are stored and retrieved using a key that uniquely identifies the record and is used to find the data within the database. So key value databases work in very different fashion from the better known relational databases. Relational databases predefine the data structure in the database as a series of tables containing fields with well-defined data types. Exposing the data types to the database program allows it to apply a number of optimizations. In contrast, key value system treats the data as a single opaque collection which may have different fields for every record. This offers considerable flexibility and more closely follows modern concepts like object-oriented programming. Because optional values are not represented by placeholders or input parameters, as in most relational databases, key value databases often use far less memory to store the same database, which can lead to large performance gains in certain workloads. Because optional values are not represented by placeholders or input parameters, as in most relational databases, key value databases often use far less memory to store the same database, which can lead to large performance gains in certain workloads performance. A lack of standardization and other issues limited key value systems to niche uses for many years. But the rapid move to cloud computing after 2010 has led to a renaissance as part of the broader NoSQL movement. Now, the third one is document database. So, a document-oriented database or document store is a computer program and data storage system designed for storing, retrieving, and managing document-oriented information, also known as semi-structured data. Document-oriented databases are one of the main categories of NoSQL databases, and the popularity of term document-oriented database has grown with the use of the term NoSQL itself. XML databases are a subclass of document-oriented databases that are optimized to work with XML documents. Graph databases are similar but add another layer, the relationship which allows them to link documents for rapid traversal. Document-oriented databases are inherently a subclass of the key value store, another NoSQL database concept. So the difference lies in the way the data is processed. In a key value, the data is considered to be inherently opaque to the database, whereas the document-oriented system relies on internal structure in the document in order to extract metadata that the database engine uses for further optimization. Although the difference is often negligible due to tools in the systems, conceptually, the document store is designed to offer a richer experience with modern programming techniques. So, document databases contrast strongly with the traditional relational database. Like relational databases generally store data in separate tables that are defined by the programmer, and a single object may be spread across several tables. So document databases store all information for a given object in a single instance in the database, and a very stored object can be different from every other. This eliminates the need for object relational mapping while loading data in the database. So the fourth we have is in-memory database. And in-memory database, IMDB, also a main memory database system, or MMDB, you can say it like a memory resident database, is a database management system that primarily relies on main memory of a computer data storage. It is contrasted with database management systems that employ a disk storage mechanism. So in-memory databases are faster than disk optimized databases because disk access is slower than memory access. The internal optimization algorithms are simpler and execute fewer CPU instructions. So accessing data in memory eliminates seek time when querying the data, which provides faster and more predictable performance than disk. Applications where response time is critical, such as those running telecommunication, network equipment, and mobile advertising networks, often main memory databases. So, in-memory databases have gained much traction, especially in the data analytics space started in the mid 2000s, mainly due to multi-core processors that can address large memory and due to less expensive RAM. A potential technical hurdle with in-memory data storage is the volatility of RAM. So specifically in the event of a power loss, intentional or otherwise, data stored in the volatile RAM is lost. With the introduction of non-volatile random access memory technology, in-memory databases will be able to run at full speed and maintain data in the event of power failure. Now the last one is additional NoSQL databases. Like a NoSQL database provides a mechanism for storage and retrieval of data that is modeled in means other than the tabular relations used in the relational databases. So there are additional NoSQL databases present in GCP like MongoDB and others. So now that you have understood the types of databases, let's now understand services under these types of databases. So first we have relational databases, under which we have Cloud SQL and Cloud Spanner. So Cloud SQL is a fully managed database service that makes it easy to set up, maintain, manage, and administer your relational MySQL databases on cloud platform. The Cloud SQL for MySQL connector allows you to access data from Cloud SQL for MySQL databases within Data Studio. So its key features are like fast and easy migration. So database migration service makes it easy to migrate databases from on-premises compute engine and other cloud to Cloud SQL with minimal downtime. So second is secure access and connectivity. So Cloud SQL data is encrypted when on Google's internal networks and when stored in database tables or temporary files and backups. So Cloud SQL supports private connectivity with virtual private cloud. And every Cloud SQL instance includes a network firewall allowing you to control public network access to your database instance. Third is easy integration. So access Cloud SQL instance from just about any application. Easily connect from App Engine, Compute Engine, Google Kubernetes Engine, and your workstation. Open up analytics possibilities by using BigQuery to directly query your Cloud SQL databases. Then fourth is standard APIs. So build and deploy for the cloud faster because Cloud SQL offers standard MySQL or PostgreSQL and SQL Server databases, ensuring application compatibility. So use standard connections drivers and build the migration tools to get started quickly. Then fifth is application compatibility. So build and deploy for the cloud faster because Cloud SQL offers standard MySQL or PostgreSQL and Microsoft SQL Server databases, ensuring application compatibility. Then the last one is automatic storage increment. So Cloud SQL can automatically scale up storage capacity when you are near your limit. This way you don't have to spend time estimating future storage needs or spend money on capacity until you need it. Now the question is when to choose Cloud SQL. From lift and shift of on-premise SQL databases to the cloud to handling large-scale SQL data analytics to supporting CMS data storage and scalability and deployment of microservices, Cloud SQL has many uses and is a better option when you need relational databases capabilities, but don't need storage capacity over 10 TB. I mean 10 terabytes. Now coming to Cloud Spanner. So Spanner is a distributed SQL database developed by Google. Spanner is a globally distributed database service and storage solution. It provides features such as global transactions, strongly consistent reads, and automatic multi-site replication and failover. Its key features are first, auto sharding. Cloud Spanner optimizes performance by automatically sharding the databases on request load and size of the data. As a result, you can spend less time worrying about how to scale your database and instead focus on scaling your business. So second is it is fully managed, which means easy deployment at every stage and for any size databases. Synchronous replication also synchronous replication and maintenance are automatic and built in. The third one is it has regional and multi-regional configurations. No matter where your users may be, apps backed by Cloud Spanner can read and write up-to-date, strongly consistent data globally. Additionally, when running a multi-region instance, your database is able to survive a regional failure and offers industry-leading 99.99% availability. So fourth is built on Google Cloud Network. Cloud Spanner is built on Google's dedicated network that provides low latency, security, and reliability for serving users across the globe. Fifth is it provides multi-language support. So client libraries in C, C++, Go, Java, Node.js, PHP, Python, and Ruby, JDBC drivers for connectivity with popular third-party tools. Last is backup and restore. Backup and restore recovers the database to the last state when the backup or the export was taken. PITR provides continuous data protection with the ability to recover your past data to a microsecond granularity. Now the question is when to choose Cloud Spanner. So Cloud Spanner should be your go-to option if you plan on using large amounts of data, more than 10 terabyte, and need transactional consistency. It is also a perfect choice if you wish to use sharding for higher throughput and accessibility. Now the next is a key value database under which Google provides big table service. So Bigtable is a compressed high-performance proprietary data storage system built on Google File System, Chubby Log Service, SST table, and a few other Google technologies. Some of its key features are: it is built for use cases such as personalization, edtech, fintech, digital media, and IoT. Second is it gives better prediction. Designed with a storage engine for machine learning applications, leading to better prediction. Third is high throughput at low latency. So Bigtable is ideal for storing very large amounts of data in a key value store and supports high read and write throughput at low latency for fast access to large amounts of data. Throughput scales linearly. You can increase QPS, means queries per second, by adding Bigtable nodes. So Bigtable is built with proven infrastructure that powers Google products used by billions such as search and maps. Then fourth is the cluster resizing without downtime. Scale seamlessly from thousands to millions of reads or writes per second. Bigtable throughput can be dynamically adjusted by adding or removing cluster nodes without restarting, meaning you can increase the size of a Bigtable cluster for a few hours to handle a large load, then reduce the cluster's size again, all without any downtime. Like, it's flexible and automated replication to optimize any workload. So write data once and automatically replicate where needed with eventual consistency, giving you control for high availability and isolation of read and write workloads. No manual steps needed to ensure consistency or repair data or synchronize writes and deletes. Benefit from a high availability SLA of 99.999% for instances with multi-cluster routing across 3 or more regions, 99.9% for single cluster instances. So next is it easily connect to Google Cloud services such as BigQuery or the Apache ecosystem. Last is it seamlessly scaled to match your storage needs, so no downtime during reconfiguration. Now the question is when to choose Bigtable. So Cloud Bigtable is a good option if you are using large amounts of single key data and is preferable for low latency, high throughput workloads. Moving on to the next type of services, that is document database services, under which we have Cloud Firestore and Firebase. So Cloud Firestore is a cloud-hosted NoSQL database that your iOS, Android, and web apps can access directly via native SDKs. Cloud Firestore is also available in native Node.js, Java, Python, Unity, C++, and Go SDKs in addition to REST and RPC APIs. It is a flexible, scalable database for mobile, web, app, and server development from Firebase and Google Cloud. Some of its key features are: first of all, it is serverless, which helps you in focusing on your application's development using a fully managed serverless database that effortlessly scales up or down to meet any demand with no maintenance windows or downtime. Second is live synchronization and offline mode. Built-in live synchronization and offline mode makes it easy to build multi-user collaborative applications on mobile, web, and IoT devices, including workloads consisting of live assist tracking, activity tracking, real-time analytics, media, and product catalogs, communications, social user profiles, and gaming leaderboards. Third is powerful query engine. Firestore allows you to run sophisticated ACID transactions against your document data. This gives you more flexibility in the way you structure your data. Fourth is libraries for popular languages. Focus on your application development using Firestore client-side development by libraries for web, iOS, Android, Flutter, C++, and Unity. So Firestore also supports traditional server-side development libraries using Node.js, Java, Go, Ruby, and PHP. Fifth is security. The Firestore seamlessly integrates with Firebase authentication and identity platform to enable customizable identity-based security, access controls, and enables data validation via a configuration language. So the last one is data store mode. Firestore supports the data store API. You won't need to make any changes to your existing data store apps, and you can expect the same performance characteristics and pricing with the added benefit of strong consistency. Existing cloud data store databases will be automatically upgraded to Firestore in the next year of 2022 also. So now the question is when to choose Firestore. When your focus lie on app development and you need live synchronization and offline support. Now coming to Firebase real-time database. Over the last few years, Firebase has grown to become Google's app development platform. It now has 16 products to build and grow your app. If you have used Firebase before, you know it already offer a database which is the Firebase real-time database. So the Firebase real-time database with its client SDKs and real-time capabilities is all about making app development faster and easier. Since its launch, it has been adopted by hundreds of thousands of developers, and as its adoption grew, so did usage patterns. Let's discuss some of its key features. So, first of all, it provides real-time synchronization for JSON data. So, developers began using the real-time database for more complex data and to build bigger apps. pushing the limits of the JSON data model and the performance of the database at scale. The Firebase Real-Time Database is a cloud-hosted NoSQL database that lets you store and synchronize data between your users in real time. In its new update, Cloud Firestore enables you to store, synchronize, and query app data at global scale. Second is like collaborate across devices with ease. So real-time synchronization makes it easy for your users to access their data from any device, web or mobile, and it helps your users collaborate with one another. Third is build serverless apps. So real-time database ships with mobile and web SDKs, so you can build applications without the need of servers. You can also execute backend code that responds to events triggered by your database using cloud functions for Firebase. Fourth is optimized for online use. So when users go offline, the real-time database SDKs use local cache on the device to serve and store changes. When the devices come online, the local data is automatically synchronized. The last one is strong user-based security. The real-time database integrates with Firebase authentication to provide simple and intuitive authentication for developers. You can use Google's declarative security model to allow access based on user identity or with pattern matching on your data. So the use cases for Firebase real-time database involve development of applications that work across devices, advertisement optimization and personalization, and third-party payment processing. Now moving on to the next type of service, that is in-memory database services, under which Google provides memory store. So memory store reduces latency with scalable, secure, and highly available in-memory service for Redis and Memcached. Memory store automates complex tasks for open source Redis and Memcached, like enabling high availability, failover, patching, monitoring, so you can spend more time coding. Start with the lowest tier and smallest size, and then grow your instance with minimal impact. Memory store for Memcached can support clusters as large as 5 terabytes, supporting millions of QPs at very low latency. So memory store for Redis instances are replicated across two zones and provide a 99.9% availability SLA. Instances are monitored constantly and with automatic failover. Applications experience minimal disruption. Some of its key features are choice of engines. So choose from the two most popular open source caching engines to build your applications. Memory Store supports both Redis and Memcached and is fully protocol compatible. Choose the right engine that fits your cost and availability requirements. Second is security. So Memory Store is protected from the internet using virtual private cloud networks and private IP, and comes with the IAM integration, all designed to protect your data. Systems are monitored 24/7 and 365 days, ensuring your applications and data are protected. Third is it's fully managed. So provisioning, replication, failover, and patching are all automated, which drastically reduces the time you spend doing DevOps. Fourth is monitoring. So monitor your instance and set up custom alerts with cloud monitoring. You can also integrate with the open sensors to get more insights to client-side metrics. Fifth is it's highly available. So standard tier memory store for Redis instances provide a 99.9% availability SLA with automatic failover to ensure that your instance is highly available. You also get the same availability SLA for Memcached instances. Last is migration. So memory store is compatible with open source protocol, which makes it easy to switch your applications with no code changes. You can leverage the import and export feature to migrate your Redis and Memcached instance to Google Cloud. Now the question is when to choose a memory store. If you are using key value datasets and your main focus is transaction latency, then you can go for memory store. Now moving on to the last type of database services, that is additional NoSQL database services, under which we have MongoDB Atlas and Google Cloud Partner Services. So MongoDB is a source available cross-platform document-oriented database program classified as a NoSQL database program. MongoDB uses JSON-like documents with optional schemes, and MongoDB Atlas is the best way to deploy, manage, and grow MongoDB on Google Cloud. Engineered and run by the same engineers that build the database, Atlas incorporates best practices developed from supporting thousands of distributed deployments into an easy to use, fully automated service that grants you the power and freedom to focus on what really matters, building and optimizing your applications. Its key features are: first, its database operations are automated, as database operations take time, and so MongoDB Atlas lowers your stress by orchestrating the moving parts, deploying clusters in minutes, modifying them on demand with zero downtime, and taking advantage of automated patches. So the second is highly scalable. So add storage, scale up, scale out, or scale down with the push of a button or a simple API call. MongoDB Atlas allows you to easily tweak the dimensions of your deployment with no impact to your applications. Third is comprehensive disaster recovery. So MongoDB Atlas includes an optional fully managed backup service that provides continuous backups with point-in-time recovery. Query your backup snapshots and restore granular datasets in a fraction of the time. Easily restore snapshots to different projects to rapidly spin up developer or test environments. Fourth, it's highly available backed by uptime SLAs. Each cluster is distributed across the zones in a Google Cloud region, ensuring no single point of failure. Should your primary fail, MongoDB Atlas will automatically trigger the election and failover process with no manual intervention required. Production databases are backed by 99.95 uptime SLA. Fifth is global clusters. So global clusters in MongoDB Atlas allow you to deploy a geographically distributed database that provides low latency, responsive reads and writes to users anywhere with strong data placement controls to satisfy emerging regulations. And the last one is full performance visibility and optimization. So MongoDB Atlas includes optimized dashboards that highlight key historical metrics, view performance in real time, customize alerts, or dig into the details with ease. So built-in tools such as the Performance Advisor highlight flow running queries and suggest indexes to help optimize your database. Now the next we have is Google Cloud Partner Services. So you can choose Google Cloud Partner Service on the basis of regions, specialization, expertise, initiatives, and products. But why work with a Google Cloud partner? So first of all, it's flexible. So Google Cloud's global network means you can work with a Google Cloud partner that best fits your organization's needs. The second is for the knowledge purpose, like collaborate with a partner that has the right industry background to unlock your next level of business growth. And the third and the last one is experience. So have the confidence to tackle your toughest business challenges with the support of a partner with proven success. So one more thing is like Google partners are the ones you can trust actually. So partners that have certified their teams, earned expertise, and achieved specialization have the Google validated skills to help you achieve your goals. So partners are divided in three forms. So first is specialization. So specialization is the highest technical designation a partner can earn. Partners who have achieved a specialization in a solution area have an established Google Cloud Service practice, consistent customer success, and proven technical capabilities vetted by Google and a third-party accessor. Like there is a specialization in application development, cloud migration, data analytics, data management, Internet of Things, machine learning, marketing analytics, etc. Second is expertise. So partners with the expertise designation have demonstrated proficiency and have exhibited customer success through the combination of experience in a specific industry, workload, or product. So for example, like there's an expertise in industry and expertise in Google Cloud product or technology and workload. Third is certification. So partners with teams of Google Cloud certified individuals have the validated technical knowledge and advanced skills to address your business's needs through implementing Google Cloud technologies. There are a lot of certifications like Foundational Digital Cloud Leader, Associate Cloud Engineer, Professional Cloud Architect, Professional Cloud Developer, Professional Data Engineers, and various others. Now let's look at some solutions provided by the GCP database. So the first one is database migration. Database migration is the process of selecting, preparing, extracting, and transforming data and permanently transferring it from one computer storage system to another. With Google Cloud, you can simplify your database migration at every step of your cloud journey. So migrate to Google Cloud databases to run and manage your databases at global scale while optimizing for efficiency and flexibility. There are two database migration strategies. First one is move to the same type of database. So lift and shift databases to Google Cloud using databases like Cloud SQL for MySQL, Cloud SQL for PostgreSQL, Cloud SQL for MySQL Server, Cloud Memory Store for Redis, and Cloud Bigtable, along with Google's open source partner databases like MongoDB, DataStax, Elastic, Neo4j, Influx Data, and Redis Enterprise. Database migration service for Cloud SQL can help to minimize downtime during migration. Second strategy is move to a new type of database. Whether you are moving from proprietary to open source databases or modernizing from traditional databases to scalable cloud native databases, we have a solution for you. Leverage your serverless change, data capture, and replication service data stream to synchronize data across databases, storage systems, and applications. Google's migration assessment guides and partners can help you get started. Now, moving on to the next solution, that is database modernization. So database modernization is primarily about changing applications to work around functional discrepancies between old and new databases. With Google Cloud, you can modernize underlying operational databases to make your apps more secure, reliable, scalable, and easier to manage. Our fully managed solutions reduce complexity and increase agility so you can focus on innovation. So you can upgrade the databases on which your applications are built on by being prepared for growth with quick seamless scaling, which means scale Google Cloud databases seamlessly and build cloud native apps that are prepared to handle seasonal surges or unpredictable growth. Second, move faster and focus on business value, which means enable developers to ship faster and perform less maintenance with database features like serverless management, auto scaling, and deep integrations. And the third one is build more powerful applications with Google Cloud. To transform your business with robust ecosystem of services like Google Kubernetes Engine, easily access data for analytics and AI/ML with BigQuery and Google Cloud AI. So the third database solution is open source databases. An open source database allows users to create a system based on their unique requirements and business needs. It is free and can also be shared. The source code can be modified to match any user preference. So open source databases address the need to analyze data from a growing number of new applications at lower cost. With Google Cloud fully managed, open source database promote innovation without vendor lock-in or high licensing fees. Google Cloud and our partners help you deploy secure open source databases at scale without managing infrastructure. So make the most of Google Cloud's commitment to open source by first line support. So Google provide first line support for open source databases so you can manage and log support tickets from a single window. Second is simple billing. So whether you are using NoSQL or relational databases, you will only see one bill from Google Cloud. Third is a single console. You can provision and manage partner open source database services straight from your Google Cloud console. Now, the last major GCP database solution is SQL Server on Google Cloud. So SQL Server is a relational database management system developed by Microsoft. As a database server, it is a software product with the primary function of storing and retrieving data as requested by other software applications, which may run either on the same computer or on other computer across a network. Its key features are lift and shift SQL Server. So migrate your existing workloads to Cloud SQL or Cloud Server running on Compute Engine with full compatibility. SQL Server running on Google Cloud works with all of your familiar tools like SSMS and Visual Studio. Connect your existing workloads to the best of what Google Cloud has to offer. Second is reduce operational overhead. So Cloud SQL for SQL Server is a fully managed database service with a 99.95% SLA. Being fully managed includes upgrades, patching, maintenance, backups, and tuning regional availability in various virtual machine shapes with memory from 3.75 GB up to 416 GB and storage up to 30 TB for all workloads. Provide flexible scaling options to eliminate the need to pre-provision or plan capacity before you get started. Now, the last one is a live migration for underlying virtual machines. When you run SQL Server on Compute Engine, the virtual machines can live migrate between host systems without rebooting, which keeps your applications running even when host systems require maintenance. Now let's understand the methods of deploying databases on Google Cloud Platform. So GCP predominantly offers three types of reference architecture model for Google data distribution. In that, the first one is single cloud deployment. The simplest of all deployment models, one can deploy databases by creating new cloud databases on Google and or by lift and shift or pre-existing workloads. So the second is hybrid cloud deployment. These types of deployments are useful when one has applications in the cloud that needs to access on-premises databases or vice versa. There are three primary factors to be considered when deploying a hybrid model, with some data on cloud platform and some on-premises. So that's why it's been shown like a public cloud and private cloud. And so in primary factors, first one is a master database. First and foremost, you need to decide whether your master database is stored on premises or on the cloud. Once you choose the cloud, GCP resources act as a data hub for on-premises resources, whereas if you choose on-premises, your in-house resources synchronize data to the cloud for remote use or backup. Second is managed services. So available for resources in the cloud, these services comprise scalability, redundancy, and automated backups. You, however, have an option of using third-party managed services. Third is portability. So based on the type of data store you choose, the portability of your data is affected too. To ensure reliable and consistent transfer of data, you need to consider a cross-platform store such as MySQL. So the third kind of deployment is multi-cloud deployment. These types of deployments can help you effectively distribute your database and create multi fail safes as it enables you to combine databases deployed on Google Cloud with database services from other cloud providers, thereby giving you an advantage of a wider array of proprietary cloud features. And there are two primary factors to be considered when deploying this model. First is integration. So, ensuring that client systems can seamlessly access databases regardless of the cloud they are deployed on. For instance, use of open source client libraries to make databases smoothly available across clouds. Second is migration. So, since there are multiple cloud providers, one may need to migrate data between clouds with the help of database replication tools or export or import processes. So, Google Storage Transfer Service is one such tool to help you with database migration. Now that you have a theoretical understanding of GCP Database Services, let's now deploy a database service on Google Cloud Platform. So you can just go to search for Google Cloud Platform. Just open this link and go to the console. You can also go to the documents part and you can understand more about the database services quite briefly. But right now, because we are going to demonstrate it practically, let's go to the console. So this is how the Google Cloud Platform console looks like. Also, if you don't have an account on Google Cloud Platform, then create one. Like Google Cloud Platform is a very nice platform to have your account on. You get a free trial in it. Like you can see here, my free trial has like 4711 credits and 23 days left in it. What happens is you get a free trial of 90 days in which you get the 300 US dollars of credit. So you can use that credit like doing the exercise I'm going to explain you in this. Also, like when you create this account, it will just debit 1 rupee and it will also get refunded to you quite soon. So you just have to give your credit and debit card details also for it. Okay, so let's start. You just go to my demo. This place. This demo is just the name of my project. You have to create your own project. You can just go to new project and create your project. Give it a name, and that's it. I have this demo and several other projects, so I will go with demo only. So that's the name of my project. So these are the project name, project ID, project number is given. So what I'm going to explain here today is like this database services, Cloud SQL. So Google Cloud SQL service. So where I will be creating an SQL instance and also like the database also I will be creating in it and also a user account. Okay. So you can just go here and go to databases. From here you can go to SQL or you can search from here. Just you can search here SQL. So yeah, we are here. Let's go to SQL. Okay, this is like one of the instance which I have already created. So that's why it's showing like this. But when you open it for the first time, it asks for what kind of instance you want to create, like MySQL or the PostgreSQL or any other. So because I have already created one, so it's not asking me. I will just go and create the instance from here. Yeah, this page you will get. Okay, that's what I was saying from SQL Server, PostgreSQL or MySQL. Okay, so I will be creating MySQL. So you can give a name. One more thing, it should be unique. It should cannot repeat the name of an instance again and again. Okay, so give it a unique name. So I will just give database service demo. Also there should be one number. So yeah, database service demo 1. Okay. Also give the password if you want to. Because right now we are just it's demo, so I will choose no password. Also choose the version from here for it. Right now I'm going with MySQL 5.7 only. Also select your region. Like I have this region nearest to you. Like I have region nearest to me is Asia South 1. Also select your zone. So we like Asia South 1. Okay. Also you can like do further customizations. So let's see the machine type. So select whichever is suitable for you. Like right now I don't require quite a high one. Like so I will go for a standard one. But like here we have like in high memory we have 4 virtual CPUs and 26 GB memory or 52 GB memory with 8 virtual CPUs and then 16 virtual CPUs and 04 GB memory. Then you can customize it by yourself also. So you can just give by yourself whatever you wanna select. Okay. But right now I will go with the standard one. So that's more than enough because the more higher the features you will choose, the more it will cost. Okay. So remember that. So I will just remember standard virtual CPUs 3.75 GB and then you can choose SSD or HDD whatever you want to choose. So I will just choose 10 GB. It's more than enough for me right now. It was just for demo purpose. So yeah, then we can also go for connections, public, private, whatever IP is there. You can choose for that. Select that. Okay, and you can then just go to backups. Like at what time you want to get your backup. So you choose the time. Yeah, you can select the region also. That's just okay. Multi region is okay. Then for maintenance purpose, you can like on which day it gets serviced. Okay, for maintenance. So that's it. And also you can select your flag labels or whatever you want to choose. Okay. So everything is done now. So let's create the instance. Okay, use lowercase letters. Okay, remember that to use the lowercase letters. Okay, also like use lowercase letters, numbers, and hyphens. Start with a letter. Okay, strings are given. Keep that in mind. So let's create the instance now. So as you can see here, that is instance has been created. So here it is, and here you can see the overview of it, like the things are being given. You can see here like the public ID is given, and this is just the CPU utilization it's given. And now right now it's not utilizing, so it's not showing anything. So the configurations are given and everything. One more like suggesting a service account and everything is given. But one cool thing let you know about this instances, you can connect it through Cloud Shell. So just click here. So it's getting connected with Cloud Shell. So gcloud SQL Connect database. So it will show here. Just enter, authorize it. It will take some time. A few minutes it will take. Yeah, not more than that. So you can see like it's asking for password, but I haven't created password, so I will just enter. But if you created the password, just enter the password and go for the next step. So now you can see the databases. So just type for it show databases. These are the databases, and if you want to create a database in it, you can just type create database demo, or you can just give test database service. Okay, so yeah, okay, just don't give hyphen or anything like that. Okay, just say create database test. Okay, yeah, so it's got features. You can just show databases, and you can see here test is being created. Okay, so now you can just exit from here. So exit. So you have to exit again. Now it will be exited from Cloud Shell. Okay, so now you can come to databases. So under database SE demo 1, that's the instance name of our SQL database. So yeah, you can see like, I mean, this is the name of our SQL instance, database SE demo 1. So here you can see like test is also being created. Okay, and also like you can come to users also. Here also default one is there, root. So you can create a database from here also. Like just have to click here, create database, give it a name, test 1. Okay, yeah, just create it from here. Similarly, test 1 is created. Okay, similarly you can go to users, you can create a user account with the name group 66. That's it, and give a password also. It's optional, but I will just, we can just give one. So 662, just create. So the user account will be created. Yeah, okay, that's how users and databases are being created. I hope you have understood it now, how to create it through Cloud Share and everything. That's how the instance are being created through Cloud SQL. Why do we need big table? In the age of Internet of Things, data is only going to get bigger and more complex. Handling such a large amount of information requires an equally complex and powerful database, and Bigtable seems to rise to that occasion. Even with the presence of other competitors in this space, here are some of the major reasons why you should consider Google's Bigtable for database needs at your organization. So first is lower costs. Google has introduced an interesting pricing strategy for Bigtable by separating the storage and computing needs of organizations. This makes Cloud Bigtable a very useful proposition for companies who might need to store large amounts of data over an extended period of time, especially if they only require minimal access and manipulation of that information. This makes it more cost effective compared to competitors who usually charge for each read or write operation on the data. Google has even claimed that charges on Bigtable would translate to half the cost as compared to competitors, but this might depend on the required configuration among other factors. Second is it's open source. So Bigtable is available as open source, which is a major advantage as it enriches the kind of comments and contributions it receives over time. Users are then assured a good degree of improvement and addition with an active developer base in the open source context. This also means that Bigtable would adhere to the required industry standards. For example, the HBase API, which is one of the most popularly used bases, is seamlessly supported, and organizations that already use products like HBase would find it doubly simple to set up Bigtable for their data. Third is high performance. Google is no stranger to high performance requirements, and as Bigtable has already been used internally, there is not much doubt that it can provide the needful to external businesses customers as well. Much of the setup and initial storage calculation is done in an instinctive manner, requiring minimal user inputs, which results in saving much time and effort for new customers. Many initial users, including SunGuard and Qubit, have been more than satisfied with Bigtable's ability to handle large volumes of data that is supported by the ease of setting up and scaling as required. The analytics support provided by Google could also be invaluable for the needs of many data-heavy industries. Fourth is it's highly secure. With large amounts of data, concerns for data security also escalate just as much. So Bigtable offers a replicated storage strategy with algorithms for encryption of data, something that is sure to help allay these concerns. Customers can also bank on Google's expertise in the area with their long-standing experience of handling the privacy and security of large amounts of data. Fifth is maturity. Due to simple fact that Bigtable has been used internally for a significant period of time by a data giant like Google, it can promise a high level of stability and maturity to its users. It is not at all comparable to a new and untested product and might probably score favorably on many fronts when compared to long-standing players in the arena as well. Due to its internal use, customers can also be sure of its continued availability and enhancement. Drawing on its strengths as an organization, Google also lists many of its service partners, including Python, CCRI, and SunGuard, as companies who can build platforms to help support a faster transition to Bigtable. Now, what actually is Bigtable? Let's understand that. First of all, Google Bigtable is a key value database. A key value database is a data storage paradigm designed for storing, retrieving, and managing associative arrays and a data structure more commonly known today as dictionary or hash table. So Google provides the key value database service in the form of Bigtable. It is a distributed storage system for structured data. Also, it is compressed high-performance proprietary data storage system which is built on Google File System, Chubby Log Service, SS Table, and few other Google technologies. You can see here how many of the world's leading companies are choosing Google Cloud to help them innovate faster, make smarter decisions, and collaborate from anywhere. Now, moving ahead, let's understand some of the key features of Google Bigtable. So, first of all, it has high throughput at low latency. So, Bigtable is ideal for storing very large amount of data in a key value store and supports high read and write throughput at low latency for fast access to large amounts of data. Throughput scales linearly. You can increase QPS, means queries per second, by adding Bigtable nodes. Bigtable is built with proven infrastructure that powers Google products used by billions such as search and maps. Second is cluster resizing without downtime. Scale seamlessly from thousands to millions of reads and writes per second. Bigtable throughput can be dynamically adjusted by adding or removing cluster nodes without restarting, meaning you can increase the size of a Bigtable cluster for a few hours to handle a large load, then reduce the cluster size again, all without any downtime. Third is flexible and automated replication to optimize any workload. Write data once and automatically replicate where needed with eventual consistency, giving you control for high availability and isolation of read and write workloads. No manual steps needed to ensure consistency, repair data, or synchronize writes and deletes. Benefit from a high availability SLA of 99.999% for instances with multi-cluster routines across 3 or more regions. Now let's understand the architecture of Cloud Bigtable. So we will understand it step by step. So first of all, you can see here like how client requests go through a front-end server, and then nodes are organized into a Cloud Bigtable cluster of a Cloud Bigtable instance. Each node in the cluster handles a subset of the requests to the cluster, and then nodes are added to increase the number of simultaneous requests to handle maximum throughput. The table is shaded into blocks of contiguous rows called tablets. Similar to H-based regions, tablets are stored on Colossus, Google's file system, in SS table format. An SS table is an ordered immutable map from keys to value, and both are byte strings. Tablet is associated with a specific node, like writes are stored in Colossus shared log as acknowledged. Then data is never stored in nodes themselves. Nodes have pointers to a set tablets stored on Colossus. Rebalancing tablets from one node to another is very fast. Recovery from the failure of a node is very fast. When a cloud Bigtable node fails, no data is lost. I hope you have understand the architecture. Let's now have a look at the data model of Google Bigtable. A Bigtable is a sparse, distributed, persistent, multidimensional sorted map. The map is indexed by a row key, column key, and a timestamp. Each value in the map is an uninterpreted array of bytes. I settled on this data model after examining a variety of potential uses of a Bigtable-like system. As one concrete example that drove some of our design decisions, suppose we want to keep a copy of a large collection of web pages and related information that could be used by many different projects. Let us call this particular table the web table. In web table, we would use URLs as row keys, various aspects of web pages as column names, and store the contents of the web pages in the contents column under the timestamps when they are fetched, as illustrated in the figure. So in this figure, you can see a slice of an example table that stores web pages. The row name is a reversed URL. The contents column family contains the page contents, and the anchor column family contains the text of any anchors that reference the page. Okay. CNN's home page is referenced by both the Sports Illustrated and the My Look home pages. So the row contains columns named anchor cnnsi.com and anchor mylook.cm. Each anchor cell has one version. The contents column has three versions at timestamps T3, T5, and T6. Now let's understand the keys in the data model. So first is row key. So the row keys in a table are arbitrary strings, currently up to 64 KB in size. Through 10 to 100 bytes is a typical size for most of the users. Every read or write of data under a single row key is atomic, regardless of the number of different columns being read or written in the row. A design decision that makes it easier for clients to reason about the system's behavior in the presence of concurrent updates to the same row. Bigtable maintains data in lexicographic order by row key. The row range for a table is dynamically partitioned. Each row range is called a tablet, which is the unit of distribution and load balancing. As a result, reads of short row ranges are efficient and typically require communication with only a smaller number of machines. Clients can exploit this property by selecting their row keys so that they get good locality for their data accesses. Then the second key is for the column family. So column keys, I mean. So column keys are grouped into set called column families, which form the basic unit of access control. All data stored in a column family is usually of the same type. We compress data in the same column family together. So a column family must be created before data can be stored under any column key in the family. After a family has been created, any column key within the family can be used. It is our intent that the number of distinct column families in a table be small, in the hundreds of at most, okay? And that families rarely change during operation. In contrast, a table may have an unbounded number of columns. A column key is named under the syntax family is to qualifier. So column family names must be printable, but qualifiers may be arbitrary strings. An example for column family for the web table is language, which stores the language in which a web page was written. We use only one column key in the language family, and it stores each web page's language ID. Another useful column family for this table is anchor. Each column key in this family represents a single anchor as shown in figure. The qualifier is the name of the referring site. The cell contents is the link text. Access control and both disk and memory accounting are performed at the column family level. In our web table example, we can see their controls allow us to manage several different types of applications. Some that add new base data, some that read the base data and create derived column families, and some that are only allowed to view existing data, and possibly not even to view all of the existing families for privacy reasons. Now the third key is timestamps. Each cell in a Bigtable can contain multiple versions of the same data. These versions are indexed by timestamp. Bigtable timestamps are 64-bit integers. They can be assigned by Bigtable, in which case they represent real time in microseconds, or be explicitly assigned by client applications. Applications that need to avoid collisions must generate unique timestamps themselves. Different versions of cell are stored in decreasing timestamp order so that the most recent versions can be read first. To make the management of version data less onerous, we support two per column family settings that tell Bigtable to garbage collect cell versions automatically. The client can specify either that only the last n versions of a cell be kept, or that only new enough versions be kept. Example, only keep values that were written in the last 7 days. In our web table example, we set the timestamps of the crawled pages stored in the contents column to the times at which these pages versions were actually crawled. The garbage collection mechanism described above lets us keep only the most recent 3 versions of every page. Now let's understand the use cases for Cloud Bigtable. You can use Google Cloud Bigtable to store and query all of the following types of data. The first is marketing data such as purchase histories and customer preferences. Second is financial data such as transaction histories, stock prices, and currency exchange rates. Then Internet of Things data such as usage reports from energy meters and home appliances. Also the time series data such as CPU and memory usage over time for multiple servers. And last, like graph data such as information about how users are connected to one another.
Now, what is Google BigQuery? So basically, BigQuery, now we are talking about, this guy. So basically, your BigQuery is a fully managed serverless data warehouse service that enables scalable analysis over petabytes of data. So this is a PaaS, which is platform as a service that supports querying you using ANSI SQL. So you can, store the data in a large storage, and whatever you're going to consume, you're going to pay for it. Now, what are the different features of it? Now, coming to different features, it has various features. Like first is serverless. What serverless means? It means that in order to run this, there is no dedicated server required. Now, you know that if I have to basically run the resources, what I will need? I will need a resource, a virtual machine, basically that I will require to run those resources, right? So it's a serverless. You don't require the server. Without having the server, you basically can, deploy your resources, you can access it, you can integrate with the application. Plus, since you are not going to use a server, so having that overhead to manage the server, performing the patching, installing the updates, even paying for that dedicated environment, you can just save the money on that. Second is scale. So it basically, you can perform the scaling as well. You can basically perform automatic scaling. At the same time, it's basically supports petabyte of data. So if you want to basically scale with, let's say, more CPU, more RAM, that you can do it very easily with this. In addition to that, in addition to scaling, let's say you want to increase number of core processors as well, you can do. If you want, you can write a script, you can write the criteria. For example, if your CPU utilization is going to go high at a certain with a certain amount. So in that case, in such kind of scenario, what you can do is it's going to automatically increase the resources. When the CPU utilization is going to go low, it's going to automatically decrease the resources. Next is real-time analytics. So wherein you can basically inject the data from various sources in this, and as you can see here towards the right, you can see the progress. Like I want to see my company is going in profit, my company is going in loss. That each and every information at the sake of fees, it's going to be available, and you can get that information very, very easily. Now, next one is your flexible pricing model. So it basically provides you various type of pricing model that we are going to dive in more detail today. So it supports flexible pricing model where you can easily get or I would say you can easily pick up the package depending on your need, depending on your requirement. In addition to that, you have to also, you can basically decide that I want to go with a monthly package, yearly package, I want to go with the services, the way the services I'm going to do. So that's something you'll be able to have that entire, flexibility with this. Plus, you have automatic high availability. So whenever you're going to create the resources, in this case, in the case of Google BigQuery, those resources basically are going to be, replicated at the different sites. Depending on the site model that you're going to use, those resources are going to be replicated automatically. At the same time, it also supports data encryption and security. So you know that nowadays encryption is one of the biggest requirement based on the ongoing hacks. So many companies got hit by the ransomware as well. So in the case of data encryption, what happens is your data is going to be encrypted automatically with a key, and that key you can store in a key vault, in a HSM, depending on the requirement that you have. So that also provides. And now, if I talk about the security, it basically supports, RBAC as well, which is role-based access, wherein you can basically define that, like to which user, what kind of role you want to assign. So all those things basically are available here as well at the sake of this. Plus, there's no, specific complex implementation. each and everything is designed in such a way that you can get easy interface with easy integrations as well. You can make a API call using different programming languages like Java, Python. Different APIs are also available. You just have to change the some variables over there, and you will be able to use it directly. Next one is standard SQL. So it also automatically have inbuilt standard SQL. At the same time, you can also define your own database by creating a new resource. In that, you can also create your own database as well. Next is foundation of AI, which is artificial intelligence. You can integrate with artificial intelligence as well, and you can also integrate with BI as well, which is business intelligence. Clear? Now, moving on, let's talk about the BigQuery storage. So in the case of BigQuery source model, it basically have 5 major components: the projects, the dataset, your tables, your views, and the jobs. Now, here in this case, let me just use this highlighter. This is a project, basically one project, its boundary. In that project, basically you have a data set. In that data set, you can basically have a couple of tables. So now in those tables, you basically can have different views, and you can basically have different jobs for it. Now this is a different project. Now likewise, you can have different projects here, which can be integrated directly with your BQS, which is BigQuery service, wherein you can easily query the data. For example, this project needs some data with this project, or this project needs data with this project, or some different project needs the data with this project. So this entire management, that role-based access control, can be easily be done with your BigQuery service. So that's again a little bit overview at a higher level. Now coming to the storage management that we have, let's take a look how storage management looks like of BigQuery, and how it is different from others. So this is towards the left that you can see, this is traditional RDBMS storage, where you are going to have record oriented storage. Like this is the one record, second record, third record. Likewise, on the right side you see this is BigQuery storage. So where it uses the column level storage. Now even if I want to perform encryption, I can perform encryption in one column. Maybe I have a data, let's say, in one column I have name, second column I have their, last name, third column I have their credit card number. Now this blue one is sensitive for me. But if I go with the traditional RDBMS storage, I have to basically encrypt the entire row. It's going to be difficult for me. And at the same time, encryption, decryption will take time. The operations execution will take time, which is going to be difficult. Now, towards the right, if we talk about, BigQuery storage, we are going to have the column level storage, where we are going to encrypt one column at the time. Clear? Now, coming to the other one, which is storage management. Now, here in this case, as you can see, like we have this table 1, table 2, table 3. In one region, we can have different zone. Different zones, basically like your different data center. Maybe in India, I have this data center in Bangalore, second is Hyderabad, third is Delhi. So if one zone is down, my data is still going to be there at the second, at the third. Now here in this case, if you see, this second one is available here as well, it's available here as well, it's available here as well. So the same data from table 2 is pointing out to this, the same data is copied at the second zone, same data is also copied at the third zone. So even and similar in this table 1, this is copied in the first, this is copied here in the second, this is copied here in the third, which is this one, and this one. Now in the third table, the same data you can see is copied here as well. It's copied here as well. It's copied here as well. Now if this one zone is going to go down, this is going to remain up. This is going to remain up. Let's say this one also got down. There was a network issue. So in that case, the third zone will remain up. Now you can have multi-regions as well, wherein the data from one region is going to be copied to the other region as well. So that's why it basically provides you a very good resiliency, and the data is going to be replicated automatically with the other data at the sake of ease. Now coming to LTS, which is long-term storage. So if you have a table or partition which is not modified for 90 consecutive days, it is considered as long-term storage. And for pricing for the storage for that table automatically gets dropped by 50% to the same cost as cloud storage nearline. So basically discount is going to be applied on per table, per partition basis. That's the biggest beauty of it. So if you are not using it, there is no need, there is no requirement that you have to change the storage type. It's automatically going to drop the price by 50% at the same cost. That's the biggest beauty of the Google Cloud, if I would say, so that you're not spending a lot of money on that. Moving on, what are different types of data ingestion that we have? So we basically have batch ingestion, we basically have streamline, we basically have data transfer. Now let's talk about each of them one by one. What is a batch ingestion? So batch ingestion basically involves loading pages, basically having data set that does not have to be processed in the real time. So they are typically ingested at a specific regular frequencies, and all the data which is going to arrive, it's going to arrive at one time, or it's not going to arrive at all. So the ingested data is then queried for creating reports or combining with different sources where it can have data from maybe different cloud providers. It can have data from your on-premise platform. It is going to be appeared together, and at the same time it's going to be processed together. In the case of streaming ingestion, it's a bit different. In the case of streaming ingestion, or you can see in this diagram, you are going to have your real-time events. Maybe I have a service running, so it's going to generate real-time events. You are going to have basically the app engine, which is going to be integrated with your applications. Can be on-premise, can be on a Google Cloud, can be on any other third-party cloud as well. And these events are going to be fed together into your messaging service. So any cloud model you talk about, for example, your Azure, you have your Google or other, they provide the messaging services. So different type of messaging services they provide, with the help of which you can have the request response protocol set up, based on which you can also set the acknowledgement, like the way TCP works. You send a request, wait for a response. If there is no response, you send another same request again, because it will consider that your request has been dropped. So with the help of stream pipeline, the request that you have received is going to be going to the like a queue where you can have multiple pipelines all together, because it supports parallel communication. And next one, you have a batch pipeline wherein you can basically create the batch of series, batch of requests, which is going to be accumulated in a queue together, and at the end it's going to process together. Then after that, you are going to have, again, this is a batch processing data which is coming from, you can have a batch load where the requests are accumulated and at a specific storage. The certain use cases, like your services are running maybe 2 p.m. every day, 3 p.m. every day. So it's going to ingest all the services from different sources to your environment at the same time, which is going to be processed by the cloud data flow, and it's going to be processed together. Again, this is a very big topic, guys. All three types, we basically have a detail. Even this in streaming and ingestion, we basically spend almost an hour on this. However, based on the time constraint that we have, that's why we are just talking about a bit overview of it. Otherwise, in general, this is a very big topic that we cover in detail. Now, the third service that we have is DTS, which is known as Data Transfer Service. So your BigQuery data transfer service is basically a fully managed service to ingest data from your Google SaaS application. SaaS is software as a service applications, like your Google Ad, your external cloud storage provider like Amazon, and different providers we have. And you can transfer the data from data warehouse technologies like your Teradata, your Amazon Redshift. So all this thing basically falls into this category, which is data transfer service. Clear? Any doubt in this? Now, coming on to the structured learning at Edureka. So if you want to dive in more detail, you want to enroll for the course, and you want to know what all the topics are. Like I said, we believe in the transparency. So all this kind of topics, every information is available on our website. So let me just share the curve path, the learning path, how it's going to be there. So if you're going to enroll for the course, this is going to be the learning path. In the first class, you learn about Google Cloud Platform, how you can create your account, how you can set up the labs, its components, subcomponents, with the hands-on on different topics. Then after that, in the second class, you will learn about how you can basically manage your Google Cloud Platform, its services, its component and subcomponents with the perspective hands-on. Then in the third class, you will learn about Google Cloud Platform, virtual networks, what are different type of networks that you can create with the perspective hands-on. Then in the fourth class, you will learn about security and identity fundamentals. How basically you can create different type of access. You can how basically you can control the entire access with you. How basically you can give different permissions. How what are the different roles that you can create. At the same time, you can also define your own structure, like how many roles you want, how many users you want. Because I don't want more than 15 users to access a resource. So all this kind of things can be restricted here, that we are going to learn with practicals hands-on. Then after that, you will learn about compute services, different type of storage that you have, different type of services that you can leverage and create in the case of cloud with the practical demonstration and the hands-on. In the sixth class, you will learn about data storage services. What are different databases that it supports, the different ways of storing it, what are the proprietary of Google. Google has provided various type of different storage services which it's their own proprietary. What are they? What is the difference between them? How you can select which storage service is best depending on the use case with the practical hands-on. Then in the next class, you will learn about architecting with Google Kubernetes Engine, what is Docker, what is how you can integrate Kubernetes, how basically Kubernetes look like in GCP, how it is different from normal Kubernetes, how you can integrate with Docker. Each and everything you are going to learn in detail with the practical hands-on. After that, we are going to learn about, in the eighth class, you will learn about application development. If you want to write the code, you want to develop the application, you know how you can do it, its components, subcomponents with the practical hands-on. Then you will learn about big data and AI services with the practical hands-on. And then in the last class, you will learn how you can perform automation on the components with the practical hands-on. So this is the entire career path, I would say the training path for your certification if you're planning to take. Now, coming to the pricing, if we talk about, we basically have two pricing model in the case of Google that it provides. One is analysis pricing, second is storage pricing. Now, if we talk about analysis pricing, this is basically on-demand pricing. Basically, it has flat rates pricing. In this, we have three model. First is you are going to have the annual model. You are going to be basically billed and paid annually. Second is on a monthly basis. Third is basically the flexible slots that you can choose. So this is again one of the example of the pricing model, the way it looks like. For example, queries on demand, you have to pay $5 per TB. So first TB is going to be free, but after that you have to pay $5 with every TB, which is a good deal as compared to other cloud vendor providers. Again, the same thing that I shared a moment ago, a different pricing model that it supports. Now, if we talk about the cost of flexible slot commitment, like I said, we have three types: the flexible, monthly, and the annual. So if we basically take a look at flexible slot, you're going to get this much slots, and based on average of this is 730 hours per month. Depending on your requirement, you can decide if you're using heavily. Do you want to go with the flexible, or your monthly is going to be best, or annual is going to be best? Likewise, if we talk about monthly, in the case of monthly, number of slots that you get is 100. You have to pay $2,000 for that. In the case of annually, the amount is less. So wherein you are going to pay less, which is $1,700. Now, if you look at the cost, in the case of flexi, it's a bit more. Now you basically look at the cost of your monthly, it's high. Annually is less. So you can save the money on that. Now, in the terms of storage pricing, if you talk about, it has two types of storage pricing. One is active storage, second is LTS, which is long-term storage. So you have seen that in the case of long-term storage, what will happen that we even talked about a moment ago, which has a benefit that if your table or partition is not modified for 90 consecutive days, that is going to be considered as a long-term storage, and price of that storage is going to be automatically dropped by 50%. That's why in this case, you see for active storage, it's the cost is $0.02, 0.02, and for long term is 0.01, which is half, because the price get dropped by 50%. And in both the cases, the first 10 GB are free.
What is Google Cloud's Virtual Private Cloud? Google Cloud Virtual Private Cloud provides network functionalities to Compute Engine virtual machine instances such as Google Kubernetes Engine containers, App Engine Flexible Environment, and other Google Cloud products which are built on Compute Engine virtual machines. Basically, VPC provides networking for your cluster-based services that is global, scalable, and flexible. Now, Google VPC is quite different from the VPC of other cloud service providers. Now, in the traditional VPC or the VPC provided by other cloud service providers like AWS, the architecture would look something like this. Now, here in the first diagram, we can see that there is two VPC built with two different subnets in two different regions, which are US East and US West. Now, the virtual machine in one region can access the internet and communicate with the other virtual machine only through the VPC gateway, which acts as an interface. In the traditional VPC, one virtual machine cannot directly communicate with the other virtual machine. Now, in the Google version of the Virtual Private Cloud, it is a global construct. which means instead of creating a VPC in US West and the other one in US East region, you just create one VPC and put the subnet in different region within that VPC. Now in this case, the virtual machine present in one region can directly communicate with the virtual machine in the other region without the help of the VPN gateway. Now the communication between the virtual machines is handled by Google underlying network. This is the same network that Google uses for its search engine, YouTube, Gmail, and its other applications. Now the Google version of VPC can be very helpful. Let's say for a large project, you use the traditional approach. Then you have to build multiple VPC and multiple gateways, which will be very hard to maintain and to keep a track of. Now with Google VPC, you just have to create one VPC and a gateway and can create multiple virtual machines in multiple subnets. It is much simpler and easy to maintain. Also, if something goes wrong with the traditional network infrastructure, it will take a lot more time and cost to identify and resolve the issue. In Google VPC, there are fewer network constructs to break and troubleshoot. This would help in identifying the problem faster and solving it. Now let us understand VPC networks. You can think of VPC network the same way as a physical network, except that it's virtualized within the Google Cloud. A VPC network is a global resource that consists of a list of regional virtual subnetworks in data centers, which are called as subnets. And all these are connected by a global wide area network. Also, VPC networks are logically isolated from each other in the Google Cloud. Now, some of the functionalities offered by Google Cloud VPC networks are: it provides connectivity for your compute engine virtual machine instances, including Google Kubernetes Engine clusters, App Engine instances, and other Google Cloud products built on compute engine virtual machines. It offers built-in internal TCP UDP load balancing and proxy system for internal HTTPS load balancing. It can also help in connecting to on-premises network using Cloud VPN tunnels and Cloud Interconnect attachments. It distributes traffic from Google Cloud External Load Balancer to the backend. Now to understand VPC network better, let us take a look at its architecture. Now here you can see we have two regions, US West 1 and US East 1 in a VPC network. Now a region is nothing but a specific geographical location where you can host your resources. And a region can have three or more zones. For example, US 1 region has three zones: US East 1A, US East 1B, and US East 1-3. Now talking about zones, zones are independent of each other. They have completely separate physical infrastructure, networking, and isolated control planes. This is to ensure that typical failures event only affect that zone. Now coming to subnets. A subnet or a subnetwork is a segmented piece of a larger network. The virtual machine instances can be created in the subnet, and the instances can communicate with each other in the same VPC network using the private IP addresses. Here you can see there are two virtual machines in US East subnet and there are two virtual machines in US West subnet. Now these virtual machines can access the internet through the VPC routing. VPC routing decides how to send traffic from the virtual machine instances to the destination. The destination could be either the other virtual machine instances or the internet. Moving on, let us understand a few important concepts in VPC like IP addresses, routes, and firewall rules. You will find all these concepts in Google Cloud VPC's console. So first, let us talk about IP addresses. Now each virtual machine instances in GCP will have an internal IP address and typically an external IP address. The internal IP address is used to communicate between instances in the same VPC network, while the external IP address is used to communicate with instances in other networks or the internet. These IP addresses are ephemeral by default but can be statically assigned. Now ephemeral means the IP address will keep changing every time the virtual machine restarts. Now talking about the VPC routes. Route tells virtual machine instances and the VPC network how to send traffic from an instance to the destination. The destination can be either inside the network or outside of Google Cloud, which is the internet. You can also create custom static routes to direct some packets to specific destination. Now each VPC network comes with some system generated routes. There are two different system generated routes. First is the default route. This route defines a path for the traffic to leave the VPC network. It provides general internet access to virtual machines that meets the requirement. It also provides the typical path for private Google access. Next, for communication within the network, there is subnet routes. It defines the path for sending traffic among instances within the network by using internal IP addresses. But for one instance to communicate with another, you must configure appropriate firewall rules because every network has an implied deny firewall rules for ingress traffic. Now talking about firewall rules, each VPC network implements a distributed virtual firewall that you can configure. Firewall rules allow you to control which packets can travel to which destination. It lets you allow or deny connection to or from your virtual machine instances based on configuration that you specify. Now, when you're creating a VPC firewall rule, you must specify the VPC network and a set of configuration that defines what the rule does. The configuration enables you to target certain types of traffic based on the traffic protocol, destination port, sources, and destination. You can create and modify VPC firewall rules by using a Google Cloud Console, G-Cloud command line tool, and REST APIs. Now, these were some of the important topics in Google Cloud VPC. Now, let us move on to the next topic and see some of the benefits of Google Cloud VPC. First is, it is global. Using a VPC gives you managed global networking functionality for all your Google Cloud resources through subnetworks known as subnets, which are hosted on Google Cloud data centers. A single Google Cloud VPC and its subnets can span across multiple regions without ever connecting to the public internet. It remains isolated from the outside world and is not associated with any specific region or zone. Second benefit is, it is shareable. Now, an entire organization can use one VPC and share it across the various teams. Different teams can be isolated within projects with different billing and quotas. Yet, they can still maintain a shared private IP space and access to commonly used services. The next advantage is, it is expandable. Google Cloud VPC lets you increase the IP space of any subnet without any workload shutdown or downtime. This gives you flexibility and growth option to meet your needs. Now, I guess you have some idea about VPC. Now let us move on to the next topic and see what is Google Cloud Load Balancer. Basically, a load balancer distributes user traffic across multiple instances of your application. By spreading the load, load balancing reduces the risk that your application experience performance issues. Google Cloud offers 6 types of load balancer, which are external HTTPS load balancing, SSL and TCP proxy load balancing, external TCP UDP network load balancing, internal HTTPS load balancing, and internal TCP UDP network load balancing. Now, to decide which load balancer best suits your implementation, consider factors such as global and regional load balancing. You can use global load balancing when your backends are distributed across multiple regions. Your user needs access to the same application and content, and you want to provide access by using a single IP address. You can use regional load balancing when your backends are only in one region. The next factor is external and internal load balancing. Now, external load balancer distributes traffic coming from the internet to your Google Cloud VPC network. An internal load balancer distributes traffic to instances within the GCP network. And the last factor you need to keep in mind is the type of traffic that you need a load balancer to handle, such as HTTPS, TCP, or UDP traffic. Now, this was a brief information about Google Cloud Load Balancing. Let us move on to the next topic and understand what is Cloud DNS service. Google Cloud provides a scalable, reliable, and managed domain name service or DNS running on the same infrastructure as that of Google. But before we get into Cloud DNS, let us understand what DNS is. So DNS is a hierarchically distributed database that lets you store IP addresses and other data and look them up by names. In other words, DNS is a directory of easily readable domain name that translate to numerical IP addresses which are used by computers to communicate with each other. For example, when you type URL into a browser, DNS converts the URL into an IP address of a web server associated with that name. Like www.example.com is translated to IP address of 72.220.193.173. Then the DNS directories are stored and distributed around the world on domain name servers that are updated regularly. Now, Cloud DNS is a high-performance, resilient global DNS service that publishes your domain name to the global DNS in a cost-effective way. Cloud DNS lets you publish your zones and records in DNS without the burden of managing your own DNS servers and software. Cloud DNS offers both public zones and private managed DNS zones. Now, a public zone is visible to the public internet, while a private zone is visible only from one or more virtual private cloud networks that you specify. This was about Cloud DNS. Now let us move on to a demo part where I will show you how to create a VPC network in Google Cloud. So for our demo, I've logged in into a GCP account. For people who are new to GCP, this is what the GCP console would look like. Now it is very simple to create a GCP account. All you have to do is enter your debit card or your credit card details and your address. Then you might be charged maybe ₹1, but even that would be refunded later. And after you sign into a new account, GCP will provide you $300 free credits. You can use this amount to explore Google Cloud services. You won't be charged until you choose to upgrade, and it will be valid for 90 days. Now coming back to a GCP console, you can see we have the project info over here. Now you must have a project in order to use the GCP resources. And here will be the list of resources that your projects use. Here will be the billing, the monitoring dashboards. If you're new to GCP, you can explore the various services provided by Google Cloud. So demo is going to be very basic, where I will explain how to create a VPC and subnets. So the first step is to select a project. Now if you're using GCP for the first time, you can just create a new project from here. Click on new project, name your project anything you like, and just create it. Now for this demo, I'll just select from an existing project. So I'll let this be, and now let us search for VPC over here. And we'll select the VPC network. Now you can see here that Google Cloud comes with a default VPC. And this VPC has 25 subnets, each subnet having its own IP address and in a different region. As I mentioned before, GCP has 25 regions and 76 zones. So each subnet is created in 25 different zones. Next, you see something called mode over here. And you can see there are two types of mode, custom and auto. We will talk about this when we're creating a VPC. And there are 4 default firewall rules. So let us now create a new VPC. So I'll just go to create VPC network. And we can name our VPC anything we want. So I'll just name it demo VPC. And you can see only lowercase letters, numbers, and hyphens are allowed. Next, you can describe your VPC, but this is optional, so I'll just skip it. Now coming to subnets, we can create a subnet with 2 different methods. One is custom and the other one is automatic. If you select automatics, subnets are automatically created with different IPs in different regions. Now you can see in automatic, 15 subnets are created in 15 different regions. If you want, you can select any firewall rules from here. Now, as I mentioned before, firewall rules allow you to control what packets can travel to which destination. Now, with the demo VPC allow ICMP, it will allow only ICMP traffic from any source to any instances in a network. And with the allow internal firewall rules, it will allow connection for all protocols and ports among instances in the network. Next, the allow RDP firewall rules allows RDP connection from any source to any instances on the network using port 3389. The port is given over here. Next is the allow SSH traffic rule. This allows TCP connection from any source to any instances in the network with the destination port 22. Next, these two are the default firewall rules. And the default routing mode is set to regional. You see, Google Cloud makes it very simple for you to create a VPC. All you have to do is just name your VPC, select automatic and click on create button. And then your VPC will be created. But for this demo, we're going to select the custom subnet and create only a few subnets. So we'll just go to custom. Now we can name a subnet anything we want. We'll just name it demo VPC subnet. If you want, you can add description about your subnet. Next, we have to select a region. So these are the available regions. So we'll just select US East 1 and we have to mention the IP address range. So we'll just mention 10.0.1.0.24. Next, we have something called private Google access. This means I can set my virtual machines in the subnet to access Google services without assigning an external IP address. So I'll just on this. So now my virtual machines will be able to access Google services without an external IP address. I will let the flow logs be off. Flow logs are just to record the network flow. If you want, you can on it as well. I'm just going to click on done. Next, we can select regional or global routing mode. Regional routing will route only in the region they were created, and global routing will route to and from all the regions. So let it be default regional. Now let us create another subnet. We'll just name it demo VPC subnet 2. And the region will select US West 1. We'll give the IP range as 10.0.2.0/24. We'll let the private Google access be on and click on done. Now I'll just create my VPC. Now VPC is being created. This might take a couple of minutes. Now you can see our VPC is successfully created. And 2 subnets are created in US West 1 and the other one in US East 1. What exactly is GCP Security Command Center? Security Command Center is a security and risk management platform provided by Google Cloud. It is an intelligent risk dashboard and analytics system for surfacing, understanding, and remediating Google Cloud security and data risks across an organization. In simple words, it is an established security and risk database for Google Cloud. Now, the Security Command Center helps security teams gather data, identify threats, and act on them before they result in business damages or loss. It offers deep insight into application and data risks so you can quickly reduce the threats to your cloud resources across your organization and evaluate the overall health. Security Command Center provides a single centralized dashboard so you can view and monitor an inventory of your cloud assets. Now, assets are nothing but your resources like organizations, your projects, your instances, and your applications. It can also help in scanning storage system for the sensitive data. It can be used to detect common web vulnerability and anomalous behavior. With Security Command Center, you can also review the access rights to the critical or important resources in your organization. And along with that, you can follow the recommended actions to resolve the vulnerability present. Now, I guess you have some idea about what exactly is the Security Command Center. So now let us see how does the Security Command Center work in order to understand it better. Security Command Center enables you to generate curated insight, which provides a unique view of incoming threats and attacks to your Google Cloud resources, which are called as assets. Now, assets are nothing but resources like organization, projects, instances, and application. This Security Command Center asset discovery runs at least once a day. You can also manually rescan on demand from the Security Command Center assets display. Then the Security Command Center displays possible security risks that are associated with each asset. The possible security risk is called as findings. Now, this findings comes from security sources that include Security Command Center's built-in services, third-party partners, and your own security detectors and finding sources. Now, this was the working of Security Command Center. Now, let us take a look at some of its prominent features. The first one is you can gain centralized visibility and control. Security Command Center gives you a centralized visibility of the number of projects you're using, what resources are deployed, and you can also manage which service accounts has been added or removed. The second feature is you can fix misconfiguration and compliance violation. With Security Command Center, you can identify security misconfigurations and a compliance violation in your Google Cloud assets. After you've identified these vulnerabilities, you can resolve them by following the actionable recommendation which is provided by Google Cloud Platform. The third prominent feature is threat detection. You can detect threats using the logs running in the Google Cloud at scale. You can detect some of the most common container attacks, including suspicious binary, suspicious library, and reverse shell. You can also identify threats like cryptography mining, anomalous reboots, and suspicious network traffic with built-in anomaly detection technologies which are developed by Google itself. Next, after threat detection, we have threat prevention. With Security Command Center, you understand the security state of your Google Cloud assets. You can uncover common web application vulnerabilities such as cross-site scripting or outdated libraries in a web application that are running on either Google App Engine or Google Kubernetes Engine or Google Compute Engines. Then you can quickly resolve this misconfiguration by clicking directly on the impacted resources and following the procedure steps on how to fix it. The last feature is sensitive data identification. With Security Command Center, you can find out which storage bucket contains sensitive and regulated data using Cloud DLP. You can also prevent unintended exposure to these storage buckets and let only the authorized person access it. So these were some of the features of Cloud Security Command Center. Let us move on to the next topic and see what is Cloud Armor. Google Cloud Armor protects your application and website against denial of service and other web attacks. You can use Google Cloud Armor security policies to protect your application running behind a load balancer from distributed denial of service or DDoS and other web-based attacks, and your application could be deployed anywhere, whether on the Google Cloud or in a hybrid deployment or in a multi-cloud architecture. So this was the definition of Cloud Armor. Now let us understand how this Cloud Armor works. Google Cloud Armor's DDoS protection is always on inline, scaling to the capacity of Google's global network. So it is able to instantly detect and reduce network attacks in order to allow only well-formed requests through the load balancing proxies. With Google Cloud Armor security policies, you can also allow or deny access to your external HTTPS load balancer at the Google Cloud Edge. which is as close as possible to the source of incoming traffic. This helps you prevent unwanted traffic from consuming resources or entering your VPC network. Now let us take a look at some of the features of Google Cloud Armor. The first feature is IP-based and geo-based access control. You can filter your incoming traffic based on IPv4 and IPv6 addresses or CIDRs. You can also enforce geographic-based access control to allow or deny traffic based on source geographical location using Google GeoIP mapping. The next feature is adaptive protection. Cloud Armor automatically detects and helps reduces high-volume DDoS attacks with a machine learning system trained locally on your applications. The last feature is pre-configured web application firewall rules. Cloud Armor comes with the out-of-the-box rule set based on industry standards to reduce the common web application vulnerabilities and help provide protection from various web attacks. So this was about Cloud Armor. Let us move on to the next topic and talk about identity and access management. Identity and access management lets the administrator authorize who can take action on a specific resources, which will help you have full control and visibility to manage your Google Cloud resources centrally. IAM provides tools to manage resource permissions with minimum confusion and high automation. You can map job functions within your companies to groups and roles so that the user gets access only to what they need to get the job done, and the admins can easily grant default permission to entire group of users. So this was the definition of identity and access management in GCP. Now let us understand how does it work. With identity and access management, you can manage access control by defining who has what access for which resources. Now resources are nothing but your compute engine virtual machine instances or your Google Kubernetes Engine clusters, your cloud storage buckets, and so on. In IAM, permission to access a resource is not granted directly to the end user. Instead, a permission is grouped into roles, and roles are granted to authenticated members. Now, an IAM policy defines and enforces what roles are granted to which members, and this policy is attached to a resource. So when an authenticated member attempts to access a resource, IAM checks the resource policy to determine whether the action is permitted or not. So only if the action is permitted, then it lets the user access the resources. So I guess you have some idea about how this cloud identity and access management works. Now let us look at some of the features of IAM. The first feature is smart access control. Actually, permission management can be a time-consuming task. So Google IAM provides Recommender, which helps admin remove unwanted access to Google Cloud resources by using machine learning to make smart access control recommendations. With Recommender, security teams can automatically detect overly permissive access and make them right based on the similar users in the organization and their access patterns. The next feature is fine-grained control, which means you can set IAM policy at any level in the resources hierarchy. It can be either in the organization level or the folder level, the project level, or the resources level. IAM enables you to grant access to cloud resources at the fine-grained levels. You can create more granular access control policies to resources based on attributes like device security status, IP addresses, resource types, and date and time. Moving on to the next feature, which is single access control interface. Now what this means is IAM provides a simple and consistent access control interface for all the Google Cloud services. So you can just learn one access control interface and apply that knowledge to all the Google Cloud resources. The last feature is it is free of charge. Now I would say this is more of a benefit. Google Cloud Identity and Access Management is offered at no additional charge for all the Google Cloud customers. So you will be charged only for the use of other Google Cloud services, not IAM. This was about GCP Identity and Access Management. Now let us move on to a final topic and see what are the best GCP security practices. Now before we dive into the best practices, I want you to know that cloud security is a shared responsibility, which means you and your cloud service providers are both responsible for securing your resources and applications. While your cloud service provider, which is in this case Google Cloud, is responsible for platform security, which would include managing the physical machines and data centers your application and data uses. On the other hand, the users, that is you, are responsible for application security, which includes setting up proper authentication, authorization, and identification for users in their system. Next, the infrastructure security can be managed by users with the help of various tools which are provided by Google Cloud. So this is managed by you with the help of Google Cloud Platform. Now talking about the best practices, The first best practices apply least privilege access control or identity and access management. The principle of least privilege is a critical foundation element in GCP security. This concept is of only providing employees with the access to application and resources they need to properly do their jobs. Only the selected users should be authorized to take action on a specific resources. The next best practice is manage unrestricted traffic and firewalls. You should limit the IP ranges that you assign to each firewall and only allow the network that need access to those resources. GCP's advanced VPC features allow you to get very granular with traffic by assigning targets by tag and service accounts. The next best practice is ensuring your bucket name are unique across the whole platform. Now it is recommended to append random characters to your bucket name and not include the company's name in it. An example for your bucket name could be product logs, B7, B12, B365, something like that. This will make it harder for an attacker to locate bucket in a targeted attack. The next best practice is setting up a Google Cloud organization structure. When you first log in into a Google Cloud admin console, everything will be grouped into a single organization unit. Any settings you apply to this group will apply to all the users and devices in the organizations. So you should plan out how you want to organize your units and hierarchy before diving into what will help you save time and create a more structured security strategy. Now these were some of GCP security best practices.
What is machine learning? So suppose you have a picture of a dog and a cat, right? So how does a computer understand the difference between which is which, right? How can the computer tell which is a dog, which is a cat? So to do that, you have to do certain processes. The first thing you do is you collect the images and process them using computer vision, which is again a machine learning service that is there. So computer vision will basically understand what kind of image that you are processing, right? Then you convert all the images in the same format, so it's easier for your computer to understand. And finally, you transform them into numbers for algorithms to learn, right? So the main aim for you to teach a computer what a certain thing is so that it can imitate you, right? So machine learning is a branch of AI which focuses on the data and algorithms to imitate the way that humans learn, gradually improving the accuracy, right? So machine learning is always data driven, and the main aim is to imitate human learning techniques as best as possible. And there is the opportunity for continuous improvement for the accuracy, right? So it is always possible to create a perfectly copied model. So this is what machine learning is. Then we talk about why use Google Cloud for machine learning. So the basic reason why people use Google Cloud for machine learning is because it improves efficiency. It is suitable because it has pre-trained models, right? So it directly saves the user a lot of time as well as provides the necessary resources required for the integration of the model with other services. So Google Cloud ML is one of these tools that is used for production and deployment of machine learning models. Then we talk about spam detection. Now, when it comes to spam detection, we talk about the fact that Google Cloud has the ability to detect spamming, right? So it crops out or removes anything which is unnecessary with respect to the trained model. Then we talk about customer segmentation and accurate predictions. So the most faced problem today that we have is the enterprise company in customer segmentation. So different enterprise teams provide relevant data such as website visitors, lead generation, and all of that. And the result is basically a big segmentation of what people want, and that is how you divide customer based on their needs. So that's what customer segmentation is all about. Then we talk about the different services that Google Cloud Machine Learning has. So of the many services that Google Cloud Machine Learning has, we're going to discuss a few of them here. The first one we talk about is your Cloud Auto ML. Now the Cloud Auto ML will basically enable developers with limited ML expertise to train high quality models. Followed by, we talk about the Google Cloud Text to Speech. So text to speech or speech to text is another service which basically enables developers to generate human-like speech. A very good example is your Google Translate. So when you basically give a certain input, let's say type in a certain word, Google Translate will say that word in a certain human-like voice format. So basically, for a certain given text, you will get a certain voice output, or for a certain voice output, you'll get a certain text. That is what Google Text to Speech does. And the aim is to generate as much as human-like voices as possible, right? Next up, we have the Cloud Vision API. Now, the Cloud Vision API allows developers to easily integrate image detection features within applications. For example, let's say the optical character recognition. Now, optical character recognition is something which helps you detect text in images. So if there is, let's say, if there's an image and it says no parking, so Google Cloud Vision will basically help you detect that text and print out no parking over there because of its capabilities for optical character recognition. Then we talk about the natural language processing API. So the Cloud Natural Language API is an interface to several other NLP models which are working on bigger data sets, right? Then we talk about Dialogflow. So Dialogflow is basically a development tool for creating chatbots. So the main aim for creating chatbots in a website is so that you make the user interface much more interactive than it already is. And if the users of that website have concerns, they can directly converse with the chatbot. So it makes the entire user experience much more seamless and better. Then we talk about the Vertex AI, which is one of the most important cloud ML services provided by Google Cloud. So Vertex AI is basically an environment for scientists to experiment, deploy, and manage the models that they create, right? Then we talk about the Cloud Machine Learning Engine. Now, the Cloud Machine Learning Engine is a managed Google infrastructure for training and serving large-scale models, right? So it is used mostly on larger training models, unlike AutoML. And finally, we talk about the TensorFlow Enterprise. Now, TensorFlow Enterprise performs enterprise-grade support, performance, and managed services for your workloads, right? So this is basically the services that Google Cloud provides. We'll talk about some more a bit later. So next up, we talk about Google Cloud machine learning features. So some of the features that Google Cloud Machine Learning offers us are the capability to train models using distributed clusters. Now, what this means is that a distributed training cluster will have the workload to train a model which is split up into different processors, right? So these small processors which take up a part of the workload are called worker nodes, and these worker nodes work in parallel so as to speed up the process of model training, right? Next up, we talk about the fact that Google Cloud ML allows you to build ML models with custom tooling. Now, what this means is that it enables developers with limited machine learning expertise to train high quality models specific to their business needs. And even if you are really not someone who is into AI, it'll help you build high quality trained models with ease, right? And finally, we talk about the enterprise level compute infrastructure that Google Cloud Machine Learning provides. And this is basically something where you can see that the ML services have self-allocated resources and high-end compute infrastructure to make the deployment of the model much more easier, right? Then we talk about the steps involved in applied machine learning. So let's suppose you want to train your own machine learning model. What do? The first thing you do is you gather the data that you need to feed your model, right? And after you gather the data, you basically structure it in such a way so that it's easier for your model to understand. So you prepare it. The next thing, and one of the most important things, is choosing a model for your deployment, right? A model that you can train. So what you have to do here after this is evaluate the different configurations that are available and choose what is best for your model and what you want according to your business needs. After that, you go to parameter tuning, where you can again fine tune your configurations for your model so that you get your best possible prediction, because the aim is to get the highest accuracy, right? And the final part is the prediction part. So the prediction part basically tells us how accurate our machine learning model is or how well we have predicted it. Now, this is basically the higher the prediction, the better the learning capability of your model. So these are the different steps in applied ML. So now we come to the demo, which is managing document AI processes using Python. So Document AI is a service provided by Google Cloud Platform, which is basically a technology that uses NLP and machine learning to train computers to simulate human review of documents. So basically what Document AI does is it extracts information from documents in digital or print form, right? It is able to accurately identify text, characters, and images as well in different languages. So this is basically what Document AI is used for. Now what we will be doing here is we will be creating processes and managing those processes using Python, right? So let's get started. So the first thing you need to do is make sure that you have a project created on Google Cloud Platform, and on that project you have Document AI enabled. Now once you have Document AI enabled, you can just go to the Cloud Shell and do the following. So once you've basically enabled Document AI, you can just first thing you do is make a directory called document processes. So once you've made the directory, you'll have to export your project ID and your Google application credentials with that as well. And once you've done that, make sure that you make a new service account. Here, the service account's name is Document AI Processes Code Lab, right? So once you create the service account, you can see that the service account has been created right here. So next thing you do is you change the IAM policy and you add the editor access. So you need editor access to manage your processes that you create. So once you've done that, it'll update the IAM policy. And as you can see, this is all being updated. So once after you've created your service account and you've made the changes to the IAM policies so that you have editor access, you have to create and download a JSON key, service account key that you have. So this is basically the service account key that I have, and it's being downloaded. And after that, I'm just checking for the entire path of my service account. And this is the entire path of my service account, which shows me the project ID, the private key, and the public key as well, right? After this, what you do is you create a virtual environment on Cloud Shell. And once you've created a Python virtual environment, what you need to do is that you need to activate it using source env bin/activate. So now your virtual environment has been created and activated. So once you've done that, since you're using Document AI, you need to basically install this, which is the Cloud Document AI Tabulate. Now what Document AI Tabulate does is it basically makes your data that you have in the document look much prettier when you have to print it, right? So now that you have your Document AI Tabulate installed, what you have to do is create a Python session with the command ipython. Now you've created a Python session, which is basically an interpreter for Python. And for that, you'll have to put all your functions and all your code in this ipython file, right? After you've basically downloaded the Document AI Tabulate file, you'll see that it's been installed. Now what you have to do is get a Python interpreter. Now you can log into this Python interpreter by the command ipython, right? After which you can just put in your functions inside that ipython file. So you have the code. Now the code basically shows you the kind of processors you have and the processor type, and basically you have to print the processors that you have. So if you do that, you'll see that you'll have something like this. Let's go down here. As you can see, this is basically all the processors that we have, and this being shown using a tabular format using Document AI, right? So we'll try something else out as well. Let's just see the number of processors that we have here has been typed out to be 34. Now this is all because that we want to know the number of processors that are present. So this is basically nothing but listing the Python and processor types that you have. So these are basically the processors that was already present. Now let's just try creating our own process and basically print that as well. So what you see here is a data frame where we're creating a processor and displaying it as well. And this is the same. So what we're doing is we're creating another data frame, which is the tabular data function, which will show us our new processors printed in a tabular state. And if you run this command, this is what you see, that these two processors have already been created and enabled, right? After this, there's another function which is basically showing us there's another processor, and we'll have to get that processor if it exists, right? So let's just go back here. Yeah, so let's just check out if a certain processor is already there existing. For example, in this function, we'll basically go check out if the OCR processor exists, right? And we'll have to go check it out and display the name of the processor and the OCR name as well, right? So the type of processor that we have is the OCR processor. This is the processor that we created, and it's called document OCR, and it's enabled. So this is a different command that you can use for getting the processes that you've created, right? So basically, it also shows you the version of the projects that you've created and the processes that you've created as well, right? So let's try out something else now. So the next thing we're going to try is we're going to try and analyze a document. In this document, it's basically called form.pdf, right? So we'll have to just, right. So if you go here, you'll see that the form.pdf file has been downloaded. And basically, when you ls into it, you'll see the files that are there, which is the form.pdf, the JSON, and the Python environment, right? Now there's a function called process file, which will basically process your document and analyze it. And it'll print the path of the file and the document as well. So basically, after that, what you have to do is print the file. So once you print the file, this is what you see, that it's a health intake form, and this is the data that you have in there, right? So this is not in tabular format because we did not mention it, but if you want to, you can. And after this, you'll have to check out the fields in the document that you have. So to do that, we have another function called print form fields, which will print the tabular data form fields and do that. So this is basically the fields that you will select. And once you select those fields that you want and print the same document, you'll see that the entire part where you wanted it to be tabulated and shown has been shown here like this, right? So there are 17 fields, and this is what you have as your document. So document AI can read and show you tabular data, which is not redundant. So now you're going to update the processor state after this. Now to basically update the processor state, what you need to do is delete the processor, right? So you will have to disable the processor first. So to disable the processor, this is the function for disabling the processor. And this is also a function for enabling as well. So if you want to enable it from disabling, you can check that out. What you need to do is you need to print out all the enabled processors here. And once you've done, you can just delete them, because this is a function which shows you how to delete the processors that you've already created. Before this, we saw how to create the processor. We saw how to get fields from a certain document. We saw how to analyze the document. We also saw how to enable and disable the processors, which is extremely important before you delete it, right? And this final part is showing us how to basically delete the. So once the file is deleted, we are done, and you've cleaned up all the data that you've already used, right? So you don't want to keep instances or processors keeping on running, because so if you exceed the free tier limit, it'll basically cost you money, right? So you don't want to do that. So make sure you always delete your instances and processors, right? So with that, we come to the end of the demo. Finally, we come to the use case, which is Spotify. Now, Spotify is the world's leading music streaming service all across the world. And what you can see here is that Spotify have actually turned their data insights much faster. Now, how has this happened? Spotify uses their Hadoop cluster, and then they change their Hadoop cluster into a BigQuery solution. Now, what this does is it allows you to not only give data insights as well, but also have around 740 active users on BigQuery, right? So that's around 25% of the employees at Spotify, which is a pretty huge percentage. So not only this, but this also gives direct and real-time insights to the artists so that they can access the live real-time streaming statistics for their songs, right? So this is how Spotify has used Google Cloud in their functionality. And this is why I think Spotify is still going to be one of the leading music streaming companies for years to come. And Google Cloud has been integrated into literally every aspect of our life.
So you might have heard a lot about the term AI. There are a lot of devices in the market which are powered by AI that we use on a daily basis. So the term AI sounds very alluring, right? But what actually is AI? So now let's have a little introduction of it. So AI stands for artificial intelligence, which is an intelligence demonstrated by machines, unlike the natural intelligence displayed by humans and animals, which involves consciousness and emotionality. The term is frequently applied to the project of developing systems provided with the intellectual processes, characteristics of humans, such as the ability to reason, discover meaning, generalize, or learn from past experience. Since the development of the digital computer in the 1940s, it has been demonstrated that computers can be programmed to carry out various complex tasks, as for example discovering proofs for mathematical theorems or playing chess with great proficiency. Despite continuous advances in computer processing, speed and memory capacity, there are yet no programs that can match human flexibility over wider domains or a task requiring everyday knowledge. On the other hand, some programs have attained the performance level of human experts and professionals in performing certain specific tasks, so that artificial intelligence in the limited sense is found in applications as diverse as medical diagnosis, computer search engines, and voice or handwriting recognition. Now let's have a look at some of the major domains which have been eased out with the help of AI. So AI in healthcare has simplified the lives of patients, doctors, and hospital administrators by performing tasks that are typically done by humans but in less time and at a fraction of the cost. In the business domain, if you see, in the present time, at least 30% of the companies globally use AI in at least one fragment of their sales processes. Today, businesses across the globe are leveraging artificial intelligence to optimize their process and reap higher revenues and profits. AI in education is used to develop smart school scheduling tools for scheduling individual student timetables. Using machine learning, which is an AI based assessment process, helps in many ways. Like it helps in faster grading, adaptive testing, and performance monitoring of students quickly with more accuracy. Now moving on to AI in autonomous vehicle. So with every car manufacturer and their mother racing to develop artificial intelligence and self-driving technologies, there are also a slew of tech companies and startups with the same purpose. Though many believe personal autonomous vehicles are the future, but there are multiple ways in which AI and machine learning are being implemented in how vehicles are built and how they operate on the road. So if you see, an AI-powered social listening tool can deliver insights from your brand's social media profiles and audience. This often involves using the power of AI to analyze social data at scale, understand what's being said in them, then extracting insights based on that information. So now moving on to the last industry, that is travel industry. So if you see, like most hotels and resorts rely heavily on delivering excellent customer service to build their reputation. And AI technology can assist with this in a variety of ways. For example, artificial intelligence can be used to improve personalization, tailor recommendations, and guarantee fast response times given in the absence of staff. Now let's take a look at some building blocks of AI in Google Cloud. So there are four major building blocks. First one is site, second is language, then conversation and structured data. So under site we have multiple products. That is, first one is Vision API. With Vision API and machine learning model, which helps you in reading images. Suppose if I upload an image under Vision API, by just reading that image, the Google Cloud Platform can help you identify the data points which are related to the particular image. So it's very efficient for data processing. I mean image data processing. Now the next one, that is cloud video intelligence, which has pre-trained machine learning models that automatically recognize a vast number of objects, places, and actions in storing and streaming video, which offers like exceptional quality out of the box. Also, it's highly efficient for common use cases and improves over time as new concepts are introduced. Now the next is Auto ML Vision, which enables you to train machine learning models to classify your images according to your own defined labels. Then AutoML Video Intelligence, which has a graphical interface that makes it easy to train your own custom models to classify and track objects within videos. Even if you have like minimal machine learning experience also, then also it can work very efficiently. It's ideal for projects that require custom labels that aren't covered by the pre-trained video intelligence API. Second category is language. So under language, we have the first product as a Cloud Translate, which like helps you in convert one particular language to another. Okay. So suppose you have something written in Japanese, you can feed that in Cloud Translate and it can get converted into English or like any other language of your choice. So the next one is like Cloud Natural Language, which is like a very famous product to send for doing sentiment analysis. Okay. Then we have with AutoML translation, like AutoML translation. So with AutoML translation, developers, translators, and localization experts with limited machine learning expertise can quickly create high quality and production ready models. So just upload translated image pairs, and like AutoML translation will train a custom model that you can scale and adapt to meet your domain specific needs. Last is AutoML natural language, which enables you to build and deploy custom machine learning models that analyze documents and like categorize them, identify entities with them, or assessing attitudes with them. Now the third main category is conversation. So under conversation, we have the first product as Dialogflow, which is a natural language understanding platform that makes it easy to design and integrate a conversational user interface into your mobile app, web application, or device, bot, interactive voice response system, and so on. So using Dialogflow, you can provide new and engaging ways for users to interact with your product. And Dialogflow can analyze multiple types of input from your customers, including text or audio inputs, like from a phone or voice recording. So it can also respond to your customers in a couple of ways, either through text or speech. Then we have a speech to text API in under conversation, which helps in converting your speech. So suppose someone is speaking and at the same time you want that particular speech to be converted into text. Then in that case, this particular API and machine learning model comes handy and it helps you do that analysis. Similarly, we have text to speech API, which helps in converting given text to the speech at the same time. Now comes to the last building block, that is structured data. So first product in the structured data is AutoML tables, which enables your entire team of data scientists, analysts, and developers to automatically build and deploy state-of-the-art machine learning models on structured data at massively increased speed and scale, which in turn transform your business by leveraging your enterprise data to tackle mission critical tasks like supply chain management, fraud detection, lead conversion, optimization, and increasing customer lifetime value. Now coming to Cloud Inference API. So if you see, time series analysis essential for day-to-day operation of many companies. Most popular use cases including analyzing foot traffic conversion for retailers, detecting data anomalies, identifying correlations in real time over sensor data, or generating high quality recommendations. So with Cloud Inference API, you can gather insights in real time from your typed time series datasets. So moving on to the last product, that is the recommendations AI, which draws on the experience and expertise in machine learning to deliver personalized recommendations that suit each customer's taste and preferences across all your touchpoints. Now, finally, let's look at some of the solutions of AI provided by GCP. The first one is Contact Center AI. With this, you can lower cost and increase customer satisfaction with the best of Google AI technology. So customer service is being improved with AI that understands, interacts, and talks. So with Contact Center AI, you can create agents that are superheroes of your customers. Also, you can enable natural interactions with virtual agents and empower your teams with actionable insights. Moving on to the next one, that is AI Platform Unified. So AI Platform Unified brings AutoML and AI Platform Classic together into a unified API client library and user interface. With AI Platform Unified, both AutoML training and customer training are available options. So whichever option you choose for training, you can save models, deploying models, and request predictions with AI Platform Unified. Now the last major solution, that is Document AI. With Document AI, you can automate data capture to scale to reduce document processing costs. It is built on decades of AI innovation at Google, bringing powerful and useful solutions to these challenges. Under the hood are Google's industry-leading technologies like computer vision and natural language processing that create pre-trained models for high-volume documents. Document AI has already processed 10 billions of tens or billions of pages of documents across landing, insurance, government, and other industries. So now let's have a better understanding of Google Cloud AI platform by trying our hands on it. If you don't have an account on Google Cloud Platform, then create one. GCP is like a really good platform to have your account on. It will ask for your credit and debit card details just for the verification purpose, and you will get a free trial for 90 days with $300 credited in GCP account, and you can use that for the demo I'm showing you, for the exercises I'm showing you. Practice with that. So this is the dashboard of Google Cloud Platform, and we have to go for AI platform. So you can just type here AI platform. So basically, AI platform is used to train your machine learning model and then scale your machine learning model, and then you can take your trained model and deploy it on your AI platform. This is the dashboard where you can, if you upload your model or anything, so it will show all the predictions for it. Also, it will predict traffic on it and everything. Error rate will also show. Prediction latency, it will also show. These kind of things are there. Right now, there's no model uploaded, so it's just showing the basic headings for it. So the first one, the first feature in this one is you can say we can come to notebooks. It is how to generate a notebook instance, just like you have Jupyter notebook, right? In that way only. You can just go to new instance here, and you can go to TensorFlow. These kind of options are there. Like you can upload your simple Python notebook also, which have scikit-learn or pandas or numpy, anything. Simple visualization or things are done, data analysis is done. Under that you can upload, or you can go for the heavy notebooks also, like TensorFlow or for PyTorch, another like Kaggle bit, like this IDE and Kaggle Python also. You can use a different kind of GPU in that, And here we are going with TensorFlow like enterprise with 2.1 with like without GPU, and you also have option of NVIDIA Tesla. Okay, so without GPU and NVIDIA Tesla you can go for, but right now we are going with without GPUs. So here you can create your instance name and everything, or you can also go to the advanced options. Here you can choose the default one have like 4 virtual CPUs, and the standard one, I mean, standard one has 4 virtual CPUs, 15 GB RAM. And if you like want more, you can select more RAM, and or if you want the less one, you can select for the less one. And then you can also select for GPU whichever you want. Okay, like Tesla K80, P100, V100, like various options are there. Okay, and you can just and then create it. Okay, it takes time. So what I did is I already created one. So we can just go back and launch from here. Can just open Jupyter Notebook here. So naturally it comes with all the built-in packages of TensorFlow and everything. But if you want to like install some specific package, you can just go to terminal. Here you can type like pip install XGBoost. You can install like, okay. So it's downloading. Install that. Okay. We have this multiple options here, launching a notebook or a simple Python console or everything. So we can just go to notebook right now. You can select, or there are like multiple languages you can select. Okay, you can also select Python 2 or other languages also. Right now I've chosen Python. So we can check the version of XGBoost we have installed. Okay, so we can type just we can import XGBoost as XGB, then XGB for checking the version, XGB dot double underscore version double underscore. Okay, then we can also launch like simple Python console also. So what you can do here is it's come as a simple Python. So what you can do, you can go for like checking the TensorFlow version also. So just import TensorFlow as TF, and then for checking the version, same TF dot underscore underscore version underscore underscore. So this is the 2.1.3 version of TensorFlow. So this is how you can play with your Jupyter with this notebook, just like you play with a manual Jupyter notebook, right? So yeah. Now coming to the next service, that is AI Hub. So what AI Hub generally does is, if there is a like Google Cloud AI team is there, and Google Cloud team now they just post the content here, the latest contents or whatever kind of content, whichever is useful for you, you can take that, and you can like if you want to understand any model, you can get it from here, or if you want to run any RNN or something, you can understand and get a research content from here. So that's just one thing. Second thing AI Hub does is, if you working in an organization, they have separate teams or something, you can share your model here, and it will be, you can put the limitation of it will completely be private to your team or certain to multiple teams. If you want to share your model with, that will be completely private. So that's a very good thing with AI Hub. Okay, you can get your model uploaded here and share it with the people you want to with your customizations. Okay, so that is AI Hub. Then we have data labeling. So in data labeling, what happens is you put your data set, be it of image or videos, in whichever manner. It gets annotated by the human annotators. So you can just create it here. You can insert your data set, whichever like image, video, text, or you can create, and then you can give your parameters or descriptions, whichever way you want your data to get annotated. So you can give a better description. It will give you a better results on the basis of that. The more your description is accurate, the more accurate will be the annotations. Okay, so that's how it can be done. Then we can go back to the other service, that is you can go to jobs. The jobs here is you can like create a new training job from here. We have option of built-in algorithm training, then a custom code training. Like custom code training, you can write your model, create your model, and you can upload it here, and whichever way you want to upload, or you want to give any kind of model, that is custom code. But its plus point is in built-in algorithm training. With built-in algorithm training, we get the option of like you can select any kind of algorithm. These option all the algorithms are given: XGBoost, distributed XGBoost, linear learner, wide and deep learner, image classification, image object detection. These are the new ones which Google Cloud introduced, like TabNet and NCF, all these things. You choose your algorithm, then you can give your training data you can give, and then you can give your algorithm arguments also, and you can provide the split ratio also. Also you can give other parameters also. On the basis of that parameter, the model will be analyzed and prepared. So that's a very plus point, as it like saves a lot of time. Instead of making the whole model, it just directly creates a model for you. You don't have to code and do everything. So that's a very plus point. And then we have pipelines. So what pipeline does is pipeline addresses all your MLOps life cycle, starting from acquiring data preparing data, analyzing data, and training the model, analyzing the model, deploying the model, and then tracking your like model artifacts, evaluating the model. It is like built on Kubeflow pipelines and TensorFlow extended modules. So it basically allows you to build an end-to-end pipeline and at the same time deploying the end-to-end pipeline. So this is what the pipeline AI platform pipeline is. So then we have like models. Models is something if you want to do code wise, like command line programming, you have to do like command line model you have to make or analyze it or deploy it. That's where model is used. We can discuss that later. That's actually a big process. So yeah. So I just wanted to show you the demo thing for this. So this is how the Google Cloud AI platform works. So this is the general description for it.
What exactly is Google Cloud Text to Speech, right? So Google Cloud Text to Speech is one of these services that Google Cloud Platform offers. It's nothing but a service that enables developers to synthesize natural sounding speech from a certain text. So it offers over 30 plus voices that you can choose from. And basically, it's a screen reading service API. So APIs are something that you can call to invoke a certain function or a service, right? So it's a screen reading service that Google Cloud provides its users with, right? So it's something that Google provides worldwide. And also the fact that Google Cloud Text to Speech turns text into sound files of high fidelity. So high fidelity is something that comes into play when you want to make the voice sound human-like. So if it is high fidelity, it means that it sounds very much like humans. So next we come to the fact that Google Cloud Text to Speech has been developed by Google and DeepMind. Now Google has helped with neural networks, whereas DeepMind is a company which focuses mainly on artificial intelligence. Now these two have collaborated before in making the Google Maps API or the Google Assistant API that are there. Now both of them have combined with the neural networks and artificial intelligence services that there are and APIs that there are. Both of them have combined to create Google Cloud Text to Speech, right? So next we come to this pricing for Google Cloud Text to Speech. Now the first question that comes into mind is it free? Now Google Cloud Text to Speech is free for a certain amount of time, just like other AWS and cloud services and GCP services that are there, right? So for a certain point of time, the standard Google Cloud Text to Speech pricing is free for 0 to 4 million characters that you type. But after the 4 million characters have been crossed, this price limit exceeds to $0.00004 per character, right? So that's a very small amount. Or if you do not use the standard version for pricing or speech, you have the WaveNet speech, which allows you to have 0 to 1 million characters to be spoken. And if you exceed that limit, you will basically have to $0.00016 per character, right? So this is the basic pricing valuation that Google Cloud provides its users with. Also, when it comes to pricing, you have to remember that SSML and spaces are definitely counted when it comes to pricing your APIs and services that you use. Now, SSML is like HTML and any other language that you use to basically convert and synthesize the text you have into a certain synthesized voice, right? So apart from the fact that SSML is counted during pricing, the price is based on the number of characters you have sent, right? So if it exceeds the free limit that you have, you will be charged based on what the charges are, right? Next up, we have the key features of Google Cloud Text to Speech. Now, when we talk about Google Cloud Text to Speech, first thing we talk about is creating audio files. Now, audio files can be created using Google Cloud Text to Speech. So this is where you have a choice of over 30 voices. So, and this is why this is a very in-use tool when it comes to Google Cloud Platform, right? Next up, we can see that pitch tuning is another feature that Google Cloud Text to Speech provides its users with. Now, pitch tuning is basically the ability for the user to personalize their pitch up to set 20 semitones, right? So that is one of the features that is there. Next up, we talk about the integrated REST APIs that are there. So Google Cloud Text to Speech allows you to use integrated APIs with Python, Java, etc. so that you can make those function calls, deploy a program, and then using that program, use the Google Cloud features and services and get a text to speech, right? So you can integrate APIs easily with any application and the REST APIs or the gRPC requests, right? So that can be done anywhere using PCs, tablets, let's say IoT devices, etc., etc. And finally, the last feature is the fact that Google Cloud Text to Speech is text and SML supported. So SML basically allows you to customize the way you want the speech to be said. Like for example, if you want to add pauses or numbers or let's say date and time, you can do all of that using Google Cloud Text to Speech. And SSML is something that is used to do that, right? Next, we come to the benefits of Google Cloud Text to Speech. Now, the first benefit is high fidelity speech. Now, high fidelity speech, like we talked about, is the fact that how human like can your voice get? And with Google Cloud Text to Speech, you can really get very human like voices using DeepMind's WaveNet voices that are there. So, that is something which is extremely efficient when it comes to high fidelity voices. Next, we talk about improving user interactions and customer interactions. Now, Google Cloud Text to Speech will automatically improve customer interactions if it can basically get that engagement. Now, when you change, let's say, for example, you have a certain chatbot in a website. Now, the fact that the chatbot is typing whatever message it is delivering to you can get a bit tedious. So if you change the chatbot to, let's say, a Google Cloud text to speech enabled assistant that you might have, that assistant might be able to basically interact with you using Google Cloud text to speech, and it's much easier and faster for you to communicate, right? So that is why the main thing that Google Cloud text to speech does is it increases engagement for users based on the UI. So the more the engagement of the users, the more is the customer interaction improvement. So that is why these two are based on one another. So engagement will directly coincide with customer interactions, right? So next we come to the demo for Google Cloud text to speech. Right. So when you go to Google and type Google Cloud text to speech, this is something that you can see. And here you can see that it has high fidelity speech. So what you can do, you can just check out some basic things here. Let's say, for example, this is the text that you want to speak, right? And this is the language. So you can choose the language that you want the person to speak in. And I want him to speak in English. So I'll keep it as English, United States. And that is the speed at which he'll speak it and the pitch at which he'll speak, right? So you can change this, and you can also see the JSON format of the file, let's say, of the audio file is here. Now, this is done using an API, which we will talk about in some time. So let's say this is the voice that is being used, the USD type of voice using wavenets. You can use standard as well. And after that, when you go to speak it, so this is basically showing you that this text that you have is being synthesized from text into speech. Now what we can do here is we can now go to the console and see how we can use APIs. So now that we basically want to use the Google Cloud Text to Speech API with Python, first thing we have to do is go to Google Cloud Text to Speech and try this API and enable it firstly. So this is enabled. Now we have to try this, right? So what we do here is, let's say, let's go back to the console, right? Yeah. So we go back to the console and basically go back to the project we created. Now this is the project that I created. What I can do here is go back from APIs to credentials, right? So here what I have to do is I have to launch an instance, a virtual instance. So I can go to IAM and admin and go to service accounts. Now when I go to service account, I can go create a service account, and these are the information that I have to fill in for service accounts, right? So the name is all you need to do here when you create service accounts. So once you basically made a service account, you can just see that the service account is being made here. What you can do is go here and manage keys, right? So when you go to manage keys, what you can do is add another key. And when you go to add another key, you can go to select key and then go to JSON and download this. Now I'll not be doing this because I've already done it and it's active. So once all of this is done, what we need to do is go to, let's say, a Python environment. And first thing we need to do is create a Python environment using CMD, right? So basically, once you've created a Python environment, you'll have files which are the scripts, the libraries that are there, the packages that are there, the Python environment has been created. So I'll show you how the entire process of using the API for text to speech is happening here. So here we are basically importing the services that are there using text to speech. And now what we need to do is cloud import text to speech. So this is something that we are importing, and this will be used for changing text into speech. Now the second thing here we do is create a virtual environment, and I name the virtual environment Google Application Credentials. So what you do after this is the key that you created, the JSON file that you created. So that file has to basically be in here. So let's go back here and you can see this is the name of my JSON file. And if you go back here, you can see this file for the JSON is same. And here I'm creating a client environment for Python in the CMD, right? And this is the text that I want to speak. So since we are using SSML here, we want to use SSML syntax. Now let's just go back here and let's just see SSML rendering of plain text. So if you want to say something like 123 street lane, you have to basically type in the syntax like this using SSML. So you just add a speak tag here, right? So similarly, what we've done here is added the speak tag and then added what we want to say. So this is basically synthesis input, which is another variable that I've defined to basically use this method, right? So synthesis input method will basically use this as SSML and read out the text that I've done. And this is basically another variable where I've basically selected the parameters of the kind of voice I want in my virtual assistant. So language code wants you to basically select the kind of language you want your virtual assistant to speak, and SSML gender will basically help you to select the finer things. Let's say when you want to add pauses, when you want to, let's say, change it to male, from male to female, all of that. And this is another voice that we have. So we can choose to do this or not do this as well. So let's just keep it for now. And what I've done here is, since maybe some of these voices are not there in list of voices that are available in Google Cloud Text to Speech, so we've done this. We've printed the client and the list of voices that are available, and using that list of voices, we are configuring our audio clip, right? So there's another variable that I've defined where basically we talk about as response one. So this is basically the client response to the synthesized text, where the synthesis input variable is basically put into the input variable, and voice variable is another one which takes into account the first voice variable I've defined here in English and in female, right? So, and then the audio configuration is then seen here. So I've changed it to audio configuration and encoding. So encoding is something that is again used to change the text into speech, right? So finally what I've done is, when I basically run this Python file, there'll be a file called as audio.mp3 that will be created. And when I open that audio.mp3 file, the response that I'll get is based on this female voice speaking in English. So what I want her to say is, what you hear now is a text to speech demo, right? So let's try it out. Make sure that you save everything that you have. And so now just go and run this file, and you can see once you run this file, there should be an audio file that's there. And right. So let's go click on this audio file, and
Hi, this is a text-to-speech demo.
as you can see here, she's saying exactly the words that I have typed in here. Now what you can do is you can play around with this, you can change a bit. Let's say you don't want it to be in SSML and you want it to be just plain text that is being read out. So all you need to do is just change this and change this. Let's say hi, right? And here, since you're doing it as plain text, what you need to do here is change this to text, right? So when I do text, now change to text, and let's say I want a male voice, right? So change this back to male and save it. So now that you've saved it, go back here and let's say run the file again. Right, you've run the file and an audio file has been generated. Now let's play this audio file and see if it's working.
Hi, what's up?
So as you can see, the voice has changed to a male voice and it's again saying what I wanted to say. So since I've changed this, you can see it's saying hi, what's up, and not what was written here before. So that is how you basically use Google Cloud Text-to-Speech APIs using Python. So that is basically the end of the demo. Right. So finally, let's talk about the future scope and the various use cases that Google Cloud Text-to-Speech has. So Google Cloud Platform is a platform which provides its users various cloud computing services. There are various emerging use cases, right, for the text-to-speech API, where the developers have used this service to improve interactions between customers and voice-enabled platforms like IVR systems. So text-to-speech is also being considered with AI to basically create playlists of memos or transcripts to prioritize data based on relevance of what has been spoken in, let's say, meetings and other such things that go on in industries. So Google Cloud Text-to-Speech is really emerging as one of the most used features when it comes to cloud computing and Google Cloud. And it is something which has made life way easier. What exactly is Google Cloud Vision API? So Google Cloud Vision API is a machine learning service that is provided by Google Cloud Platform. And this API allows developers to basically integrate vision detection features into their applications, right? So this includes labeling, face detection, OCR, which is basically optical character recognition, and it changes the way that apps integrate with images. So after that, what we talk about is why do we need to use Vision API? So why do we need to use Cloud Vision API? So the first reason why we use Cloud Vision API is the ML models that it provides, because these models can be used, they can learn and predict image content very easily. And then basically the fact that it is a fairly easy to use REST API and you don't need to really do a lot of things and it's fairly easy to learn. And most importantly, it provides pre-trained ML models through the REST APIs that are there. So this is why you need to use Cloud Vision API. Now we talk about how Cloud Vision API works. So first thing we see that an API takes your requests and gives you a certain response. So you give in a certain request, the API takes it and gives it to the server gives the API the response, and then the API gives it back to you. And next we see that Vision API then categorizes these images that you have. So it helps detect faces, objects, all of that, and gives you certain insights on that, right? So new avenues like building metadata is basically something that is extremely important when it comes to image cataloging. And image cataloging is something that these developers do. And finally, we see that developers build rich metadata all around to perform custom searches and give good results. As you can see here, for example, we can see that for this image that you see here, we have a search which basically gives it labels such as the mode of transport that you can see, the transport that you can see, the street that you can see, the urban area. So this is what it's detecting from the image that you've put, right? So this is how Cloud Vision API works. Next, we come to the features of Cloud Vision API. The first thing we talk about is the fact that Cloud Vision API helps in detecting labels. Now, detecting labels basically allows you to extract information about certain entities in an image. And you can basically group them in a broader category. So labels can identify general objects, locations, etc. So this is one of the features of Cloud Vision API. Next, we see optical character recognition, or OCR. Now, OCR is basically the electronic conversion of images of typed, handwritten, or printed text into machine encoded text. So what basically this means is that if an image has some sort of text in it, be it scanned, be it imprinted in the image, it doesn't matter. But if there is some sort of text in the image, OCR will help recognize it and then change it into machine encoded text. So this can be from scanned documents or from the web as well. Next, we come to web detection. Now, when we talk about web detection, this basically can be used to detect web references for an image. Let's say, for example, if you use an image from the internet, you can basically check out the URL, the full and partial matching images, and the pages that use the same image that you downloaded. So this is what Vision API helps with, right? And finally, we come to facial recognition. It is one of the key features based on the image that you provide. Now, Vision API uses sentiment analysis to give tangible insights to users. Now, these insights can be, let's say, what kind of facial features and structure they have, the kind of person he or she is. These are the insights for facial recognition. So basically, this can detect faces if face grouping is on. So next we come to the benefits of Vision API. Now, Vision API, the main benefit is that it gives you a lot of insights on any image that you provide it with. Let's say, for example, that Cloud Vision generates tangible insights, right? So, safe search, label detection, and color schemes are all these different domains that you can use to basically give insights to a certain image. Now, all of these are different. Let's say labels basically tell you the type of image it can be. Safe search tells you if your image is safe enough to be on the internet. Next, we come to entity detection. Now, entity detection is basically the fact that you can identify web labels, text, images within an image and other such entities for the user very easily. And that is a very important benefit as well as a feature. And then we come to moderation of content. Now, Vision API moderates your content using safe search. Like we talked about before, safe search is basically provided by Google. So explicit content will be marked unsafe if safe search is on, and content is based on user interaction, right? So these are the benefits of Vision API. Then we come to the demo for Cloud Vision API. So you go to your Google Cloud Platform account console and you go to APIs and services, go to library and just type in Vision API. We have Cloud Vision API right here and go to manage. So this is Cloud Vision API and this is already enabled, and you have to make sure that before you use any API on Google Cloud Platform, you have to enable it separately. So let's check out how Google Cloud Vision basically gives you insights on certain images. Right. So you can just drag an image in here. Let's say, for example, let's go in here and check this out and click this as well. So as you can see, what Vision API does is gives you insights on what the image might or might not be. Now this gives you a chance that it might be a person, there is some sort of footwear in the image, and there can be animals as well. So it is 71% sure of this, 55% sure of this. So there are labels then that it might be a mammal word, and all of these are different. Next we come to logos, text, if there are text. So there's no text here, so basically there is nothing in here. And the properties will basically tell you the different color schemes that are there here. And safe search finally gives you the kind of content the image has to provide. So this is a fair enough image for the internet. So let's check out how to use Google Cloud Vision API with Python. So when you go to your console, what you have to do is enable Google Cloud Vision API, then go to credentials and go to create credentials and go to service account. Now make sure you give the name to your service account. Let's say Vision API and go to create and continue. Now here you go to search role. So you go here and you check currently used and you go to owner, and this is basically you're granting the access and the role for your service account, right? And then after this you click on done. So once you've created your service account, you can go check it out, the description of it, and basically just go and go to keys. So you basically then go to key and create new key and download the JSON format, and private key is now saved to my computer. So once you've downloaded your JSON file, you can then go to your VS Code editor, and let me just explain this code to you. So before doing any of these, you have to make sure that you have made a Python environment. I've named my Python environment Vision API demo, and this is it. And then you can go to your VS Code. So what you have to do is, before doing any of these, you have to make sure that through CMD or any PowerShell, you have to install Google Cloud Vision, and that once that is installed, you can go to your editor, and let me just explain this code now. Right. So first you import the OS and IO files. Then from the Cloud Vision API that you installed through CMD, you can import Vision and Vision V1 instances. So these are packages that you can import. So the difference between Vision and Vision V1 is that Vision V1 has to offer two more methods than Vision, right? So the next thing we do is that we have to create Google application credentials. And once that is created, this is what your JSON file is used for. So just go back here and use this as your name for the JSON file. And as you can see, this is the name of the JSON file, and you just have to put .json, right? And just let's save this. So the next thing we do is move to client. Now here we basically use the Vision Image Annotator client method. Now what we can see here is that we are defining a detect text method. Now detect text is one of the functions from Google Cloud Vision V1. So here we can see we have defined a function detect text, and this is the code for it. And what this means is that detect text is one of the features of Vision V1, and that is where it's imported from. And what it does is reads content from the image file that you have, right? And after this, what we do is that we have a response for the image that is being read, right? So whatever is being read is then responded as annotations to the user, right? And here we've imported pandas before. Now pandas is basically used for data frames, SQL, and other such, let's say Excel and all of that. Now pandas will be used for data frames, and this is the code for it: pt.dataframe columns, and this will show me the location of any text that we have in the image and the description that is there. That is the description of the text that is there in the image. Now what we've tried to do here is another version of OCR, where basically optical character recognition will happen. It will detect text from the image that is present there, right? So the next thing we do is, after this, add the dictionary and add text to descriptions and locale, right? And then return the function for it. The last thing we do is print our file name and the image that you want. Now for this we use print detect text os.path join and the file name and folder path. Now what you need to do is run this. Now before you run this, make sure that you have the image that you want open. Let's go and check out images, and this is the image, and you can see there is some text here. So let's go try and run this code. Right. So as you can see, it's basically giving us an output, and this is the text that you have here. If you go up here, you can check that the location of the text in the image and the text that is there has been given. The entire text you can see here in one line, and here we talk about the locations that is there for locale and description. Then let's check the image now. The image says believe you can, and you're halfway there, right? And let's go back here. So this is the image text that is present, and for location one we have believe. This is true that you can, and like this you can see that Google Cloud Vision API is helping me detect the text that is there in this image, right? So this is how you basically use Google Cloud Vision API using Python. Finally, we come to the use case for Google Cloud Vision API, which is nothing but the Google Lens. Now, Google Lens is the most popular and widely used case for Vision API. So, Google Lens attempts to identify the object or read labels in text and show relevant search results, right? So what you're doing is basically you're directing the phone's camera at an object, and that when directed towards the object will basically give you insights on whatever you're pointing it at, right? So Lens is also integrated with Google Photos, Google Assistant, and other internal Google services that are there present.
What Google Cloud IAM is. So IAM, which means Identity and Access Management, lets you grant granular access to specific Google Cloud resources and helps prevent access to other resources. IAM lets you adopt the security principle of least privilege, which states that nobody should have more permission than they actually need. Let's now understand how Google Cloud IAM works. First, let's take a real-time example, or say real-life scenario. Suppose if you enter a company and you got the visitor card, so you have a very limited access through it. Like you can access reception, you can access cafeteria, you can access a lobby where you can rest. Okay, now suppose you got selected in that company. Okay, you got selected as a fresher, as in the position of junior analyst, you can say. Now you have much more access than cafeteria, reception, and lobby. Now you have access to certain databases, you have access to certain maybe cloud resources also, a little bit, whatever is required for you for analysis purpose. Also you can have access to various analytical tools also, but you don't have complete access to all of them. Suppose now you are working under a senior research analyst. This senior research analyst, or you can say senior analyst, have much more access than you because you are a junior analyst. Senior analyst have much more access to more cloud resources. He has more access to much more Excel sheets also, you can say, and also like various other analytical tools also. Now suppose there's another person who isn't an analyst team, he's in cloud team, say he's a cloud engineer. So now you can see he might having the access of a lot of cloud resources compared to you, but he won't be having access to certain database services which you have access to, certain databases also which you have access to, a certain analytical tools also which you have access to, he might not be having that access. So that's how a certain rights and certain accesses are being provided to different teams and depending on their work. This is just, you can say it as a real time example. Okay, that's how access and identity management works. So now let's understand how IAM works in Google Cloud. With IAM, you manage access control by defining who, means identity, has what access, means role, for which resource. For example, compute engine virtual machine instances, Google Kubernetes Engine clusters, and cloud storage buckets are all Google Cloud resources. The organizations, folders, and projects that you use to organize your resources are also resources. In IAM, permissions to access a resource isn't granted directly to the end user. Instead, permissions are grouped into roles, and roles are granted to authenticated members. An IAM policy defines and enforces what roles are granted to which members, and this policy is attached to a resource. When an authenticated member attempts to access a resource, IAM checks the resources policy to determine whether the action is permitted. You can see this following diagram illustrates permission management in IAM. This model for access management has three main parts. The first part is member. So a member can be a Google account, you can say, for end users, and a service account, you can say, for apps and virtual machines. And then there is a Google group or a Google workspace or cloud identity domain that can access a resource. The identity of a member is an email address associated with a user, service account, or Google group, or a domain name associated with Google workspace or cloud identity domains. Then there is a role. So a role is a collection of permissions. Permissions determine what operations are allowed on a resource. When you grant a role to a member, you grant all the permission that the role contains. Okay. And then there is policy. So the IAM policy is a collection of role bindings that bind one or more members to individual roles. When you want to define who has what type of access, means role, on a resource, create a policy and attach it to the resource. Now let's understand the concepts in IAM. First, let's understand the concepts related to identity. So in IAM, you grant access to members, and members can be of the following types. Like it can be a Google account, which represents a developer, an administrator, or any other permission who interacts with Google Cloud. Account can be an identity, including gmail.com or other domains. New users can sign up for a Google account by going to the Google account sign up page. Then there is service account. A service account is an account for an application instead of an individual end user. When you run code that's hosted on Google Cloud, the code runs as the account you specify. You can create as many service accounts as needed to represent the different model components of your application. Okay. Then there is Google Group. So a Google Group is a named collection of Google accounts and service accounts. Okay. And every Google Group has a unique email address that's associated with the group. You can find the email address that's associated with the Google Group by clicking about. There is this option about on the home page of any Google Group. Google Groups are a convenient way to apply an access policy to a collection of users. You can like grant an access controls for a whole group at once instead of granting or changing access controls one at a time for individual users or service accounts. You can also easily add and remove members from a Google group instead of updating an IAM policy to add or like remove users. Google Groups don't have login credentials, and you cannot use Google Groups to establish identity to make a request to access a resource. Then there is Google Workspace domain. Google Workspace domain represents a virtual group of all the Google accounts that have been created in an organization's Google Workspace account. Then Google Workspace domains like represent your organization's internet domain name, such as example.com. You can just for example. So I'm just naming it as example.com. And when you add a user to your Google Workspace domain, a new Google account is created for the user inside the virtual group, such as like you can take it as username at the rate example.com. Like Google Groups, Google Workspace domains cannot be used to establish identity, but they enable convenient permission management. Then the fifth one is Cloud Identity Domain. A Cloud Identity Domain is like Google Workspace domain because it represents a virtual group of all Google accounts in an organization. However, Cloud Identity Domain users don't have access to Google Workspace applications and features. Then the next one is all authenticated users. So the value all authenticated users is a spatial identifier that represents all service accounts and all users on the internet who have authenticated with a Google account. So this identifier includes accounts that aren't connected to a Google Workspace or Cloud Identity domain, such as personal Gmail accounts. Users who aren't authenticated, such as anonymous visitors, aren't included. And the last one is all users. So the value all users is a spatial identifier that represents anyone who is on the internet, including authenticated and unauthenticated users also. Now moving ahead to the concepts related to access management. When an authenticated member attempts to access a resource, IAM checks the resource's IAM policy to determine whether the action is allowed or not. So the first one in this is resource. If a user needs to access to a specific Google Cloud resource, you can grant the user a role for the resource. Some examples of resources are projects, compute engine instances, and cloud storage buckets. Some services support granting IAM permissions at a granularity finer than the project level. For example, you can grant the storage admin role to a user for a particular cloud storage bucket, or you can grant the compute instance admin role to a user for a specific compute engine instance. In other cases, you can grant IAM permissions at the project level. The permissions are then inherited by all resources within that project. For example, to grant access to all cloud storage buckets in a project, grant access to the project instead of each individual bucket. Or to grant access to all compute engine instances in a project, grant access to the project rather than each individual instance. And the next one is permissions. So permissions determine what operations are allowed on a resource. In the IAM world, permissions are represented in the form of service.resource.verb. For example, if you are using PubSub, then you can give it as pubsub.subscriptions.consume. That becomes service.resource.verb, right? Permissions often correspond one-to-one with REST API methods. That is, each Google Cloud Service has an associated set of permissions for each REST API method that it exposes. The caller of that method needs those permissions to call that method. For example, if you use PubSub and you need to call the topics.published method, you must have the PubSub topics published permission for that topic. You don't grant permissions to users directly. Instead, you identify roles that contain the appropriate permissions and then grant those roles to the user. So the third one is roles. A role is a collection of permissions. You cannot grant a permission to the user directly. Instead, you grant them a role. Then when you grant a role to a user, you grant them all the permissions that the role contains. So there are several kinds of roles in IAM, like there are basic roles. Roles historically believe in the Google Cloud Console. These console are owner, editor, and viewer. Cautiously remember that basic roles include thousands of permissions across all Google Cloud services. In production environments, do not grant basic roles unless there is no alternative. Instead, grant the most limited predefined roles or custom roles that meet your needs. Then there are predefined roles, so roles that give finer grained access control than the basic roles. For example, the predefined role PubSub publisher provides access to only publish messages to a PubSub topic only. Then there are custom roles, so roles that you create or tailor permissions to the needs of your organization when predefined roles don't meet your needs. Like you can see here, an example of role is given, like the role is assigned as a compute.instance admin. Like the role is assigned compute.instance admin. So under this role, you have permissions to access all the resources under this role, like compute.instance.delete or like compute.instance.get. Everything is you can access. Now the next one is IAM policy. So you can grant roles to users by creating an IAM policy, which is a collection of statements that define who has what type of access. A policy is attached to a resource and is used to enforce access control whenever that resource is accessed, as you can see here. So an IAM policy is represented by the IAM policy object. An IAM policy object consists of list of role bindings. A role binding binds a list of members to a role. IAM provides a set of methods that you can use to create and manage access control policies on Google Cloud resources. These methods are exposed by the services that support IAM. For example, the IAM methods are exposed by the Resource Manager, PubSub, and Cloud Life Sciences APIs. Just to name a few, like the IAM methods are set IAM policy, which sets policies on your resources. Then there is get IAM policy, which gets a policy that was previously set. Then there is test IAM permissions that sets. Then there are test IAM permissions, which test whether the caller has the specified permissions for a resource or not. Now, moving on to the next and the last one, that is resource hierarchy. So, Google Cloud resources are organized hierarchically. Like the organization is the root node in the hierarchy. Then there are folders, which are children of the organization. Then projects are children of the organizations or of a folder. And the last one, like resources for each service, are descendants of projects. Each resource has exactly one parent. So this following diagram is an example of a Google Cloud resource hierarchy. You can set an IAM policy at any level in the resource hierarchy, the organization level, the folder level, the project level, or the resource level. Resources inherit the policies of all their parent resources. The effective policy for a resource is the union of policies set on that resource and the policies inherited from higher up in the hierarchy. This policy inheritance is transitive. In other words, like a resource inherit policies from the project, which inherit policies from folders, which inherit policies from the organization. Therefore, the organization level policies also apply to the resource level. For example, in this diagram, topic underscore A is a PubSub resource that lives under the project example prod. Suppose there is a account named Mika at that example.com, and if you grant the editor role to Mika at that example.com for resources for example production and grant the publisher role to song at that example.com for topic underscore A, you effectively grant the editor role for topic underscore A to Mika at that example.com and the publisher role to song at that example.com. The policies for child resources inherit from the policies for their parent resources. For example, if you grant the editor role to a user for a project and grant the viewer role to a same user for a child resource, then the user still has the editor role grant for the child resource. If you change the resource hierarchy, the policy inheritance changes as well. For example, moving a project into an organization causes the project to inherit from the organization's IAM policy. Now let's understand the practical actionable settings you can modify in the IAM, which will greatly improve the security of your project. So the first one is you can enforce multi-factor authentication. You can say it as MFA, which is a method where not only is one piece of information used to authenticate a user, example password, but there's also at least one additional source of proof needed to establish that the right person is accessing a system. On Google Cloud Platform, users authenticate themselves using Google accounts. These can be individual email addresses registered as a Google account or more commonly like accounts of a Google suite domain. On the Google Cloud Platform side, you cannot enforce that the Google accounts that have access to your project must have multi-factor authentication enabled, means MFA enabled. But if you only grant access to users from your Google suite domain, then the Google suite domain administrator can set up MFA on the Google suite domain in a way that forces everyone to use it. If you need to give access to people without accounts in your Google suite domain, then you can create accounts for them in your Google suite domain for the sole purpose of accessing your project. This way you can enforce settings on their accounts. If you combine both these rules, then you can be certain that every user who has access to the Google Cloud Platform project needs to validate themselves using MFA, means multi-factor authentication. This makes it much harder to compromise your project even if the password for an email address leaks from another source. Second thing is you can set up password policy for users. The password policy settings are technically not inside the Google Cloud Platform, but at the discretion of the Google Suite domain administrator. If you only allow users from your domain and the domain is set up with the right password policy, then these two things combined will result in the password policy being enforced on all your Google Cloud Platform users. Third one is give the necessary but the least possible privileges. So it is a good practice in general to only give the minimum necessary privileges to all of your users. If all of the previously discussed account protection methods fail, your attackers will still have fewer services to break into or steal information from. The actual implementation of this principle will vary based on your usage patterns. For example, if your database administrators only need to do Google Cloud SQL administration tasks, don't give them project editor role, give them a Cloud SQL admin role instead. Also, what you can do is you can set up quotas. Like default quotas are set for every newly created project on Google Cloud Platform. This is a least resort security control to avoid unexpected runaway spending. For example, if you have a faulty script creating resources in a recursive manner, it will only be able to create them up to the quota limits. It can also protect against compromised account creating a lot of new resources for the attacker's purposes. The quotas can be changed on the quotas page, but it requires the service usage.quotas.update permission, which is only included in the following predefined roles like owner, editor, and quota administrator. So if a compromised account or faulty script does not have the permission, then the spending can only increase up to the quota limits. Last thing is check and rotate service account keys. There is another type of account on Google Cloud Platform besides the user accounts, that is service accounts. So service accounts are meant for programmatic use cases. They cannot be used to access the Google Cloud Console because they are only valid for Google Cloud API access. The most frequent use case is to run applications or instances inheriting the rights of a specific service account so they can access other cloud service without extra authentication. Service account use keys for authentication. One service account can have multiple keys associated with it. It is a good practice to regularly rotate the keys of the service account. This can be achieved by creating a new key for the service account, then overwriting the current key with the new one everywhere it was saved, and then deleting the old key associated with the service account. This way, even if an application where the key was stored is compromised without your knowledge, the attacker will only have a limited time window to use the key. Now that you have a theoretical understanding of Google Cloud Identity and Access Management working and concepts, let's now see a practical demonstration of it on Google Cloud Platform. So we are at Google Cloud Console now. This is how the dashboard of Google Cloud Platform looks like, means console looks like. You can see the ID dhruv.pandey@edureka.co. So what we are going to do is we are going to see the identity and access management. So let's move on to IAM and just click here and go to IAM and admin. And here you can see all the permissions the accounts have. So we are going to provide a new access to the, like you can also see the project here, it's demo billing. So from this project I will be giving the access. So let's add account. So you can add it from here. I'm going to add like the other account of mine in it. So yeah, it will be at project level. You are going to give a role now. So select it, go to project, give editor. As I have explained you how we have to give the editor role here, editor. Now you have to give another role at resource level. That's what is given in the policy, right? I have explained you the policy of access management. Choose a resource for it. So you're going to choose cloud storage. We can choose. So cloud storage, where it is. Yeah. So we are just going to choose the viewer option. Okay. So yeah, save it. But at the project level, we have the editor option. Remember that. Okay. So yeah, it's been added now. Now you can just go to like, because you have the editor permissions at the project level, so you can just simply see how like we can go to virtual machine also. So here you can go and you can see if there is any virtual machine is there. Oh, just a second. Right now I am logging in the same account. So what I can do is I can go to another account that is which I have given permission to, right? So I'll go to this account. Sorry. So now I'm logged into my other account, that is roughpande2595@gmail.com. You can see now. So in this account, I have been to the VM instance now. So in this, you can see like there is no VM created now, but I can create an instance from here. And similarly, if you go to cloud storage, you can access other services also through this account because you have the editor option at project level. Okay, let's go to cloud storage, and you can see there is this demo store cloud is here. So you can even create a new bucket, or you can just go to this one and you can upload any file into it also. Like I'll show you how upload files. Say okay, you can just upload this. So you can see how upload has been done because you have all the rights of editor. Okay, you can delete it also. So you just select this one. So you can just delete it from here. Yeah, action is permanent and it will get deleted. Now go back. You can even delete this one also. You can just select it and you can delete it from here. Okay, now let's move back to our own IAM permissions. This is the main account I am opening. You can see here. From here I will go to the IAM roles and everything. So IAM access management means identity and access management. And what I can do here is I can edit the roles. So what I can do is I can delete it from here. Like okay, I will not delete it at project level. No, I will delete it the editor. Okay, but the resource level it will remain, but it won't be completely be deleted. Okay, so I'm just deleting this one. So just select here, delete role one, and save. Okay, now if you refresh it, you will see like you won't be having access to it. Now we have deleted the editor role. What we can do is we can choose the other account. Okay, now access to the secondary account, and then we will go to storage. Sorry, just a second. Cloud storage. So you can see the permissions are being limited, so you don't have sufficient permissions to view this. Even though the other way to view this is because you have the viewing option and don't not at the project level but at the resource level. So you can view it from the Cloud Shell. There are certain codes being given in the documentation part of identity and access management in Google Cloud. You can see the codes and you can just type it here and at the command line interface of the Google Cloud. It is Cloud Shell, which is this. You can activate it from here and you can just access means so you can view the files from here. Okay, but not at the console. You can only be able to see it from command line interface, that is Cloud Shell. Now let's move back to this my main account. Now I can even delete these roles, like the roles I provided now. So I can delete this role completely. Okay, so I will just remove it from here, confirm. Okay, so that's how the role has been deleted. I hope you have understand how identity and access management in Google Cloud works. You can configure billing on Google Cloud in a variety of ways to meet different needs. So let's start with having a brief overview of a resource in Google Cloud. So the first question that arises while having an overview of a resource in Google Cloud is, what is actually a resource? In the context of Google Cloud, a resource can refer to the service level resources that are used to process your workloads, virtual machines, databases, and so on, as well as to the account level resources that sit above the services such as projects, folders, and the organization. Now, the next thing we need to understand under resource overview is, what is resource management? So resource management is focused on how you should configure and grant access to the various cloud resources for your company or team, specifically the setup and organization of the account level resources that sit above the service level resources. Account level resources are the resources involved in setting up and administrating your Google Cloud account. Now, the third and major thing is resource hierarchy. Google Cloud resources are organized hierarchically. This hierarchy allows you to map your organization's operational structure to Google Cloud and to manage access control and permissions for groups of related resources. The resource hierarchy provides logical attach points for access management policies like identity and access management and organizations policies also. Both identity and access management and organization policies are inherited through the hierarchy, and the effective policy at each node of the hierarchy is the result of policies directly applied to the node and policies inherited from its ancestors. So this following diagram shows an example of resource hierarchy illustrating the core account level resources involved in administrating your Google Cloud account. So in this, you can see first is like domain. So your company domain is the primary identity of your organization that establishes your company's identity with Google services, including Google Cloud. to manage the users in your organization. At the domain level, you define which users should be associated with your organization when using Google Cloud. Domain is also where you can universally administer policy for your users and devices. For example, enable two-factor authentication, reset passwords for any users in your organization. The domain is linked to either a Google Workspace or Cloud Identity account. The Google Workspace or Cloud Entity account is associated with exactly one organization. You manage the domain level functionality using the Google Admin Console from like admin.google.com. Then the second thing is organization. An organization is the root node of the Google Cloud hierarchy of resources. All Google Cloud resources that belong to an organization are grouped under the organization node, allowing you to define settings, permissions, and policies for all projects, folders, resources, and cloud billing account parents. An organization is associated with exactly one domain established with either a Google Workspace or Cloud Identity account and is created automatically when you set up your domain in Google Cloud. Using an organization, you can centrally manage your Google Cloud resources and your users' access to those resources. This includes proactive management and reactive management. So, proactive management is to reorganize resources as needed. For example, like restructuring or spinning up of a new division may require new projects and folders. And reactive management is an organization resource that provides a safety net to regain access to lost resources. For example, if one of your team members loses their access or leaves the company. The various roles and resources that are related to Google Cloud, including the organization projects, folders, resources, and cloud billing accounts, are managed within the Google Cloud Console. Now, the third thing is folder. So, folders are a grouping mechanism and can contain projects, other folders, or a combination of both. To use folders, you must have an organization node. Folders and projects are all mapped under the organization node. Folders can be used by group resources that share common identity and access management policies. While folder can contain multiple folders or resources, a given folder or resource can have exactly one parent. Then the fourth one is projects. So projects are required to use service level resources such as compute engine virtual machines, pub subtopics, cloud storage buckets, and so on. All service level resources are parented by projects, the base level organizing entity in Google Cloud. You can use projects to represent logical projects, teams, environments, or other collections that map to a business function or structure. Projects form the basis for enabling services, APIs, and IAM permissions. Any given resource can only exist in one project. And then we have resources. So Google Cloud service level resources are the fundamental components that make up all Google Cloud services such as compute engine, virtual machines, pub subtopics, cloud storage buckets, and so on. For billing and access control purposes, resources exist at the lowest level of a hierarchy that also includes projects and an organization. Then the last one is label. So labels help you categorize your Google Cloud resources such as compute engine instances. A label is a key value pair. You can attach labels to each resource, then filter the resources based on their labels. Labels are great for cost tracking at a granular level. Information about labels is forwarded to the billing system so you can analyze your charges by label. Now let's move on to understand Cloud Billing Account and Google's payment profile. So we will understand them simultaneously. Okay, so a cloud billing account is set up in Google Cloud and is used to define who pays for given set of Google Cloud resources and Google Map platform APIs. Access control to a cloud billing account is established by identity and access management rules. Then a cloud billing account is connected to a Google Payments profile. Your Google Payments profile includes a payment instrument to which costs are charged. So a cloud billing account is a cloud level resource managed in the cloud console, whereas Google Payments profile is a Google level resource managed at payments.google.com. A cloud billing account like tracks all the costs incurred by your Google Cloud usage. A cloud billing account can be linked to one or more projects, and projects usage is charged to the linked cloud billing account. Okay. Whereas Google Payments profile connects to all of your Google services such as Google Ads, Google Cloud, and iPhone services. A cloud billing account results in a single invoice per cloud billing account. Okay, and a Google Payments profile processes payments for all Google services, not just Google Cloud. A cloud billing account operates in a single currency and defines who pays for a given set of resources. A cloud billing account is connected to a Google Payments profile, which includes a payment illustrating defining how you pay for your charges. Google Payments profile, on the other side, stores information like name, address, and tax ID when required legally, and who is responsible for the profile. Also, it stores your various payment instruments like credit cards, debit card, bank accounts, and other payment methods you have used to buy through Google in the past. Also, Google Payments Profile functions as a document center where you can view invoices, payment history, and so on. Cloud Billing Account has like billing specific roles and permissions to control accesses and modifying billing related functions established by identity and access management roles. Whereas Google Payments Profile controls who can view and receive invoices for your various cloud billing accounts and products. Now let's understand the types of cloud billing accounts and profile. So there are two types of cloud billing accounts. First is self-serve account, so in which the payment instrument is a credit or debit card or ACH direct debit, depending on availability in each country or region. And in that, the costs are charged automatically to the payment instrument connected to the cloud billing account. You can sign up for self-serve accounts online. The documents generated for self-serve accounts include statements, payment receipts, and tax invoices and are accessible in the cloud console. And the second one is invoiced account, or you can say offline account. In this, the payment instruments can be checked or wire transfer. Invoices are sent by mail or electronically. Invoices are also accessible in the cloud console as are payment receipts. You must be eligible for invoiced billing. So for that, learn more about invoice billing eligibility. You can learn that from the documentation of a GCP billing on Google Cloud Platform documentation. Okay. Now coming to the types of Google Payments Profile. When you create your payments profile, you will be asked to specify the profile types. This information must be accurate for tax and identity verification. This setting can't be changed when you are setting up your payments profile. Make sure to choose the type that best fits how you plan to use your profile. There are two types of payments profile. One is individual and another is business. So in individual, you are using your account for your own personal payments. If you register your payments profile as an individual, then only you can manage the profile. You won't be able to add or remove users or change permissions on the profile. And in business payment profile, you are paying on behalf of a business, organization, or partnership or educational institution. You use Google Payment Center to play apps and games and Google services like Google Ads, Google Cloud, and Pi Phone services. A business profile allows you to add other users to the Google Payments profile you manage so that more than one person can access or manage a payments profile. All users added to a business profile can see the payment information on the profile. Now let's understand the charging cycle and billing context in GCP billing criteria. Okay. So first understand the charging cycle. So the charging cycle on your cloud billing account determines how and when you pay for your Google Cloud services and your use of Google Maps platform APIs. For self-serve cloud billing accounts, your Google Cloud costs are charged automatically in one or the two ways. You can see of like a monthly billing, which where costs are charged on a regular monthly cycle. And the second is the threshold billing, in which the costs are charged when your account has acquired a specific amount. For self-serve cloud billing accounts, your charging cycle is automatically assigned when you create the account. You do not get to choose your charging cycle and you cannot change the charging cycle. For invoice cloud billing accounts, you typically receive one invoice per month, and the amount of time you have to pay your invoice, means your payment terms, is determined by the agreement you made with the Google. Now let's understand the billing contacts. A cloud billing account includes one or more contacts that are defined on the Google Payments profile that is connected to the cloud billing account. These contacts are people who are designated to receive billing information specific to the payments instrument on file. For example, when a credit card needs to be updated. To access and manage this list of contacts, you can use the payments console or you can use the cloud console. Now understand the sub accounts under cloud billing accounts. So sub accounts are intended for resellers. If you are a reseller, you can use sub accounts to represent your customers' charges for the purpose of chargebacks. Cloud billing sub accounts allow you to group charges from projects together on a separate section of your invoice. A billing sub account is a cloud billing account that is owned by a reseller's parent cloud billing account. The usage charges for all billing sub accounts are paid for by the reseller's parent cloud billing account. Note that parent cloud billing account must be an invoiced billing. A sub account behaves like a cloud billing account in most ways. It can have projects linked to it. Cloud billing data exports can be configured on it, and it can have identity and access management rules defined on it. Any charges made to projects linked to the sub account or grouped and subtotaled on the invoice And the effect on resource management is that access control policy can be entirely segregated on the sub account to allow for customer separation and management. The Cloud Billing Account API provides the ability to create and manage sub accounts, use the API to connect to your existing systems, and provision new customers or chargeback groups programmatically. Now let's understand the relationships between organizations, projects, and cloud billing accounts and payments profile. There are two types of relationships that govern the interactions between organization, cloud billing accounts, and projects. That is ownership and payment linkage. So ownership refers to an identity and access management permission inheritance, and payment linkages define which cloud billing account pays for a given project. Ownership of a cloud billing account is limited to a single organization. Payment linkage of a project linked to a cloud billing account is not limited by organization ownership. It is possible for a cloud billing account to pay for projects that belong to an organization that is different from the organization that owns the cloud billing account. The following diagram you can see shows the relationship of ownership and payment linkages for a sample organization. In the diagram, the organization has ownership over projects 1, 2, and 3, meaning that it is the IAM permissions parent of the 3 projects. The cloud billing account is linked to project 1, 2, and 3, meaning it pays for costs incurred by the 3 projects. Note that although you can link cloud billing accounts to projects, cloud billing accounts are not parents of projects in an identity and access management sense, and therefore projects don't inherit permissions from the cloud billing account they are linked to. The cloud billing account is also linked to a Google Payments profile, which stores information like name, address, and payment methods. In this example, many users who are granted identity and access management billing roles in the organization also have those roles on the cloud billing account or the projects. Now that you have a theoretical understanding of billing criteria in Google Cloud Platform, let's now see how it's been done practically by trying our hands on it on Google Cloud Platform. You can just directly go to the Google Cloud console. So I already have my account login here. If you don't have an account on Google Cloud Platform, create one. It's a very good platform to have your account on. You will just ask for a little bit of information, including debit or credit card details, and it will just deduct a very small amount of money, 1 or 2 rupees. That's it, and that will also be refunded soon. And what you will get is by creating a Google Cloud Platform account, you will get 90 days free trial in which you will get $300 of free credit, and you can use that for certain demos of like BigQuery or Bigtable, or you can say of Compute Engine virtual machine instances, launching any kind of service you can use using those free credits. Okay, so this is the project I can show you. Like you can go here and create a project. Okay, or you can I have like certain projects here, but I will create one more new project. Okay, so that I can show you how billing can be linked to this project. So I will just make the project is getting created. You can see the project name. Okay, this is the older one, so we will just open the new one, demo billing. Yeah, so now you can see the project name here, project ID is being shown, and project number, everything is here. But right now the billing account is not been linked to it, so we can just go here and open billing from here. So we can manage from here. What you can do is you can create a new billing account also. Like for this, we can say right now it's because it's been linked, because there is a limit of 3. Like if you are making projects, so only 3 accounts can be linked to a billing account. And right now, before making this project, I only had 1 account linked to it. So I just created another and it got automatically linked to it. Okay, so it just got linked, and means it got it linked by itself. But you can if it don't get linked, you can, if you open this from like billing section, when you open now, from there only you can link the account. Like manage billing accounts is there. You can go here, and if you don't have a billing account, you can create one billing account from here, and then the account will be appropriated to it. The billing account will be attached to your project. Okay, so we can see there is one active billing account, and if we close the active, then there are 2 accounts. This is the free tier account. Actually my free tier is over, so it's closed now. That is my billing account, that is the free tier account, and right now we are accessing is my billing account 1. Okay, so that's how it's get linked. And then what you can see here, it's showing the billing account, my billing account 1 we are accessing right now. Now what we can do is we can set the budgets and alerts for it. So we can just go to budgets and alerts. Right now the budget is being created. For that we can delete this one. This is the older one, so we will just delete this one, and we can create budget. So all you have to do is give a name. So we can say like custom billing. Okay, and you can like select for which you want to give. Like there are two projects are there, demo or demo billing, but we have to choose a demo billing, so we are just going to choose demo billing, or we can choose all of them also. It's up to us. And then we can go for all services. You can choose a specific service also, or you can choose all of them. So right now I'm choosing all of them. Yeah, and I've chosen all of them, and then I'm just right now unchecking it, just because we want to see the price like without our discounts and promotion applied to it. So we can just go to next then there are like two options here. You can see amount, like if you want to give the last month's spend, whatever you have spent last month, that will be applied here, or you can just choose a specific amount. So I will just choose a specific amount for it, like I can give 1,000. Okay, and the maximum amount I'm going to choose, and that's 1,000. Now you can see you can like put a threshold over it. If the Google will notify you, it will mail you or something, so that you get the alert that 50% of your budget is being spent, or 90% of your budget is spent, or 100% of your budget is spent. Okay, and from like this is the amount, on that basis only it's showing. Okay, so we can also go for actual or forecasted. So actual is like, okay, when it gets spent, I mean. Okay, and forecasted mean when it will forecast that in how much time or in how much period of time it will get spent. It will notify you. Right now we are choosing actual, and you can like create another threshold if you want to. Like I can give at 1% also. So 1%, that will be 10 rupees. After 10 rupees will be spent, it will notify us, I mean, that this much amount is being spent. Okay, and you can like email alerts. Okay, it will email, so you can choose this so that you can get the email for threshold. Okay, and you can just finish it. So custom billing has been made, and 0 credits are being used out of 1,000. That has been done. Then what we can do is go for billing export. How you want to get it export to your BigQuery. Okay, you can like export your billing, whatever your billing amount and every information regarding billing, that will be exported to your BigQuery. It's enabled actually, but it is enabled for demo, right? It's not enabled for our demo billing project. So what we can do is we can edit settings. We want to make it for demo billing, but right now we don't have a data set. So create new data set we can do. This is getting created in BigQuery, under BigQuery only. This data set is getting created. So demo bill underscore BQ we can give BigQuery. So data location default we can give, that's not a problem. So whichever location you want to choose, and enable table expiration. Like this is a very cool option. Like whatever data you are like getting saved in your table now under dataset, so for how many days should it retain. So you can give the number of days you want to retain, or if you don't want to delete it. So like just for a second you can understand, like you can give here 10 days. So if you give here 10 days, after 10 days only all the data under table will get deleted, even the table will get deleted. So in that sense you can just give the days here, or you can just remove it so that don't expires. Okay, so you can just create data set. Okay, must contain only letters. Okay, so demo bill BQ is okay. You can just create data set now. So data set is being created, demo bill BQ we can choose, and then we can save it. So BigQuery export is being getting created, and then we can like also enable it for pricing also. So we can just go to edit settings, and we can choose our project, that is demo billing and demo bill BQ. So we have to enable the data transfer API in BigQuery. So we can just enable it. So we can just now go back to the billing, and then we can go back to the billing export, and now we can do this. As the data transfer API is being activated, now we can go for demo billing, and we can choose the demo billing IQ and save it. Okay, so the pricing is being enabled for demo billing, and also the daily cost detail is also been enabled, and that will be saved in your BigQuery dataset under the table. Okay, whatever table it's been getting created under that BigQuery, so that will be there. You can see it in BigQuery also, like just go here, BigQuery. You can see the demo bill IQ, you can see dataset. So in this the table will be created. Right now it's not getting created, but means when the data will be exported, at that time the table will be created, and the data will be saved here. So this has been showing in the BigQuery. Okay, and we can go back here, and now the last feature, that this is the main thing, that is cost table. You can come to cost table. It will show you about the cost of the resources you have used. So for this, like right now, I haven't made any resources in this billing account. What we can do is we can go to the that I have told you, like I have that free tier account. So we can go to that account. We can choose that account. Like if we can remove, we can go to the older account, that is closed one, but we can choose this one. So we can just go to my billing account, this, and now we can go to cost table. So here I have all the invoices for it because I have used resources in this. So we can choose this project. Okay, we will open this project demo. Now all the cost and everything which has been charged for this project is just showing here, cost, credit, and everything, because this was a free tier account. So all of whatever is charged, it been reimbursed at the same time. Okay, so you can choose for like compute engine. Every resource has been elongated here. So okay, we can just minimize it, recover it, I mean. So in demo we have a compute engine. So in compute engine we can see, like I have launched the instance N1 predefined instance core for Americas and everything, however it has been given. So you can see the prices for it, like the cost 4297. The virtual machine instance which I have launched, it is showing the cost 4297. But we can check it from pricing calculator also, like how much does it cost. Open from pricing calculator from here. So just open pricing calculator, okay, and we can just check for instance, for compute engine instance, like how much does it cost. I might have ran that for around a month, actually 20 days or a month. So you can just compute engine and instances we are seeing. So number of instances we can say like 2 instances, but we can okay check for one only. So yeah, all these things are okay, no problem. That's machine type standard only might have I have chosen. So I had to estimate. So estimate cost it's showing is $48.92 per month. So that will come around like 4,000 5,000 only. So that's how I've been charged for it. Similarly, if you can see, like there is an N1 predefined instance core and N1 predefined instance core running in Americas, everything like how it has been charged 163. I have other instance that might be. Then there is a RAM running, so for that also it been costed around 2147. That also you can check in pricing calculator only. So instances, okay, it will come in instances only, RAM and everything. So because it's a instance core instance RAM. So and then we can see for E2 instance core how it costed 756 rupees. For everything you can see like the cost is given for every resource. Similarly, we can come for the app engine also. Just a second. What I can do is I can minimize it from here, compute engine. So now there is app engine. You can see similarly for the prices for it. The flex instance core hours Mumbai. In Mumbai I have launched it, so for Mumbai region, so it's costed 2089, and flex instance RAM in Mumbai it costed 277. Similarly, you can see it for Cloud SQL also. These are the prices, and for those prices you can choose the if you think it's really high, so you can check it for here, like what's the average price for the resource you are going to launch. Okay, for whatever you are like using, the resource you are using. So now you have understood like how it is costing, and if it is not similar to the cost it has been showing in pricing calculator, then you can redefine it and make it more efficient by understanding the costs and everything. So that's how the GCP billing prices works. Let us now see the reasons why one should consider Terraform. So Terraform lets you define infrastructure in configuration code and will enable you to rebuild and track changes to infrastructure with ease. So Terraform provides a high level description of infrastructure, which means it's infrastructure descriptive. Second, it has a lively community and is open source. There is a massive community developing around this tool. Many people are already using it, and it's easier to find people who know how to use it, like plugins, extensions, professional support, etc. This also means Terraform is evolving at a much faster rate. They do releases very often. So third is like speedy operations. So Terraform's speed and operations are like exceptional. One cool thing about Terraform is its plan command lets you see what changes you are about to apply before you apply them. Code reuse features and Terraform tends to make most changes faster than similar tools like CloudFormation. Also, it is like the right tool for infrastructure management, as many other tools have a severe impedance mismatch from trying to wrangle an API designed for configuring management to control an infrastructure environment. Instead, Terraform matches correctly with what you want to do. The API aligns with the way you think about infrastructure. Also, like Terraform is the only sophisticated tool that is completely platform agnostic as well as supports other services, while there are a few alternatives, but they are focused on a single cloud provider. There's a declarative code. So Terraform enables you to implement all kinds of coding principles like having your code in source control, the ability to write automated tests, etc. Now that we have understood why one must choose Terraform, now let's briefly understand what Terraform actually is. Terraform is a configuration orchestration tool designed to provision the servers themselves. It refers to arrangement and coordination of automated tasks resulting in a consolidated process or workflow. So it is also an like open source tool, means open source software tool created by HashiCorp. So HashiCorp created Terraform to manage present as well as popular service along with the custom in-house solutions. So Terraform lets you provision Google Cloud resources with declarative configuration files, resources such as virtual machines, containers, storage, and networking. Terraform's infrastructure as a code, that is, IAC approach, supports DevOps best practices for change management, which lets you manage Terraform configuration files in source control to maintain an ideal provisioning state for testing and production environments. Terraform manages external resources with providers, external resources like public cloud infrastructure, private cloud infrastructure, network appliances, software as a service, and platform as a service. HashiCorp maintains an extensive list of official providers and can also integrate with community developed providers. Users can interact with Terraform providers by declaring resources or by calling data sources. Rather than using imperative commands to provision resources, Terraform uses declarative configuration to describe the desired final state. Now let's look at some tools for using Terraform with Google Cloud. We will briefly understand these tools. So there are like variety of tools you can use to optimize your Terraform experience. So first, let's explore the Cloud Foundation Toolkit, which provides a series of reference modules for Terraform. The modules reflect Google Cloud best practices, and using these modules help you get started with Terraform more quickly. The modules are documented in the Terraform registry and open sourced on GitHub. So these are some of the features of Cloud Foundation Toolkit. So first is ready-made templates. So the Cloud Foundation Toolkit provides a series of reference templates for Deployment Manager and Terraform, which reflect Google Cloud best practices. These templates can be used off the shelf to quickly build a repeatable enterprise-ready foundation in Google Cloud. This frees you to focus on deploying your applications in this baseline secure environment, and with infrastructure as a code, you can easily update the foundation as your needs change. Second, like you can treat your infrastructure like software. So through the open source templates, you can automate repeatable tasks and provision entire environments in a consistent fashion. Plus, your teams can collaborate on the infrastructure by participating in code reviews and suggesting source code changes. Third, it's like built for enterprise. So the Cloud Foundation Toolkit is designed especially to meet the compliance and security needs of enterprises. By creating a foundational environment using these templates, you can be confident that best practices are implemented out of the box, including key security and governance controls. Also, you can like maintain consistency easily. By adopting the toolkit, you can be confident that different teams are deploying their applications and environments using a consistent set of tools and patterns. This reduces the potential for misconfigurations and inconsistencies while allowing easier collaboration across different teams. Also, you can choose your adoption strategy. Each template from the Cloud Foundation Toolkit can be used independently. You can choose which patterns make sense for your organization and add new ones as your environment evolves. The open source templates can easily be forked and modified to suit your organization's needs. Lastly, you can save time and resources with pre-built templates. With the Cloud Foundation Toolkit, you don't need to spend time developing your own templates and patterns for Google Cloud. Instead, you can build an open source templates and focus only on the customizations which are required to your company and workloads. Developers can like move faster and migrations are less time consuming because of it. So the second tool is Terraform Validator. So leverage Terraform Validator to enforce policies on Terraform configurations for Google Cloud. So Terraform Validator is a tool for validating compliance with organizational policies prior to applying Terraform plan. It can be used either as a standalone tool or in conjugation with Forseti or other policy enforcement tooling. Terraform Validator relies on policies that are compatible with Config Validator. Note that using Terraform Validator does not require an active installation of Forseti. Terraform Validator is a self-contained binary. So you can see the Forseti config validator shown here, which is the newest addition to the Forseti security toolkit. So Config Validator helps cloud admins put guardrails in place to protect against misconfigurations in Google Cloud Platform environments. This allows developers to move quickly and give security and governance teams the ability to enforce security at scale. So how does a Terraform validator works? So cloud admins write security and governance constraints as YAML files once and store them within their company's dedicated Git repo as a central source of truth. Then Faucety ingests constraints and uses them as a new scanner to monitor for violations. Then Terraform Validator reads the same constraints to check for violations before provisioning in order to help prevent misconfigurations from happening. That's how the whole process of Terraform Validator works. The next tool we have is Terraformer. So by importing existing Google Cloud resources into Terraform with Terraformer, it is a command line interface tool that generates TF or JSON and TF state files. Terraform already has existing resources in your environment, performing the reverse of what Terraform is designed to do. This tool can be thought of as infrastructure to code. Next, and the last tool is a Cloud Shell. So Terraform is integrated with Cloud Shell, and Cloud Shell automatically authenticates Terraform, letting you get started with less setup. Using Cloud Shell, you can manage your infrastructure and develop your applications from any browser. Cloud Shell is an online development and operations environment accessible anywhere with your browser. You can manage your resources with its online terminal preloaded with utilities such as the G-Cloud command line tool. You can also develop, build, debug, and deploy your cloud-based apps using the online Cloud Shell editor. So some of the features of Cloud Shell are like full power access from anywhere. You can manage your Google Cloud resources with the flexibility of a Linux shell. Cloud Shell provides command line access to a virtual machine instance in a terminal window. Then it has a developer ready environment, so you can develop your apps directly from your browser with the Cloud Shell editor. Is streamlined to increase your productivity with features such as Go, Java, Node.js, Python, and C language support. An integrated debugger, source control, refactoring, and a customizable interface. Run your app on the Cloud Shell virtual machine or in the Minikube Kubernetes emulator. Preview it directly in your browser, then commit changes back to your repo from your Git clients. Then the next feature is like your favorite tools pre-installed and up to date. So many of your favorite command line tools from Bash and SH to Emacs and Vim are already pre-installed and kept up to date with Cloud Shell. Admin and development tools such as command line tool, MySQL, Kubernetes, Docker, Minikube are configured and ready to use. No more hunting around for how to install the latest version and all its dependencies. Just connect to Cloud Shell and go. So the last feature is cloud code tools for maximizing development productivity. With this, you can easily develop cloud-based applications with the tools provided by our cloud code extensions, allowing you to develop and deploy your Kubernetes and cloud run applications, manage your clusters, and integrate Google Cloud APIs into your project, all directly from the Cloud Shell editor. So now let's understand like the support that Terraform provides for GCP. The core Terraform command line interface is developed by HashiCorp. Use the following resources for support, like for provider related issues, open an issue on GitHub. For questions about Terraform in general and common patterns, check the HashiCorp community portal. For general troubleshooting advice, see Terraform's debugging documentation and join in the Google Cloud Community Slack Terraform channel. If you haven't already, you can like register for the Google Cloud Community Slack. Now that you have a theoretical understanding of Terraform with GCP, let's demonstrate it practically with an example of launching a virtual machine instance in GCP through Terraform. So the first step is to download the Google Cloud SDK installer. So just search out Google Cloud SDK. So go here. So you can just directly go to the install section here. Yeah. So yeah, here like if you have a Linux OS, you can go to Linux and follow the steps to download, or you can go for Mac OS also. Because I have Windows, so I will start download directly from here. So I got it downloaded. Okay, open. Takes a few seconds. Yeah. Let's go next. So I already have a SDK installed, so I don't have to continue. But if you don't have SDK installed, so do continue, like get the installation complete. So yeah, the next step is to download your Terraform. So you can just directly go to releases.hashicorp.com/terraform. So HashiCorp, as I've told you, is the company that created Terraform. So from here, like all the versions are given, a lot of versions are there. So you can just go and download one. Yeah. If you have a Linux OS, you can just copy the address from here and unzip it. Okay, that's what you have to do. So if you're a Windows user, you can just download it from here. Yeah, it got downloaded twice, so you can delete this one. Yeah, so you can just extract it from here. Yeah, you got it. Just copy it and paste it somewhere where you are going to like place other files like separately. Like I have a different place to copy, so I will just go to my section, like not here, just a second. Okay, I will just go to my place, like because I am going to provide the path also. I will keep that in mind to place it separately. The demo section in the Terraform. Yeah, like this one I have got it before, so I will delete this one and I will paste the new one. Yeah, and I will name it as Terraform only. So the next step is to go to the build infrastructure. So here, go to the HashiCorp website. From here, you will go to the tutorial section of the Google Cloud. Okay, the prerequisites are given, like you have to create the account on Google Cloud Platform. So if you don't have an account, create one. It's a very good platform to have your account on, and it provides a free trial, like it's given the free trial. So free trial account is provided for 90 days with $300 credits. And when you're going to register it, it'll ask for your debit or credit card details, and it will just debit 1 rupee, and that will also be refunded very soon. Also, like $300 credit is provided, so that is like a lot of credits. Even means the exercise which I'm going to provide you, it's like it doesn't cost anything. It will only cut around $15-20, not more than that, or maybe maximum $50. That's it. So that's how you can use it. So next, CloudShare I've already explained you how it works and what are its features. Then is set up the GCP. So what you have to do in the GCP is you have to create a project, then you have to create a service account, and you have to generate a key. Okay, so let's go to the GCP console. So this is how the GCP console, like Google Cloud Platforms console, looks like. Okay, from here you go here and create a project. So you can create a project from here, but I already like created the project. My project name is demo, so I will use this project only. So now what I have to do is I have to make a service account. So I will type service account, and yeah, this is the default one, and this is the one I have created recently. So I will create a new one with the name TF demo. For service account, we will name it as SA. Okay, so create and continue. Now for access purpose, you have to give the role. So like different access options are provided for, like different services are here. You can provide like for a specific service, you can provide the access like App Engine or AI notebooks and everything, Auto ML, CA service, Cloud Asset, Cloud Data Labeling. For a specific service, which for whatever purpose you want to give, you can give it specifically. For this service account, I want a complete access, so I will just go to the project, and in project, I will give the owners to get the complete access. So yeah, continue. Done. So yeah, the service account is created for TF demo SA. Okay. For the next step, you can go to the registry Terraform that I've already opened. Okay, in this way, you have to go to the getting started with Google Cloud Provider. You will get the code for here, the basic code for virtual machine launching the instance. It's simple. This one, and it's the basic code of Terraform. Okay, so if you're going to use AWS now, so in AWS you will just use, instead of Google, you will use AWS. That's it. All the things will be same. And similarly, the provider code is provided below. So just copy this code also and make a provider file. And for this, create a VM file. Like I have created one. So this is how I have copied it here. Like this is the VM, the basic codes, and then the provider code is provided here. So you can see in VM, like the credentials are given, project, and then region is given, everything. And similarly, like the provider in this, the name, like with the virtual machine instance that will be created now, that will be named by Flask VM, and whatever the ID, it will be there. So in that name, the virtual machine will be created. Similarly, machine type is given and zone is given. Also, one more thing. So I have to generate a key in this, like this I have created now. I have to generate the key. I have, like, remember I told you in this, like the third step is to create a service account key. So you can go here, like the service account we have created. In that we have to create a key. So manage keys and add key, create new. So in JSON file will be created from here. So yeah, got created. So we can just go to downloads. Yeah. So it is here. So we can just copy here and you will just paste it where we have all the Terraform files, and name it as tf underscore authorization underscore, sorry, tf underscore demo underscore authorization This is what I have named in the code also. That's why I'm naming this. So yeah, tf underscore demo underscore authorizer.json. So that's what it is. Same. So coming back. So yeah, all the codes and everything is done. So now what we have to do is take that. So it's the key is active now, you can see. So what we have to do is now open the command prompt. You just have to provide the path first. So the path is cd demo / terraform. So yeah, the path is here. Then we have to revoke the authorization. So gcloud authorization purpose for gcloud authorization revoke. One more thing I will show you, the JSON file. If you see, everything is given like privately. For project ID is given private, key ID is also given. From the name the virtual machine will be launched, the key will be given this Flask ID and the key. Then private key is given, then client email, client ID, authorization token, everything is given in this. Okay, so we got this authorization revoke, credentials are here. So after that we have to configure. So gcloud config configurations list. So yeah, though everything is right in my account, but if you want to change, so what you can do is you can initialize this. So first clear this one. So you can initialize it for changing anything in your configuration list. Okay, so gcloud, oh sorry, gcloud initialize init. So yeah, for reinitialize, give the one choice number, numeric number one. It's been done. Then would you like to log in? Yes, I want to log in. Just have to log in from here. Allow, and it's authenticated. It will be done now. So you can just come back. You can choose the project from here. So your project name is, if you remember, it's Chrome Sensor 313404. Okay, so it is Chrome Sensor. So it's second, and I think then yeah, the zone and region we have to select. So yeah, we want to select. So my region is South Asia. Yeah, so I will select 37 South Asia 1A. So yeah, everything is done now. So we can just again configure now. So yeah, everything is at place. Account, yeah. So last time if you see, like I was saying, like everything is right, but it last time also like everything wasn't right, because in the place of account now my account wasn't selected, so it wouldn't have worked. Do check it properly. Then just clear this. Then let's start with the Terraform initialization. Terraform init. We have to go with, I think, yeah, it's getting initializing. So yeah, it's got initialized, and we go with plan. So Terraform, sorry, can stop initialize. I have already initialized that, sorry. So Terraform plan now. So yeah, so it will be like create. So if you like got done, but you can go, so you can see like Google Compute instance will be created now. Okay, so what we have to do is we just have to apply. So here the command is terraform apply. Only yes will be accepted. So yeah, yes, yeah. So it's got created. So let's check. Let's go to the virtual machine instance. Pure engine, virtual machine instances. The Flask will be created with the name Flask, or some ID will be given again. Flask VM ID something. I hope it get created. It will be created because it's showing, so of course it got created. Yeah, Flask VM in the private ID. So yeah, that's how it got created. And if you want to delete it, you can just give the command of destroy. Okay, so you can just come here. You can give terraform destroy. Only yes is accepted. So yes, it takes a few seconds. So yeah, so it got destroyed. Let's check. Now it is here. So we will just refresh it. We will find that it will get deleted from here. Yeah, so it got deleted. What is a project in Google Cloud Platform? So a project in a Google Cloud Platform organizes all your resources. A project consists of a set of users, a set of APIs, and billing, authentication, and monitoring settings for those APIs. Like for example, all of your cloud storage buckets and objects along with user permissions for accessing them reside in a project. Let's now understand how to create and manage projects in Google Cloud Platform. Before we begin, keep in mind that in order to interact with Google Cloud resources, you must provide the identifying project information for every request. So the following are used to identify your project. First is a project name, which is a human readable name for your project. The project name isn't used by any Google APIs. You can edit the project name at any time during or after project creation. Project names do not need to be unique. Now the next one is a project ID, which is a customizable unique identifier for your project. So you can see this in the project name. My sample project is given, which is the project name. Then the second thing is project ID, which is a customizable unique identifier for your project. The project ID is a unique user assigned ID that can be used by Google APIs. If you do not specify a project ID during project creation, a project ID is assigned automatically. The project ID must be a unique string of 6 to 30 lowercase letters, digits, or hyphens. It must start with a letter and cannot have a trailing hyphen. You cannot change a project ID once it has been created. Cannot reuse a project ID that is in use or one that has been used for a deleted project. Some words are restricted from use in project IDs. If you see restricted words in the project name, such as Google or SSL, the generated project ID excludes these words. Now, the last one is a project number, which is an automatically generated unique identifier for your project. The project number and project ID are unique across Google Cloud. If another user owns a project ID for their project, you won't be able to use the same project ID. You can't reuse the project ID of a deleted project as well. So when you choose your project ID, don't include any sensitive information in your names. Like you can see here, the project ID is given as a my sample project 191923 and project number. This is just a for example I showed you project number that is also automatically assigned. Now let's get started with understanding how to create a project. This permission is included in the project creator, resource manager project creator role, which is granted by default to the entire domain of a new organization and to free trial users as well. If you do not specify the parent resource, a parent resource is selected automatically based on the user account's domain. You can create a new project using the Cloud Console, the Google Cloud command line tool, or the project create method also as well. So to create a new project, do follow these steps. Like go to the manage resource page in the Google Cloud Console. On the select organization drop down list at the top of the page, select the organization in which you want to create a project. If you are a free trial user, skip this step as this list does not appear. Then click create project. In the new project window that appears, enter a project name and select billing account as applicable. A project name can contain exclamation points and must be between 4 and 30 characters. Then enter the parent organization or folder in the location box. That resource will be the hierarchical parent of the new project. When you have finished entering new project details, click create. Also, you can create a project using a service account. You can use a service account to automate project creation, like user accounts, service accounts can be granted permission to create projects within an organization. And service accounts are not allowed to create projects outside of an organization and must specify parent resource when creating a project. Service accounts can create a new project using the gcloud tool or the projects.create method. So now let's understand how to manage a project. So the first step is to manage project quotas. So if you have fewer than 30 projects remaining in your quota, notification displays the number of projects remaining in your quota on the new project page. Once you have reached your project limit, to create more projects, you must request a project limit increase. Alternatively, you can schedule some projects to be deleted after 30 days on the manage resource page. Projects that users have soft deleted count against your quota. So these projects get fully deleted after 30 days only. Now the second thing is identifying projects. So to interact with the Google Cloud resources, you must provide the identifying project information for your request. A project is identified by its project ID and project number. As I have already explained you what is project ID and project number and how to get them. Also, you can get an existing project. You just have to go to the project list and choose your existing project. Then you can also go for listing projects, which can be done in two ways. That is, list all projects under a resource or search for a project. For managing the project, the updating of the projects can also be done. Like you can update projects using the Cloud Console or the projects.patch method. Currently, the only fields that can be updated are the project name and labels. You cannot change the project ID value that you use with the Google Cloud command line tool or API requests. Next thing is shutting down, or you can say deleting the projects. So you can shut down projects using the Cloud Console or the projects.delete method. A project must have a lifecycle state of active to be shut down in the way. This method immediately marks a project to be deleted. A notification email will be sent to user who initiated the delete operation. In the technical category, contracts that are listed in essential contacts. Project that is marked for deletion is not usable. If the project has a billing account associated with it, that association is broken and isn't restrained if the project delete operation is cancelled. After approximately 30 days, the project is fully deleted. At the end of the 30-day period, the project and all of its resources are deleted and cannot be recovered. Until it is deleted, the project counts towards your project quota. If you have set up billing for a project, it might not be completely deleted until the current billing cycle ends and your account is successfully charged. The number and types of services in use can also affect when the system permanently deletes a project. If the process to shut down a project fails, you can go for troubleshooting project deletion. And the last thing in managing a project is restoring a project. Project owners can restore a deleted project within the 30-day recovery period that starts when the project is shut down. Restoring a project returns it to the state it was in before it was shut down. So some resources such as cloud storage or PubSub resources are deleted before the 30-day period ends and may not be fully recoverable. To restore a project using the Cloud Console, you just have to go to the Manage Resources in the Google Cloud Console, and in the project picker at the top of the page, select your organization. Below the list of organization folders and projects, click Resource Pending Deletion, and then check the box for the project you want to restore. Then click just Restore. In the dialog that appears, confirm that you want to restore the project. Now that we have understood how to manage and create a project, let's understand how we can provide access control for projects using identity and access management. So Google Cloud offers identity and access management, which lets you give more granular access to specific Google Cloud resources and prevents unwanted access to other resources. So IAM lets you adopt the security principle of least privilege, so you grant only the necessary access to your resources. IAM lets you control who has what access to which resources by setting IAM policy, which grants specific roles that contain certain permissions. So the first thing in access control is permissions and roles. So to control access to resources, Google Cloud requires that accounts making API requests have appropriate IAM roles. IAM roles include permissions that allow users to perform specific actions on Google Cloud resources. For example, the resource manager organizations list permission allows a user to list the organizations they own, while resource manager projects delete allow a user to delete a project. You don't directly give users permission. Instead, you grant them roles which have one or more permissions bundled with them. You grant these roles on a particular resource, but they also apply to all of that resource's descendants in the resource hierarchy. So let's understand it briefly. So first is permissions. So to manage projects, the caller must have a role that includes these following permissions. The role is granted on the organization or folder that contains the projects. So you can see the method and required permissions for it. You can see for create permission, there is a resource manager projects create. You can see all these same, but you can see the third last one, which is resource manager projects test IAM permissions. That doesn't require any permission. Then there are user predefined roles as well. So IAM predefined roles allow you to carefully manage the set of permissions that your users have access to. The following table lists the predefined roles that you can use to grant access to a project. Each role includes a description of what the role does and the permissions included in that role. So you can see the role and the name for it, then also the description, you can see for role name project creator. You can see that it provides access to create new projects. Once a user creates a project, they are automatically granted the owner role for that project. Then you can see the permissions for it, the specific permission for it, like resource manager organizations get to get the permissions. Similarly, for project deleter and project mover and project IAM admin, specific permissions are there, and you can see the descriptions also for it. And then there are basic roles. These roles are very powerful and include a large amount of permissions across all Google Cloud services. Like you can see for owner, editor, and viewer. These are if you see in resource hierarchy, they are the highest roles. You can see how for owner all permissions for all resources are given. Then for editor, create and update access for all resources. And then with the viewer role, you can get and list access for all resources. Also, can create custom roles. So in addition to the predefined roles described in the topic, you also create custom roles that are collections of permissions that you tailor to your needs. Then the second thing in access control at the project level. So you can grant roles to users at the project level using the Google Cloud Console, the Resource Manager API, and the Google Cloud Command Line tool. So there's a default role also, when you create a project, you are granted the owner role for the project to provide you full control as the creator. This default role can be changed as normal in an IAM policy as well. Then there are VPC service controls. So VPC service controls can provide like additional security when using the resource manager API. So VPC service controls improves your ability to mitigate the risk of data exfiltration from Google Cloud services such as cloud storage and BigQuery. You can use VPC service control to create parameters that protect the resources and data of services that you explicitly specify. Now let's move on to understand how to move a project within the resource hierarchy. So the project resource is the base level organizing entity in a Google Cloud organization. Projects are created under organizations and can be placed under folders of the organization resource itself, forming the resource hierarchy. You can move project resources within your resource hierarchy, but should consider the policy implications of the move before you make it. So when you move a project, any identity and access management policies or organization policies that are directly attached will move with it. However, a project in your resource hierarchy is also affected by the policies that it inherits from parent resources. So if a project inherits an IAM role that provides user permissions to use a particular service, users will not have access to that service at the destination unless it would inherit the permission at the destination as well. So like for example, consider a service account has the storage object creator role bound to a user or a folder. You can consider the folder as folder A. So the service account has permissions to upload data to cloud storage in any project in folder A. If you move one of these projects to folder B, which does not have the same inherited permission, the service account for that project loses the ability to upload data, resulting in a service outage. These same considerations apply if organization policies are defined at the source and destination folders. Like IAM policies, organization policies are inherited. Consequently, you must ensure that your organization policies are consistent between source and destination folders. To move a project, you need the following IAM roles, like having the resource manager.projects update permission on the project, which typically comes from having either the project editor or project owner roles on the project. So the second permission is have the resource manager project move permission on both the source folder and the destination folder. This permission is typically part of the project owner, project editor, or folder admin or folder mover roles. If the resource is not in a folder, you will need the permission on organization node. You can follow these steps to move a project. So in the Google Cloud Console, go to the manage resource page, select your organization from the organization drop down on the top left of the page. Third is the click on your projects row to select your project role from the list of resources. Note that you must not click on the name of the project, which takes you to the project's IAM page. Then next you have to click on the options menu in the row and click move. Then click browse to select the folder to which you want to move the project, and then finally click move. Now that you have understood how to move a project, let's now understand how to migrate a project between organizations. We will understand it quite briefly. So the project resource is the base level organizing entity in a Google Cloud organization. Projects are created under organizations and can be placed under folders or the organization resource itself. Forming the resource hierarchy, you may need to migrate projects between organizations due to acquisitions, regulatory requirements, and separation between business units, among other things. You can use the resource manager API to move projects across organizations or to another place in the resource hierarchy of its current organization. The resource manager API also lets you roll back the migration, moving the project back to its original place in the resource hierarchy. Note that it generally takes less than a minute for the project move to complete. After moving a project, it may take several minutes to reflect this change in the Google Cloud Console. So in migrating projects, first we need to create a migration plan. So the most important thing to consider during a project move is how the migration will impact the services running inside the project. The resource manager API treats the project resource and all services running underneath it as a single unit, meaning that no configuration changes will be applied inside the project. While migration will not make direct configuration changes to the project, the change in the resource hierarchy is likely to have an impact on the function of the project and its running services. Inherited policies such as identity and access management or organization policies will not move with the project during migration. While migration will not make direct configuration changes to the project, change in the resource hierarchy is likely to have an impact on the function of the project and its running services. So inherited policies such as identity and access management or organization policies will not move with the project during migration. Only policies and serve accounts that are attached directly to the resource. This may cause unintended behavior after the migration is complete. So the second thing in creating a migration plan is verification of policy. So when you migrate your project, it will no longer inherit the policies from its current place in the resource hierarchy and will be subject to the effective policy evaluation at its destination. So we recommend making sure that the effective policies at the project's destination match as much as possible the policies that the project had in its source location. So any policy that is applied directly to the project will still be attached after the migration is complete. So applying policies directly to the project is a good way to verify that the correct policies are applied from the moment the move is complete. Identity and access management policies and organization policies are inherited through the resource hierarchy and can block a service from functioning if not set properly. Determine the effective policy at the project's destination in your resource hierarchy to ensure the policy aligns with your governance objectives. So the third thing is manage encrypted keys. So you should verify if your project has a customer managed encrypted key or other cloud key management service enabled on it. Cryptographic keys are owned by the project, and a user with owner access to that project will therefore be able to manage and perform cryptographic operations on keys in Cloud KMS in that project, I mean. Now, the next thing is the preview features. So you can enable preview features on organizations, folders, or projects. If you have enabled an alpha or beta feature on the project to be moved, this feature should continue to function after the migration. If the preview feature is private and not listed for the destination organization, you will not be able to make any configuration changes after the move is complete. Now the next thing is the rollback plan. So if you discover that something is not working on any of the projects you have migrated, you can move them back to their original location. In order to do that, you need to have the necessary IAM permissions and set the required organization policies so that you can run the project migration in reverse. Now the last thing is the dedicated import and export folders. So policy inheritance can cause unintended effects when you are migrating a project both in the source and destination organizations. You can mitigate this risk by creating specific folders to hold any projects for export and import and ensuring that the same policies are inherited by the folders in both organizations. You can also set permissions on these folders that will be inherited to the projects moved within them, helping to accelerate the project migration process. When planning a migration, consider setting up a dedicated source folder first. To do this, create a folder for each organization to which you plan to export projects. Then set an organization policy on the folders, each with the constraints or resource manager allowed export destination constraint set to the single organization to which you want to export projects. After you have completed your project migration, you should remove these dedicated folders as well. So after creating a migration plan, assign permissions as well. Note that when assigning permissions related to a cross-organization migration, you must designate the roles on the same member email address in both the source and the destination organizations. You need the following permissions to move a project between organizations. To gain these permissions, ask your administrator to grant the suggested role at the appropriate level of the resource hierarchy. So the first is project move permission. So on the project resource that you want to move and its parent resource, you need the project mover role. Or another role that includes the following permissions are the V1 Resource Manager API. So the permissions required for the resource you are moving are like resource manager.projects.update. And for permission required for the parent resource will be resource manager.project.move. So on the destination resource, the permission you need to depend on the resource to which you are moving the project. If the destination resource is a folder, you need the project mover role or another role that includes the resource manager project move permission. If the destination resource is an organization, you need the project creator role or another role that includes the resource manager project create permission. Now the second thing is the organization policy permissions. So on the source and destination organizations, you must have the roles organization policy admin role, which grants permission to create and manage organization policies. Now, after assigning permissions, you need to configure organization policies as well. To move a project resource to a new organization, you must first apply an organization policy that will define the organization to which the project can be moved. You must also set an organization policy in the destination that defines the organizations from which projects can be imported. Note that if you do not set the following organization policies, the migration will result in a failed precondition error. On the parent resource to the project you want to move, set an organization policy that includes the constraints or like resource manager allowed import export destination constraint. This will define the target destination as a valid location to which you can migrate the project. On the destination resource, set an organization policy that includes the constraints like the resource manager allowed import sources constraint. This will define the source as a valid location from which you can migrate your project. So on the destination resource, set an organization policy that includes the constraints resource manager allowed import source constraint. This will define the source as a valid location from which you can migrate your project. Note that whether you are using dedicated import and export folders or not, it is a good practice to remove these organization policies after you are done moving projects across organizations. You can enforce them again if you need to perform another project migration. So the first thing while configuration organization policies is change the billing account for a project. So cloud billing account can be used across organizations. Moving a project from one organization to another won't impact billing, and charges will continue against the old billing account. However, organization moves often also include a requirement to move to a new billing account. To change the billing account for an existing project, you must have the owner role on the project and the billing admin role on the destination billing account. To change the billing account, go to the billing page in the Cloud console, click the name of the billing account you want to change, and under projects linked to this billing account, find the name of the project to move, and then click the menu button to the right. Then click change billing, and then select the new billing account, then click set account. Follow these steps and you can change the billing account for a project. Charges already incurred that have not yet been reported in the transaction history will be billed in the former billing account. This can include charges from up to 2 days prior to when the project was moved. Also, you can move a billing account between organizations. So a billing account can be moved from one organization to another, although this isn't often a necessary step. Most existing organizations will already have a billing account that should be used instead. If you need to migrate an existing billing account, get the billing admin role on the source and destination organizations. Then go to the billing page in the Cloud console. Click on the name of the billing account you want to move. At the top of the account management page, click change organization. Then select the destination organization and then click OK. The billing account is now associated with the specific organizations. Note, if you move a billing account that has active Google Cloud Marketplace subscriptions, those subscriptions are automatically cancelled. Then the last step in migrating a project is perform the migration, of course. So if you have the appropriate IAM permissions and the required organization policies are enforced, you can use the resource manager API to move a project resource. So the following instructions are only for migrating a project from one organization to another. Like to migrate a project under an organization, run the following command. This you can see like gcloud beta projects, this one. Then you can also specify a folder as the target resource with the following command. So where it will happen? So you need to understand the project ID for that. Like project ID is the ID or number of the project you wish to migrate. And then there's organization ID, which is the ID of the organization to which you want to move the project. You can only specify one target, either an organization or a folder. And then there is folder ID, which is the ID of the folder to which you want to move the project. You can only specify one target, either a folder or an organization. Also, you can roll back a migration. So if you have mistakenly moved a project, you can roll back the operation by performing the move again with the old source as the new destination and the old destination as the new source. You must have the necessary IAM permissions and organization policies enforced to allow this as if this were an entirely new migration. So now that you have a theoretical understanding of projects in GCP, let's now see how it's been made practically by trying our hands on it on Google Cloud Platform. You can just directly go to Google Cloud Platform console. So this is how the Google Cloud Platform console looks like. So if you don't have an account on Google Cloud Platform, create one. It's a very good platform to have an account on. While making the account, it will ask for your credit and debit card details. It will just deduct 1 rupee and that will also be refunded soon. So here you can see like the project name, project ID and project number is given. Dashboard only. That's how the dashboard looks like. So and you just have to go here. This is from here you can choose your project. Like I have created number of projects. You can also go and create a new project from here. Just give the project name. You can give it like my project test. So you can see the project ID is getting created with this, the name and then this number. It cannot be changed later. Okay. Then you can also choose your organization. If you are using a free account and you don't have an organization, then you can choose no organization also and create a billing account like this, or you can just simply choose the organization. I will choose it from here. So I will just create it. It will take a few minutes, few minutes, like 1 or 2 minutes. Yeah. So you can see like it got created. I will just select this project. So now you can see like the project name, my project test, project ID, and project number. Everything is given here. That's how easy it is to create a project in Google Cloud Platform. And by making this project, now you can use all its services. Like you can see, you have the access to use Compute Engine, Kubernetes Engine,
storage services also, database services also, application integration as well. All these services you can use. Once you create a project, under the project you get the access to use these services. If you want to delete the project, you can just go to this settings, go to the project settings. You can see, you can like choose the project name. This one only we have created, so we will just delete this project. We just have to shut down for that. We just have to type the name for it. So project ID with this. Okay, to shut down project. You just have to type the project ID. So this is the project ID. I'll just copy it from here, paste it here, and shut down. So as I've told you, like it takes at least 1 month to get the project shut down. So you can see today is like 22 July. So by 21st August, it will get shut down. That's how it's been shut down. Now you can see my project test is does not exist here anymore, right? So I hope you have understood how to create a project and how to delete the project in Google Cloud Platform. These are the concepts of Google Cloud Platform projects.
What is website hosting? Now, when we talk about website hosting, we can see that website hosting is basically an online service that allows you to publish your website on the internet. So anybody who has access to the internet has access to your website. And basically, in practice, it refers to the service you get from a web hosting provider. So a hosting provider is somebody who is a third party and basically helps you host your websites for you and maintains them, right? So hosts are responsible for maintaining the site. Next up, we talk about why host on Google Cloud, right? So there are various reasons why you should host on Google Cloud. There are various advantages as to why people use Google Cloud Platform for hosting. The first reason is the fact that it has a better pricing availability, right? So when it comes to better pricing availability, economically, Google Cloud hosting plans are much cheaper than the AWS or Azure hosting plans. Like Google Cloud Platform is definitely at least 5% cheaper than Azure and at least 8% cheaper than AWS hosting plans, right? So this better pricing plan is basically something that keeps Google Cloud Platform hosting services ahead, and it is billed per second. So that is why Google Cloud Platform is better pricing. Next up, we talk about the enhanced execution that Google Cloud Platform offers us. So when we talk about enhanced execution, we see that the enterprise level Google Cloud has enhanced the performance of its hosting services, right? So an individual can access the data from any location via remote or a big infrastructure, right? So that big infrastructure allows Google Cloud to basically execute various complex operations and enhance its own resources and services, right? Next up, we talk about the commitment to constant development. So when we talk about this, we talk about the fact that when Google is developing its infrastructure rapidly, right, that is according to its customers' requirements. So when in the near future we'll see that the customers' requirements has changed, it will be based on the Google infrastructure, based on new locations, right? So it's continuously evolving based on your requirements. Next up, we see that Google Cloud hosting is basically something where you can have redundant backups. Now, redundancy basically is something where you do not have an extra copy of certain data, right? So every data is unique to itself, right? So Google has its own built-in redundant backups, right? So if some component is not functioning, then Google will create a backup automatically because you are storing the data in different locations, right? So that is why there's a backup. Next up, we talk about the control and security that Google Cloud Platform hosting will provide us. This is because that Google has its own security model. So when it has its own security model, which is again used in other services provided by Google, such as Gmail, YouTube, and other such products, Google has recruited a large number of security professionals just to basically protect the data of the servers, right? So all the data on the Google Cloud Platform is encrypted. So it is extremely secure. And finally, we come to the fact that live migration of data is possible. So one of the top advantages of Google Cloud hosting is live migration, right? It is the biggest advantage because AWS and Azure both do not provide this benefit, right? So it only consists of migration of virtual machines when it comes to AWS. Next up, we talk about static website versus dynamic website. So when we talk about hosting in cloud, that is basically cloud hosting, which is one of the various kinds of hosting available, such as VPS hosting as well. So when it comes to cloud hosting, there are two kinds of websites that can be hosted, right? So one of the websites is a static website and the other is a dynamic website. So when it comes to static website, it is basically the same info displayed to every user that is there, while a dynamic website will be unique for each user. For example, your Gmail login page and your Gmail homepage will be different for every user because it's customized to you and you can customize it as well. Whereas a basic HTML hello world page will be the same for everybody, and that is an example of a static web page. Next up, we talk about the fact that static web page does not have any servers that are used, right? So it consists of basic HTML pages which can be stored in buckets, and these buckets can then be hosted on Google Cloud using the endpoints, right? Whereas dynamic websites need server-based technologies like PHP, and that is basically something that is necessary for deployment. Web apps are used for the deployment of dynamic websites. So these are the two different kinds of websites that are present when it comes to hosting. Next up, we have a demo on basically how to host a static and a dynamic website on Google Cloud Platform. So once you've basically logged into your Google Cloud Platform console, you can go to Compute Engine and go to VM instances. We're going to basically talk about how to host a dynamic website on Google Cloud Platform. So the first thing you need to do for this is create your own project, and in that project you'll have to go to Compute Engine and then create an instance. Make sure that you have a service account as well, but in this demo we'll be using the default service account that's there. So let's get started. So let's see, there's an instance name here and it's named as instance 3, so we can keep that as is. And on the right hand side, you can see that the pricing for the estimate pricing for our machine is given, right? So the pricing depends on the amount of resources you use, the kind of machines you use. And what you have to do here is just get it, change it to N1. So when you change it to N1, you can see that the price has just reduced, or it's the same, because you don't need a lot of users to be logging into your EM instance right now. It's just you. So you'll be the one logging in, so you don't need a very powerful machine. That's N1. And what you have to do here is to platform GPU, configure all this. It's done. And come here and change the boot disk. Now you can keep it as you wish. You can keep it as Debian as well if you want. I'll be keeping it to Ubuntu and changing my space to 20 GB. That is changing my boot disk. And after that, you'll have to allow HTTP and HTTPS traffic because you need public access for your website. So when you basically go onto the internet, you want your website to be shown, right? So after this, what you have to do is basically go to security, and here what you have to do is manage your access for the VM, right? So for this, what we need to do is create a public key, and you'll have to add the public key separately, and for that we'll be using puttygen. Generate your key, save it as private key, right? So you'll have to make a passphrase, and that passphrase is for basic authentication and improving the security, right? So you can keep this passphrase whatever you want to and save it as a private key. So let's just name this private and .ppk, save that. And after this, what you need to do is load this, go to private and open this up. Open up your with your passphrase, and you'll have your public key that you can copy. You can just copy this and we can now go back here and paste this here, and after this just create the instance. Right, so your instance is now created. What you need to do now is connect to the SSH and open in a browser window. Once connection to your SSH has been established, type in sudo su and you can just go in there and cd and just type apt get. Right, so this is what you have to write. And you can see your Apache 2 is being installed. Now, Apache 2 is basically going to be the server, and just type in Y. Right, so this is now done. So what we can do is just check if our Apache is running. For that, we just have to do this. As you can see, basically this is running. So basically what you have to do now is go back in here, type in ls, and then add HTML here. If you go into the directory, you can see there's an index.html page. Now, when we talk about the index.html page, what we have done here is the index.html page is supposed to be the Apache server page, but we need to host our own website, right? Or our own dynamic website. So what we've done here is had our own index.html web page, which is going to replace the Apache server web page, right? So let's try that out. Go into ls, right? Do backslash and index.html, right? So now you're in here, and basically what you have to do after this is vi index.html, the index.html page. You take this code in and you change it in the index.html, and let's now go back and copy this, and once you're done copying, just go back to your incognito. So you can see Apache server default page, right? So you can see that this page has basically been activated and it's running. What you need to do is change this. This is your code. This is the web page with which you'll change this page, right? So basically what you have to do is go back into your SSH and into your index.html, which is basically just, right? So you can just go back to, so basically you can see that HTML is already a directory, right? So you'll just have to vi into the index.html, right? Take your code here, copy it, and add in here. So right now you have your code, and it's changed from the Apache page to your very own web page, right?
So you can basically go back using the command :wq.
So now when you refresh this, let's just try refreshing this. It's still the same. And let's go back to our right. So copy this up, paste this, add it, and so what you have to do here is starting from change the HTML code. So now that you've changed the HTML code, what you need to do is move it into somewhere else. Let's try this mv index.html index1 html. So now let's try it out. Go back here, this and this, paste this, And basically what you'll see is that you have your own web page in here which you've replaced with the Apache web page, and that is because you went into the SSH,
changed the code in index.html and moved it from index to index1.html.
So that is basically how you host a dynamic website using servers and in VMs on Google Cloud Platform. There's another way you can host dynamic websites on Google Cloud Platform, but that is through App Engine.
If you would like us to make a video on Google Cloud App Engine, please do let us know in the comments below.
And now let's go back and check out what it's like to host a static website, right? So when you create a static website, you need buckets. And what you need to do is just go to cloud storage.
So when you're talking about hosting a static web page, you basically need only a storage service because you're going to basically get the HTML code in these storage buckets.
And these buckets have then got a URL which is publicly accessible, and you'll have hosted a static web page. So let's get started. We'll try and create a bucket. Try and name it anything we want. Let's say bucket 1997, right? Continue. Okay, so this is taken. So let's try this out, right? So we want it to be multi-regional because it will be publicly accessible, right? So this is going to be multi-regional and US, multiple regions in the United States, right? So you can change it to Europe if you want. Let's go to continue again.
You get to choose your default storage class for your data, and these are divided into standard, nearline, code line, and archive. Standard being the most short term, and archive being the most long term.
And then let's go to continue. So what we want to do here is we don't want to prevent public access, right? So we'll not tick on this. What we'll do is give it to fine grained where we'll have ACL permissions and go to continue. And what we'll do here is have none of the protection tools, but we'll have none of the protection tools.
And right after that, we'll basically create our bucket.
Right. So our bucket is created. Now what we need to do is
Upload our HTML pages in the bucket.
on this bucket. Let's do this. There's an error file I have and there's an index.html file I have. Let's upload both of these. So we've uploaded both these files. So basically what we have to do now after we've created the bucket is change its permissions and allow public access. So once you basically made the bucket, you have to change the configurations. That is basically edit website configuration, and you'll have to add your index.html and error.html and save it, right? So right after you've done that, what the last thing you need to do is you have to edit the access. Now when you're editing the access, you need to public access is subject to ACLs. Now what we'll have to do is add a new principal, and here we'll have to select all users, right? And here we'll have to select a role which is the object view storage object viewer, which basically gives you the view access to the website only, and you have to save that. So basically this is asking if you want to make it public. So we just have to update this, and now our bucket has public access. Let's just check. Right, so there is public access to the internet, right? So now that we have public access to the internet, let's just go check out our URL. So enter your bucket, copy the URL and paste it in here. So as you can see, our index.html page has been hosted on this endpoint, which is basically googleapis.com with this bucket name index.html. And that is how you host a static website on Google Cloud platforms. About is the use case. So when it comes to the use case, we're going to talk about one very popular use case, which is the Cloudways use case. So Cloudways is basically in partnership with Google Cloud Platform, and
What happened is the price performance balance.
for the virtual machines, cloud computing engines, automatic compute engines, automating compute engines, internal processes.
So Cloudways in collaboration with GCP has improved, in fact, a lot of Google Cloud Platform's already existing services, such as the Kubernetes engine, the compute engine, and other such performance ratios.
And this basically increases a lot of cost efficiency and productivity, right? So this is how hosting using Google Cloud Platform has made Cloudways much more scalable and cost effective.
What is WordPress? WordPress is a web publishing software you can use to create a website or a blog. Technically, it could be defined as a free and open source content managing system written in PHP and paired with MySQL or MariaDB database. It can be used to not only create blogs and website, but can also be used to create directory, forums, galleries, business website, online e-commerce website, and many more. It is the most popular website building platform in the world. Just to give you an idea about how popular WordPress is, WordPress powers about 35% of all internet websites. Bloggers, small businesses, and Fortune 500 companies use WordPress than all the options combined. Now, you do not need any coding knowledge to use WordPress. It enables you to build and manage your own full-featured website only by using your web browsers. Now, what makes WordPress so famous? To answer this, let us look at some of its features. The first feature is it is simple and easy to use. Creating content with WordPress is as simple as creating and using MS Word document. You can create posts and pages, format them easily, insert media, and with a click of a button, your content is live and on the web. And also, WordPress is available in more than 70 languages, so you can choose and create content with the language you're most comfortable with. The next feature is it is flexible. Now with WordPress, you can create various types of website like a personal blog, a website, a photo blog, a business website, a professional portfolio, a government website, a magazine, a news website, an online community, and many more. You can make your website visually pleasing using themes and extend it with plugins. With WordPress, you can also build your very own applications. The next feature is user management. WordPress uses a concept of roles, which are designed to give the site owner the ability to control what users can and cannot do within the site. The site owner can assign different roles to different set of users. Generally, WordPress has 6 predefined roles: the super admin, administrator, editor, author, contributor, and subscriber. Now, the super admin role allows a user to perform all possible capabilities or functions. The administrator manages the site, editor works with the content, author and contributor write the content, and subscriber has only the read capabilities. This lets you have a variety of contributor to your website and let others simply be a part of your community. The next feature is you can extend it with plugins. WordPress comes packed with a lot of features for every user. For every feature that is not in the WordPress core, there is a plugin directory with thousands of plugins. You can add complex galleries, social networking, forums, social media widgets, spam protection, calendars, fine-tuned controls for search engine optimizations, and forms. These were just some of the plugins which you could use with WordPress. The next feature is it has an easy theme system. You can select from thousands of themes to create a beautiful website from the theme directory. By default, WordPress comes bundled with 3 default themes, but you can upload your own themes with a few clicks. Now it only takes a few seconds for you to completely customize your website. The next feature is search engine optimization. WordPress is optimized for search engines right out of the box. If you want more fine-grained SEO controls, there are plenty of SEO plugins to choose from. Now these were just some of the features of WordPress. Let us move on to our next topic and see what is Google Cloud Platform. Google Cloud Platform is a suite of cloud computing services and management tools offered by Google. GCP runs on the same cloud infrastructure that Google uses internally for its end user products such as Google Search, Gmail, Google Photos, and even YouTube. It is one of the leading cloud service providers along with Amazon Web Services and Microsoft Azure Cloud and owns 7% of the total cloud market share. Gartner has positioned Google as the Magic Quadrant leader among the furthest 3 positioned vendors. Google Cloud's global network spans across 25 regions with 76 zones and is available to the users from 200 plus countries and territories. Now, a region is a specific geographical location where you can host your resources, and a region can have 3 or more zones. Now, what are the resources GCP provides us? Google Cloud Platform provides various services in different domains. Let us take a look at some of the core GCP service domain. First is the Cloud Compute Engine. This service is where we can create instances or virtual machines on GCP. Second is the storage and database. GCP offers highly durable, available, and scalable storage solutions for different types of data and access methods. Next is the networking service. GCP provides a fast, reliable, securing networking that scales based on user demands. Next, we have big data. GCP provides several services like Dataflow, Dataprocs, and Data Fusion to help you create a complete cloud-based big data infrastructure. Next, GCP provides all the tools developer and the development team needs to be productive while writing, deploying, and debugging applications hosted on the Google Cloud. The next service domain is identity and security. This domain lets administrator authorize who can take actions on specific resources, giving you full control and visibility to manage Google Cloud resources. Next, we have Internet of Things. GCP provides you with an intelligent IoT platform which is scalable, fully managed, and integrated. It lets you connect, store, and analyze data at the edge and in the cloud. The next service domain is Cloud AI. GCP provides fast, scalable, and easy-to-use AI offerings, including AI platform, video and image analysis, speech recognition, and multi-language processing. These were some of the core service domains in GCP. Now, Google also provides free trial to all its new customers. It provides $300 in free credit to fully explore and conduct an assessment of Google Cloud Platform. You can use this $300 to try various Google Cloud products and learn how to use them. You won't be charged until you choose to upgrade, and it is valid for 90 days. GCP also has free tier in which all Google Cloud customers can use selected Google Cloud products like Compute Engine, Cloud Storage, and BigQuery free of charge within the specified monthly usage. Now, until you stay in your free tier limits, these resources will not be charged. Now, we're talking about GCP free tiers because we're going to use it for our demo. Now, let us move on to our next topic and see the steps to host WordPress on GCP. The first step would be to sign in into your Google Cloud Console. If you're new to Google Cloud, you can just sign up for an account by providing your address and your credit or debit card details. It is a very simple process and it won't take you long. Next, after that, you have to first create a new project in the Google Cloud. You will find first project on the top left corner. From there, you can create your project. The next step is selecting a WordPress instance. For this, you have to go to the navigation menu, which is on the left-hand side, and under that, select Marketplace. Now, Google Cloud Marketplace will allow you to quickly deploy functional software packages that run on Google Cloud. Even if you're not familiar with services like Compute Engine or Google Cloud Storage, you can start up with familiar software packages without having to manually configure the software or the virtual machine, the storage or network settings. Next, you have to select your WordPress instance from the GCP Marketplace. Now, there are various deployments of WordPress in GCP. I will show you in the demo part. So in today's session, we'll select WordPress certified by Bitnami because it is quite simple and straightforward to install. You will find this under Blocks and CMS column. Next, it will ask you to configure your WordPress instance. You can make changes according to your convenience. After the configuration is done, you can simply click on Deploy, and after a few moments, your WordPress website is deployed on Google Cloud Platform. But this is not the end. Your site is only accessible via an IP address, so you'll have to map a domain to the IP address. This step is important because if somebody has to access your website, they will prefer to enter the domain name to your website rather than the IP address. You can just register for a new domain name if you do not have one and link it to your WordPress website. Next, you have to set up an SSL certificate, which stands for Secure Socket Layer. Now, this is a type of digital certificate that provides authentication for a website and enables an encrypted connection. This step is not mandatory, but it is recommended. Now, let us move on to our next topic and see some of the benefits of hosting WordPress on Google Cloud Platform. The first benefit is uptime. Businesses such as big e-commerce stores, trading sites, and news sites rely heavily on optimal server uptimes. They would want their servers to be up and running always because even with a slight interruption in the service, it can cause them a lot of financial damage. But Google Cloud Engine is available for more than 99.9% of the time, so companies can be assured they won't have this problem. Next, it is simple to deploy. As I've told you in the previous topic how simple it is to deploy WordPress on the Google Cloud, I will also show you how simple it is. It also gives you complete liberty to make changes to any of your root files. With GCP hosting, you will get high performance consistently no matter how much traffic you receive. The third benefit is reliability. Google Cloud Engine uses the same infrastructure as other Google apps like Gmail and YouTube, which means your website is hosted on the most well-maintained hardware which is controlled by Google. So you can be assured there would not be much downtime to your website. Google constantly works on improving the services so they can provide a better customer experience. The next benefit would be scalability. Google Cloud Engine servers are highly scalable and can handle unexpected traffic spikes with ease. So imagine there is a peak time and a lot of users are trying to access your website. Now, as your website is hosted on the Google Cloud, it will scale its servers up in order to match the incoming traffic. With GCP, you can also upgrade or downgrade your server size without changing the IP address. Now, these were some of the advantages of hosting your WordPress website on GCP. Let us move on to a demo part where we'll host our WordPress website on the Google Cloud platform. So for our demo, I've logged in into a GCP account. It is very simple to create a GCP account. All you have to do is enter your debit card or your credit card detail and your address. Then you might be charged maybe 1 rupee, but even that will be refunded later. Now, as you sign in into a new account, GCP will provide you $300 free credit. Now you can use this $300 to explore Google Cloud services. You won't be charged until you choose to update, and it will be valid for 90 days. So the first step is creating a new project. So we'll go to my first project over here. I will just select a new project from here. We can name a project anything. So let us name it demo. We'll just create it. Now you can see our demo project is created. Now let us move on and select our WordPress instance. So for that, we'll go to navigation menu. Now here you have something called a marketplace. Now marketplace will allow you to quickly deploy functional software packages that run on Google Cloud. So we'll go to marketplace. Here you can see there are a few WordPress instances. But in today's session, we're going to use WordPress certified by Bitnami and Automatic. But let us take a look at WordPress Google Click to deploy. So we select this. Here you can see the overview of the instance and its details. The type of virtual machine, the version, the operating system, and the packages it contains. Here when we go to pricing, you can see how much will it cost you per month. So it will cost us 2,751 rupees per month. Now let us go back and see WordPress by Bitnami. It will be under blocks in CMS. So we'll just click on this. So here is our overview of our instance, its details, and the pricing. And you can see the pricing is 1,009 rupees. It is way more cheaper and it is very simple and straightforward to deploy. It also comes with a lot of preloaded packages which are very helpful for a WordPress website. So now we will go ahead and launch it. Now we have to configure our instance. First, we have to name our deployment. So we'll just name it WordPress demo. Next, we have to select a region. So for this, if you're using a free tier account, you should select a particular region only. If you go to the GCP free tier page, we can launch a F1 micro virtual machine for free only in this region, which is Oregon, US West 1, or Iowa, US Central 1, or South Carolina, which is US East 1. So we'll go back and we'll just select US East 1. Now you can select anything from B, C, D. These are just the zones available. We'll just select this. Next, we have to select the machine type. So for this demo, I won't be needing too much of compute capacity. Now here the default is small, with one shared virtual CPU and 1.7 GB memory. But for this demo, I'll go with micro, where I get one shared virtual CPU and 0.6 GB memory. You can select your compute capacity according to your website needs. Now the micro machine type will only cost me $5.13 per month. Next, we have boot disk. The boot disk type can be either standard persistent or SSD persistent or balanced persistent. So let us just go with the standard persistent disk. and the boot disk size be 10 GB. We'll keep the networking as default itself. Next, we'll select both HTTP and HTTPS traffic from the internet. This basically means allowing network traffic to your website. This means anyone with the access of internet can visit your website. We'll accept the term and condition and just click on deploy now. You can go back and check how much would it cost you per month. For me, it would cost $5.13 per month. So just go ahead and deploy it. It will just take a few minutes for Google to deploy your WordPress website. During the process, software scripts is run, WordPress is configured, the username and password for your WordPress account is generated. Now you can see our WordPress website is successfully deployed. Now let us log into a WordPress website. We'll just click on admin URL. Our username is user. We'll just copy the password from here and we'll log in. And now we are in our WordPress website. Now let us just post something. Go to post, add new. We'll just type WordPress on GCP and we'll publish it. Now let us view our website. Here, WordPress on GCP. Now going back to our Google Cloud Platform, you will see the IP address which we used to log in will keep changing every time I restart my virtual machine. Now we have to make that static. So for that, we'll just go to navigation menu and we'll select VPC network, and from here we'll go to external IP addresses. Now the type here is ephemeral. We'll make it static. We'll just name it and we'll just reserve this. Now the IP address will be static and it won't change every time I restart my virtual machine. So this was today's demo. But after this, you still have to link a domain name to a static IP address and also set up a SSL certificate. Now a SSL certificate is a bit of code on your web server that provides security for online communication. Now let us compare these three cloud service providers. Let us first compare them based on the market trends and growth rate. Now, according to Statista, AWS owns 32% of the total cloud market share. Amazon reported that Amazon Web Services revenue was $13.5 billion in the first quarter of 2021, which actually exceeded the analyst prediction of $13.1 billion. Now, when you compare this to the first quarter revenue of 2020, which was $10.33 billion, we can see AWS revenue grew more than 30% in a year. In the first quarter of 2021, AWS revenue accounted for 12% of total Amazon's revenue and nearly 47% of Amazon overall operating income. Amazon CEO Jeff Bezos has said AWS has an unusual advantage of a 7-year head start before facing like-minded competition. As a result, the AWS services are by far the most evolved and most functionality rich. Next, let us take a look at the market trend for Azure. According to Statista, Microsoft Azure owns 20% of the total cloud market share. Now, unlike Amazon, Microsoft only reports the growth rate and not the revenue. It reported 50% revenue growth over the previous quarter, which was better than the 46% growth the analysts expected. In 2020, Microsoft reported that its commercial cloud officially hit the 50,000 billion mark for its annual run rate. Next, looking at the market trend for GCP, according to Statista, GCP owns 9% of the total cloud market share. In the first quarter of 2021, Google Cloud reported revenue of $4.0 billion, which was an increase of 46% compared to the previous year. Also, the operational losses were reduced to $974 million this year compared to the losses of $1.73 billion last year. Now, this was the market trend and growth rate of AWS, Azure, and GCP. Now, let us move on and compare them based on their availability zones. But before we compare their availability zones, I would like to define what are availability zones and regions. Now, a region is a specific geographical location where you can host your resources, and availability zones are distant locations within the region that are engineered to be isolated from failure from the other availability zones. Now, talking about the availability zones of AWS, it has the most extensive global cloud infrastructure. Its multiple availability zones are connected by a low latency, high throughput, and highly redundant networking. AWS has 80 availability zones within 25 geographical locations around the world, and has also announced for 15 more availability zones and 5 more regions in Australia, India, Indonesia, Spain, and Switzerland. Now comparing it to the availability zones in Azure. Azure has 60 plus region, with each region having at least 3 availability zones. Next, coming to GCP availability zones, its global network spans across 25 regions with 76 zones and is available to users from 200 plus countries and territories. GCP has recently announced new regions in Seoul, Salt Lake City, Las Vegas, Jakarta, and Warsaw, and will also expand its networks to 9 more regions. Now, this was about the availability zones. Next, let us see what are the top companies using this cloud service providers. First, talking about AWS, its services are used by top companies like Netflix, Coca-Cola, McDonald's, Unilever, ESPN, and Adobe. Next, coming to Azure, it is used by many Fortune 500 companies. And some of the companies which use Microsoft Azure clouds are Samsung, HP, BMW, FedEx, and Pixar Animated Studio. Moving on to GCP, the top companies who use their services are PayPal, Twitter, 20th Century Fox, P&G, and King Digital Entertainment. Now that we have seen what are the top companies which use these cloud service providers, let us compare them based on the compute services. Compute services are one of the core services when it comes to cloud computing. Compute services helps to create instances of virtual machines in minute and also scale up instances instantly if needed. So in today's session, we're going to compare these 3 cloud service providers based on the compute service and storage service. The primary compute service for AWS is Amazon EC2. The primary compute service for Azure is Azure Virtual Machine. And for GCP is Google Compute Engine. Now all the 3 services are equally powerful but unique in their own way. Each one has its own advantages and disadvantages. Like Amazon EC2 has 99.5% of the annual uptime and can be tailored with variety of options according to users' requirements. On the other hand, Azure Virtual Machines provides enhanced security and hybrid cloud capabilities. But when you compare the cost, Azure instances tend to get costlier as the compute size increases. Next, talking about Google Compute Engine, they're comparatively cheaper, they come with a persistent disk storage and provide consistent performance. Next, talking about the storage services, AWS offers a variety of storage options like S3 for object storage, EBS for block storage, EFS for file storage, and a few other storage services. Next, talking about Azure Cloud Storage, this also includes object, file, disk, queue, and table storage. They also have specialized services for data-rich applications and many data backup services. Now talking about GCP Cloud Storage, they have a fewer storage as compared to the other two, but they are more targeted. For object storage, GCP offers cloud storage. It offers persistent disk for block storage to be used with virtual machine and file storage for storing the files. For backing up your data, AWS provides a service called as AWS Glacier and Azure provides a service called as Azure Backup, but Google does not yet have any backup services. Next, let us compare these 3 cloud service providers according to the pricing. Now, all the 3 cloud service providers offer a pay-as-you-go structure, which means you only pay for the services you use. Now, pricing would vary for different services. Like for compute services, one cloud service provider could be cheaper, but it could be costlier for database services, and so on. So just to give you a general overview of the pricing, among the 3 cloud service providers, GCP offers a slightly cheaper pricing model and has a flexible cost control, which allows you to try the different services and features. AWS charges you on an hourly basis, whereas Azure charges you on a per minute basis, and GCP provides per second billing for its resources. When it comes to a short-term subscription plan, Google Cloud and Azure gives you a lot more flexibility. But in certain services, Azure tends to be costlier when the architecture starts scaling up.
Let's understand the best practices under data management. So first you have to ensure a total visibility of data. Without a holistic view of data and its resources, it can be difficult to know what data you have, where data originated from, and what data is in the public domain that shouldn't be. Second, to design data loss prevention policies in JUsuit. So data loss prevention in JUsuit is a set of policies, processes, and tools that are put in place to ensure your sensitive information won't be lost during a fire, a natural disaster, or break-in. You never know when tragedy will strike. That's why you should invest in prevention policies before it's too late. Third is have a logging policy in place. So it is important to create a comprehensive logging policy within your cloud platform to help with auditing and compliance. Access logging should be enabled on storage buckets so that you have an easily accessible log object access. Administrator audit logs are created by default, but you should enable data access logs for data writes in all services. Also use display names in data flow pipelines. So always use a name field to assign a useful at a glance name to the transform. This field value is reflected in the Cloud Data Flow Monitoring UI and can be incredibly useful to anyone looking at the pipeline. It is often possible to identify performance issues without having to look at the code using only the monitoring UI and well-named transforms. Then moving on to the second category, that is cost optimization. So one of the best practices for cost optimization is to automate it, like automating the tasks and reduce manual intervention. Automation is simplified using a label, which is a key value pair applied to various Google Cloud services. You can attach a label to each resource, such as compute instances, then filter the resources based on their labels. So the second best performance under cost optimization is using preemptible virtual machines. As with most trade-offs, the biggest reason to use a preemptible virtual machine is cost. So preemptible virtual machines can save up to 80% compared to a normal on-demand virtual machine. This is a huge savings if the workload you are trying to run consists of short-lived processes or things that are not urgent and can be done anytime. So the third one is purchase commitments. The sustained usage discounts are a major differentiator for GCP. They apply automatically once your instance is online for more than 25% of the monthly billing cycle and can net you a discount of up to 30% depending on instance type. You can combine sustained and committed use discounts but not at the same time. Committed use can get you a discount of up to 57% for most instance types and up to 70% for memory optimized types. Fourth is utilize cost management tools that take action. Using third-party tools for cloud optimization help with cost visibility and governance and cost optimization. Make sure you aren't just focusing on cost visibility and recommendations, but find a tool that takes the extra step and takes those actions for you. This automation reduces the potential for human error and saves organization time and money by allowing developers to reallocate their time to more beneficial tasks. Now, the last best performance in the cost optimization is optimized performance and storage costs. In the cloud, where storage is billed as a separate line item, paying attention to storage utilization and configuration can result in substantial cost savings. And storage needs like compute are always changing. It's possible that the storage class you picked when you first set up your environment may no longer be appropriate for a given workload. Moving on to the next category, that is networking. So the first best performance under networking is use virtual private cloud to define your network. So use VPCs and subnets to map out your network and to group and isolate related sources. Virtual private cloud is a virtual session of a physical network. Virtual private cloud networks provide scalable and flexible networking for compute engine virtual machine instances and for the services that leverage virtual machine instances including Google Kubernetes Engine, Dataproc, and Dataflow, among others. VPC networks are global resources. A single VPC can span multiple regions without communicating over the public internet. This means you can connect and manage resources distributed across the globe from a single Google Cloud project, and you can create multiple isolated VPC networks in a single project. VPC networks themselves do not define IP addresses ranges. Instead, each VPC network consists of one or more partitions called subnetworks. Each subnet in turn defines one or more IP address ranges. Subnets are regional resources. Each subnet is explicitly associated with a single region. Then we have centralized, like you have to centralize the network control. So use shared VPC to connect to a common VPC network. Resources in those projects can communicate with each other securely and efficiently across project boundaries using internal IPs. You can manage shared network resources such as subnets, routes, and firewalls from central host project, enabling you to apply and enforce consistent network policies across the projects. With shared VPC and IAM controls, you can separate network administration from project administration. This separation helps you implement the principle of least privilege. For example, a centralized network team can administer the network without having any permissions into the participating projects. Similarly, the project admins can manage their project resources without any permissions to manipulate the shared network. Then connect your enterprise network. So many enterprises need to connect existing on-premises infrastructure with their Google Cloud resources. Evaluate your bandwidth, latency, and SLA requirements to choose the best connection option. If you need low latency, highly available enterprise-grade connections that enable you to reliably transfer data between your on-premises and VPC networks without traversing the internet connections to Google Cloud, then use Cloud Interconnect. And if you don't require the low latency and high availability of Cloud Interconnect, or you are just starting on your cloud journey, then use Cloud VPN. Now, moving on to the next category of best practices, that is security. So, under this, first one is like apply least privilege access controls or identity and access management. The principle of least privilege is a critical foundation element in GCP security. The principle is the concept of only providing employees with access to applications and resources they need to properly do their jobs. Second is manage unrestricted traffic and firewalls. Limit the IP ranges that you assign to each firewall to only the networks that need access to those resources. GCP's advanced VPC features allow you to get any granular with traffic by assigning targets by tag and service accounts. This allows you to express traffic flows logically in a way that you can identify later, such as allowing a front-end service to communicate to virtual machines in a back-end service account. And the third one is ensure your bucket names are unique across the whole platform. It is recommended to append random characters to the bucket name and not include the company name in it. This will make it harder for an attacker to locate buckets in a targeted attack. Fourth is set up a Google Cloud organizational structure. When you first log into your Google Admin Console, everything will be grouped into a single organizational unit. Any settings you apply to this group will apply to all the users and devices in the organizations. So, planning out how you want to organize your units and hierarchy before diving in will help you save time and create a more structured security strategy. Moving on to the next category, compute engine region selection. So the first one in this is when to choose your compute engine region. So early in the architecture phase of an app, decide how many and which compute engine regions to use. Your choice might affect your app. For example, architecture of your app might change if you synchronize some data between copies because the same users could connect through different regions at the same time. Also, like price differs by region, and also process to move an app and its data between regions is cumbersome and sometimes costly, so should be avoided once the app is live. Second is we need to see the factors to consider while selecting regions. Okay, there are multiple factors where you decide to deploy your app. Okay, so first factor is latency. However, this is a complex problem because the user latency is affected by multiple aspects such as caching and load balancing mechanisms. In enterprise use cases, latency to on-premises systems or latency for a certain subset of users or partners is more critical. And the second factor affecting is price. So Google Cloud resources, if you see, like their costs differ by region. The resources available to estimate the prices are compute engine pricing, pricing calculator, Google Cloud SKUs, billing API. If you decide to deploy in multiple regions, be aware that there are network charges for data synced between regions. And the third factor affecting is co-location with other Google Cloud services. So co-locate your compute engine resources with other Google Cloud services wherever possible. While most latency sensitive services are available in every region, some services are available only in specific locations. Fourth factor affecting is machine type availability. Not all CPU platforms and machine types are available in every region. The availability of specific CPU platforms or specific instance type differ by region and even zone. The fifth factor affecting is resource quotas. Your ability to deploy compute engine resources is limited to regional resources quotas. So make sure that you request sufficient quota for the regions you plan to deploy in. Moving on to the third best practice, that is evaluating latency requirements. So latency is often the key consideration for your region selection because high user latency can lead to an inferior user experience. You can affect some aspects of latency, but some are outside of your control. Region selection can only affect the latency to the compute engine region and not like entirety of the latency. So the first one in this is last mile latency. The latency of the segment differs depending on the technology used to access the internet. Then the second one is Google frontend and edge pop latency. These are like subcategories under evaluate latency requirements best practices. So second subcategory I mean is Google frontend and edge pop latency. Depending on your deployment model, the latency to Google's network edge is also important. This is where Google load balancing products terminate TCP and SSL sessions and from which Cloud CDN delivers cache results. Based on the content served, many round trip might already end here because only part of the data needs to be retrieved the whole way. Okay. So moving on to the third subcategory, that is compute engine region latency. So in compute engine region latency, the user request enters Google's network at the edge pop. The compute engine region is where Google Cloud Services handling requests are located. This segment is the latency between the edge pop and compute engine region, and it's wholly within Google's global network. So the fourth subcategory is app latency. Different apps have different latency requirements. Depending on the app, users are more forgiving of latency issues. Apps that interact asynchronously or mobile apps with a high latency threshold, 100 milliseconds or more, can be deployed in a single region without degrading the user experience. However, for apps such as real-time games or a few milliseconds of latency can have a greater effect on user experience. Deploy these types of apps in multiple regions close to the users. Now, moving on to the next category, that is AR platform training. We have different best practices under AR platform training also. So the first one is choose the right machine configuration for your training characteristics. You can choose arbitrary machine types and various GPU types. The machine configuration that you choose depends on your data size, model size, and algorithm selection. For example, deep learning frameworks like TensorFlow and PyTorch benefit from GPU acceleration, while frameworks like Scikit-learn and XGBoost don't. On the other hand, when you are training a large Scikit-learn model, you need a memory optimized machine. Okay, so the second one in this is don't use large machine for simple models. Simple models might not train faster with GPUs or with distributed training because they might not be able to benefit from increased hardware parallelism. Because the scikit-learn framework doesn't support distributed training, make sure that you use only the scale tier or custom machine type configurations that correspond to a single worker instance. And the third best performance is scale up before scaling out. So scaling up instead of scaling out while experimenting can help you identifying the configurations that are performant and cost effective. For example, start by using a single worker that has a single GPU and then try a more powerful GPU before you use multiple GPUs. After that, try distributed training as discussed later in the section. Scaling up is faster than scaling out because network latency is much slower than the GPU interconnect. And the fourth best performance under AR platform training is for large data sets, use distributed training. So distributed training platforms data parallelism on a cluster of nodes to reduce the time required to train a TensorFlow model when you use a large data set. Make sure that you adjust the number of iterations with respect to the distribution scales. That is, take the total number of iterations that are required and divide the total by number of GPUs multiplied by the number of work nodes. I hope you have understand all the best practices under the Google Cloud Platform.
What exactly is Google Cloud Certification? Well, Google Cloud Certification is a level of Google Cloud expertise that an individual obtains after passing one or more certification exam. The certification validates your cloud expertise and helps you showcase your ability to help companies and businesses with Google Cloud technology. Now, some of the reasons to get a Google Cloud certification would be you will be more confident about your cloud skills. According to the survey response from the 2020 Google Cloud Certification Impact Report, 87% of the Google Cloud certified individuals are more confident about their cloud skills. Next, the Professional Cloud Architect was the highest paying certification of 2019 and also 2020. Next, more than 1 out of 4 Google Cloud certified individuals took on more responsibility and leadership roles at their work. Now, a company or an organization is more likely to work with an individual who is certified rather than a person who isn't. This is because the certification acts as a proof that you have knowledge about Google Cloud and you have worked on it before. Now, this was about Google Cloud certification. Now, let us move on to our next topic and see the types of certification. There are 3 levels of Google certification. First is the foundational certification, next is the associate level certification, and then comes the professional level certification. Now, let us discuss about them one by one. The fundamental level of certification validates broad knowledge of cloud concepts and Google Cloud products, services, tools, features, benefits, and use cases. To sum it up, you should basically understand the capabilities of Google Cloud. Now, in this level of certification, there is only one certificate, which is the Cloud Digital Leader. This certification is appropriate for individuals in a non-technical job role who wants to add value to their organization by gaining cloud knowledge. This certification is also for someone who has little or no hands-on experience working on the Google Cloud. In the foundational certification, multiple choice and multiple select types of questions are asked. You will have 3 hours to complete this examination, and the registration fees for this examination is $99. You can write this examination in English. You can either write it online or in a test center near you. The next level of certification is the associate level. This level of certification focuses on the fundamental skills of deploying, monitoring, and maintaining projects on Google Cloud. In this level of certification also, there is only one certificate, which is the Cloud Engineer. Now, this certification is a good starting point for those who are new to cloud and can be used as a path to professional level certifications. It requires at least 6 months of work experience working on the Google Cloud. The types of questions which are asked in the associate examinations are also multiple choice and multiple select, but you will have only 2 hours to complete this exam, and the registration fees for this examination is $125 plus taxes. You can write this examination in English, Japanese, or Spanish. The last level of Google certification is the professional level. This level of certification ranges across various key technical job functions and accesses advanced skills in design, implementation, and management. The certifications are recommended for individuals with industry experience and familiarity with Google Cloud products and solutions. There are 8 professional cloud certifications in Google, which are the Cloud Architect, Cloud Developer, Data Engineer, Data Security Engineer, Cloud Network Engineer, Cloud DevOps Engineer, Collaboration Engineer, and Machine Learning Engineer. Now, this level of certification requires more than 3 years of industry experience, including more than 1 year of hands-on experience working on the Google Cloud. The types of questions asked in this examination are again multiple choice and multiple selects, but you'll have 2 hours to complete this examination. The registration fees for this examination is $200 plus taxes, and you can write this examination in English. Now, some of the professional certification exam can also be written in Japanese. You can either write this examination online or in a test center near you. Now, these were the types of certification. Now, let us move on to the next topic and see some of the major role-based certification. We will start by knowing the fundamental level certification, which is Cloud Digital Leader. A Cloud Digital Leader should have good understanding of Google Cloud core products and services and how they benefit the organizations. The Cloud Digital Leader should understand how the services can be used in real time to solve business problems and how cloud solutions support an enterprise, making it more efficient. This is the only Google Cloud certification that does not require any previous cloud experience nor requires hands-on experience with Google Cloud. So if you're just starting your cloud career and do not know where to begin, well, preparing for this certification should be your first step. The Cloud Digital Leader exam accesses your knowledge in 3 areas. The first is general cloud knowledge, second, general Google Cloud knowledge, and Google Cloud products and services. The next certification we'll talk about is the Associate Level Cloud Engineer certification. An Associate Cloud Engineer is expected to deploy application, monitor operations, and manage enterprise solutions. An individual appearing for this certification should be able to use Google Cloud Console and command line interface to perform common platform-based tasks to maintain one or more deployed solution that leverages Google managed or self-managed service on Google Cloud. Now, for this associate level certification, you will need more than 6 months of hands-on experience working with Google Cloud. The Associate Cloud Engineer exam examines your ability to set up a cloud solution environment, plan and configure a cloud solution, deploy and implement a cloud solution, and ensure successful operation of a cloud solution, and also configure access and security. The next certification we'll talk about is the Professional Level Cloud Architect certification. This certification is intended for individuals who are interested in designing and managing business solutions using Google Cloud Platform. According to Google Knowledge, Google Certified Professional Cloud Architect is the highest paying certification. Now, the professional cloud architect should be able to use cloud technologies to maximize the benefit for their organization. They should have a thorough understanding of Cloud Architect and Google Cloud Platform. They should be able to design, develop, and manage robust, secure, scalable, highly available, and dynamic solutions to drive business objectives. For this certification, you should have more than 3 years of industry experience and also have 1 or more year experience architecting and managing solutions using GCP. The next certification is the Professional Cloud Developer. This certification is intended for individuals who want to build and test applications using Google Cloud Service. A professional cloud developer should be able to build scalable and highly available applications using Google recommended practices and tools. You should have hands-on experience with cloud-native application, developer tools, managed services, and databases. A professional cloud developer should be skilled with at least one high-level programming language and skilled at producing meaningful metrics and logs to debug and trace code. For this certification also, you should have more than 3 years of industry experience and more than 1 year of experience designing and managing solutions using Google Cloud. The rest of the professional certifications are the Data Engineer. This certification is intended for individuals who want to design and build data collecting and processing machine learning models on Google Cloud Platform. Next, we have Cloud DevOps Engineer. This certification is intended for individuals who want to work as a DevOps engineer. They should be efficient in both development and operation and should have good knowledge of various DevOps tools. They should build software delivery pipeline, deploy, and monitor services. The next certification is Cloud Security Engineer. This certification is intended for security engineers who have good understanding of security best practices and the current industry security requirements. They have to design, develop, and manage a secure infrastructure using Google Security Services. The next professional certification is a Cloud Network Engineer. This certification is intended for individuals who want to design, implement, and manage network architecture on Google Cloud Platform. Next is a Collaboration Engineer. This certification is intended for individuals who can understand an organization's mail routing and identify management infrastructure and be able to efficiently and securely establish communication and data access. They should have at least 1 year of Google Workspace administration experience. The next certification is the Machine Learning Engineer. This certification is intended for individuals who want to design, build, and productize ML models to solve business challenges using Google Cloud technologies. Now, these were the professional level certification. Now we will move on to a final topic for today, where I will give you a few tips to prepare for this certification. The first point is read the exam guide for the certification. Now, before you start practicing for the certification, I would suggest you to go through the exam guide. The exam guide contains domain and subdomains from which the questions are asked in the examination. This will give you a clear idea about what topics you should focus on in order to pass the examination. You will find the exam guide in the Google Cloud Certification official website. Next, the most important step is hands-on experience. If you're writing any certification examination except the Cloud Digital Leader, you should have at least 6 months of hands-on experience working on the Google Cloud. But if you're just starting your career in Google Cloud or want to start a career with Google Cloud, I would highly recommend you using the GCP free trial account. Now, Google provides all its new customers with free trial, which offers $300 in free credits. Now, they do this because they want you to fully explore and conduct an assessment on Google Cloud Platform. You can use this $300 to try various Google Cloud products and learn how to use them. You won't be charged unless you choose to upgrade, and it will be valid for 90 days. My next suggestion would be solving the sample questions. The sample questions will familiarize you with the format of the exam question and example content that may be covered on the exam. Now, solving the sample questions will help you improve your confidence. You can also refer Google white papers, which will give you technical knowledge about various Google Cloud concepts and services. If you want to follow a structured approach, then I would highly recommend you to opt for an online training certification. I would highly recommend Edureka's certification training, which is curated by top industry experts. The certification course consists of demonstration, assignments, MCQs, and a certification project, which will help you master the concepts.
Let's go through certain exam questions that have been coming for Google Cloud Platform Associate certification over the past few years. First up, we have your organization plans to migrate its financial transaction monitoring application to Google Cloud. Auditors need to view the data and run reports in BigQuery, but they are not allowed to perform transaction in the application. So you are leading the migration and you want the simplest solution. And what is it that you should do? So the answer to this is fairly simple. What you need to do is, since you're working with BigQuery and there are a lot of auditors, what you need to do is create a group of auditors and assign roles to each BigQuery data viewer, right? So this is because a predefined role is always used to basically provide access to BigQuery for the group of auditors. Now, auditors can be added or deleted from the group, right, according to your responsibilities. So you can always have a group of auditors working on certain data sets at all times. Next up, we have you are managing your company's first Google Cloud project. Now, project leads, developers, and internal testers will participate in the project, which includes sensitive information. Now, you need to ensure that only specific members of your development team have access to certain sensitive information that you have. and you want to assign the appropriate identity and IAM roles. So how should you do that? So when it comes to, let's say, data integrity and sensitive information, you have to make sure that your authentication for every role and authentication for every project is specific, and you have to make sure that if you don't want everybody in the team to know, then you will have to assign roles for specific users who can access these projects. So you have to create the groups and then assign the IAM predefined roles for each group, right? So this is included for those who will have access to the data that you have, right? So predefined roles are fine grained enough to set permissions for specific roles. And that is how you basically make sure that your sensitive data is only accessed by people you want them to see. The next question is, you are responsible for monitoring all the changes in your cloud storage and Firestone instances. For each change, you need to invoke an action that will verify the compliance of the change in near real time. So you want to accomplish this with minimal setup. So when it comes to compliance and real-time application of Firestone and storage, you have to make sure that you have to use Google Cloud Function events and call the security scripts for the function event triggers. This is because Google Cloud Function provides a fast response and requires minimal amount of setup. The next question is, your application needs to process a significant rate of transactions. The rate of transactions exceeds the processing capabilities of a single virtual machine. You want to spread transactions across multiple servers in real time and in the most cost effective manner. So how do you do that? So the answer to this will be that you have to send transactions to PubSub. Now, PubSub is another such API that is present in Google Cloud Platform, and you can use this to process the transactions in the VM in a managed instance group, right? So PubSub is a very scalable solution that can be effectively distributed in a large number of tasks in a group at a very low cost. So this is why PubSub is the best option when it comes to assigning large number of tasks effectively in a group. Next up, we have your team needs to directly connect your on-premises resources to several virtual machines inside a virtual private cloud. You want to provide your team with fast and secure access to the VMs with minimal maintenance and cost. How do you do that? So here we see that we can use Cloud VPN to create a bridge between the virtual private clouds and your specific network. So this is the most feasible option as it adheres to Google's recommended cloud practices. And if you follow Google's best practices, you will basically make sure that you can have the minimal cost and the maximum amount of maintenance with no cost. Next up, we have, you are implementing cloud storage for your organization and you need to follow your organization's regulations. Now, these include that you have to archive data older than 1 year, you have to delete data older than 5 years, and you have to use standard storage for all other data. Now, you want to implement these guidelines automatically and in the simplest manner available. So to do this, what you have to do is you'll have to set up a project lifecycle management. So these are policies that allows you to basically automate the entire implementation process of the organization's data policy. And next up, we come to question number 7. Now, here we can see that you are creating a cloud IoT application requiring data storage for up to 10 petabytes, right? The application must support high-speed reads and writes of small pieces of data, but your data schema is simple. You want to use the most economical solution for data storage. Now, in this case, when you have to use data storage for your Cloud IoT application that you need for continuous read writes, you will have to make sure that you want economical data storage capabilities. So here what you do is you store it in the cloud Bigtable and implement the business logic in the programming language of your choice. Now what Bigtable does is Bigtable provides high speed reads and writes and accommodates a simple schema, which basically makes it very cost effective. The next question is, you have created a Kubernetes deployment on Google Kubernetes Engine that has a backend service. Now, Google Kubernetes Engine is an ML service provided by Google. And you also have pods that run on the front end service. Now, you basically do not want any interruption in the communication between the front end and the back end, even if these pods are removed or restarted. Now, what should you do when there's a case like this? Now, it's a very simple answer. You have to create a service that groups your pods together in the back end service and tells your front end pods to communicate to that service. So you basically have a middle intermediate service that connects both to your back end and front end. Next, we have question number 9. You are responsible for the user management service of your global company. The services will add, update, delete, and list addresses. Each of these operations is implemented by a Docker container microservice. The processing load can vary from low to very high. You want to deploy the service on Google Cloud for scalability and minimal administration. What should you do? Now, here what you have to do is you have to deploy your Docker containers into Cloud Run. Now, Cloud Run is a managed service that basically helps you with minimal administration of your Docker containers. And finally, we come to the last question. Question 10. You provide a service that you need to open to everyone in your partner network. You have a server and an IP address where the application is located, but you do not want to change the IP address of your DNS server if your server crashes or it's replaced. You also want to avoid downtime and deliver a solution for minimal costs in setup. What should you do now? So when it comes to making sure that you do not have to change your IP address on your DNS server when your server crashes or is replaced, what you do is you reserve a static external IP address and assign it using Cloud DNS. External IPs are routable and can be advertised and seen on the internet easily, and it is the most cost effective solution as well.
Now, starting with our interview questions, we are first going to see some general cloud computing and Google Cloud Platform questions, then questions on compute and hosting domains, then storage and databases, next networking, followed by big data, machine learning, and cloud artificial intelligence. So I guess it is clear what all we're going to talk about today. So let's get started. So the first question we're going to discuss is, what is cloud? Now there are various ways to answer this. One of them could be, the cloud can be referred as global network of servers, each with a unique function. These servers are designed to store and manage data, or to run various applications, or deliver content, and have many more functionalities. You can also mention that the servers are located in data centers across the world. You can also talk about the various service cloud offers such as compute, storage, databases, networking, and so on. Now I want you to understand the concepts and frame the answer in your own words. Moving on to our next question. What is cloud computing? Now, like the previous question, even this question can be answered in many ways. So to answer this question, I would say cloud computing is an on-demand availability of computer system resources. Now, these resources could include computing power, storage, databases, and so on. With cloud computing, you don't have to buy or own or maintain physical data centers and servers. You can just rent these resources whenever you need them from a cloud service provider. Now here you can also mention what are cloud computing used for, like it can be used for data backup, disaster recovery, virtual desktops, software development and testing, big data analytics, and customer-facing web applications. So now moving on to a third question. List the type of service model available in cloud computing. So there are 3 types of service model available in cloud computing. That is IaaS, PaaS, and SaaS. IaaS stands for Infrastructure as a Service. In this service model, you can rent IT infrastructure such as servers and virtual machines, storage, networks, and operating system. Let's say a user wants to use a Linux machine. He can access the Linux machine using IaaS service model without worrying about the physical machine or the networking of the system on which the OS is installed. The next service model is Platform as a Service. This service model provides an on-demand environment for developing, testing, delivering, and managing your software application. The users don't have to worry about setting up or managing the underlying infrastructure of servers, storage, networks, and databases which are needed for development. This is taken care of by the cloud service provider itself. The next service model is Software as a Service. In this service model, the cloud providers leases application and software which are owned by them to its client. The clients can access the software on any device which is connected to the internet using tools such as web browser or an application. Now to summarize this answer, just think of it as this way. Infrastructure as a service provides you with an infrastructure such as virtual machine or a servers. Whereas platform as a service provides you with a platform where you can develop, test, and run your application. And software as a service provides you with the software itself. Now I guess you have some idea about service models which are available in cloud computing. Let us move on to the next question. The next question is, list the types of cloud deployment model. So there are 4 types of cloud deployment model, which are public cloud, private cloud, hybrid cloud, and community cloud. In public cloud deployment model, the resources such as application and storage are available to general public over the internet. These resources can be free or sold on demand, which will allow users to pay only per usage for the CPU cycles, storage, or bandwidth they use. Now, when we talk about private cloud, it is operated solely for a single organization. It offers services over a private internet network, which is typically hosted on premises. Now, this private cloud is costlier, but there is high level of security. Next, the hybrid cloud deployment model can be defined as a combination of public and private cloud. It can share services between public and private clouds depending on their purpose. The 4th cloud deployment model is the community cloud. Now, the community cloud infrastructure is shared between several organizations from a specific community with a common concern. Educational universities that are cooperating in the same area of interest as that of a research institute can use the same community cloud. Now, these were the 4 types of cloud deployment model. So now let us move on to the next question and see what are the benefits of cloud computing or why companies are increasingly adopting cloud computing. So now here you can mention some of the benefits of cloud computing, such as there is reduced cost of managing and maintaining IT system or infrastructure. The next benefit is scalability of the IT resources. You can scale up or scale down your operational and storage needs according to your convenience. The next benefit is it provides better productivity and collaboration efficiency. For example, if your team is working on a project across different locations, you can use cloud computing to give your employees, contractors, and third-party access to the same file. The next benefit is data backup and storage. You can elaborate this by saying your data is backed up, so you don't have to worry if your data is lost or deleted. The next advantage is cloud service providers provide automatic updates. This would include up-to-date version of software as well as upgrades to servers and computer processing power. Now, these were just some of the benefits of cloud computing. We can also mention some more benefits of cloud computing. So now let us move on to the next question. So the next question is, what is Eucalyptus? Eucalyptus is the abbreviation for Elastic Utility Computing Architecture for linking your program to useful systems. It is an open source software infrastructure that helps in implementation of clusters in the cloud computing platform. It can build public, hybrid, and private cloud and has the ability to create a data centers into a private cloud. It also helps the user to utilize their functionalities across those other organizations. Now, these were some of the general cloud computing questions that can be asked in a GCP interview. So now let us move on to the next set of questions on Google Cloud Platform. So first question is, what is Google Cloud Platform? We all know Google Cloud Platform is a cloud service provider, but just to define it, Google Cloud Platform is a suite of cloud computing services and management tools offered by Google. It runs on the same cloud infrastructure that Google uses internally for its end user products such as Google Search, Gmail, Google Photos, and YouTube. Now, this is a very basic question, but even this can be asked in your interview. The next question is, what are the various services offered by GCP? The various services offered by Google Cloud Platform are compute services, storage and database services, networking services, big data services, identity and security services, Internet of Things services, then machine learning and cloud artificial intelligence services. Moving on to our next question, what is Google Cloud SDK? Google Cloud SDK or Google Cloud Software Development Kit is a set of command line tools. It is used for the development of Google Cloud. With these tools, you can access the compute engine, cloud storage, BigQuery, and other services directly from the command line. So now I guess you have understood what is Google Cloud SDK. So let us move on to the next question and see what is Google Cloud APIs. Google Cloud APIs are programmatic interface to Google Cloud Platform services. They are a key part of Google Cloud Platform, which allows you to easily add the power of everything from computing to networking to storage to machine learning based data analysis to your applications. Now moving on to our next question, why would you prefer GCP over other cloud service providers? Well, here you are expected to say the benefits of GCP. We can start the answer by saying, well, each cloud service provider has its own pros and cons. But what makes Google Cloud Platform unique is it offers a much better pricing model compared to the other cloud service providers. Next, considering hosting cloud services, GCP has an overall increased performance and service. You can also mention Google Cloud is very fast in providing updates about servers and security in a better and more efficient manner. You can also mention the security level of Google Cloud Platform is excellent. The cloud platform and the networks are secured and encrypted with various security measures. So I guess you got some idea about how to answer this question. So now let us move on to the next question and see what is projects in GCP and how to create one. A project organizes all your Google Cloud resources. A project consists of a set of users, a set of APIs, and billing, authentication, and monitoring settings for those APIs. So for example, all of your cloud storage buckets and objects, along with the user permission for accessing them, all this resides in a project. So in order to create a project, you have to sign in to Google Cloud Platform console. Then on the top left corner, you will have an option called as project. Select that and click on new project to create a new project, or you can also select an existing project from the list. So now I guess you have some idea about projects in GCP. So let us move on to the next question. Our next question is, what is Cloud Shell? So if you have been using GCP, you will know what is Cloud Shell. So for people who don't know what Cloud Shell is an online development and operational environment which is accessible anywhere with your browser. You can manage your resources with its online terminal, which is preloaded with utilities such as gcloud command line tool, kubectl, and many more. We can also develop, build, debug, and deploy a cloud-based application using the online Cloud Shell editor. So this was about Cloud Shell. Our next question is, what are availability zones and region? And how many availability zones and regions are there in GCP? So a region is a specific geographical location where you can host your resources. And availability zones are isolated locations within these regions from where public cloud services originate and operate. And then talking about Google Cloud Platform availability zones and region, it has 25 regions with 76 zones. Each region has at least 3 or more zones. The next question right after this could be, how would you choose an availability zone? Or what all parameters would you consider while selecting an availability zone? So you can answer this by saying you have to select the availability zone based on the following factors. The first factor is latency. Opt for the closest region for low latency. Fast connection to the servers ensures better performance in terms of quick loading and transfer time, which results in overall better user experience. So choose a region that is closest to the majority customer base. And then the next factor you should consider is the cost. Different regions will have different costs for the resources. For example, if I want to use an EC2 instance virtual machine in the US Central region, it would cost me somewhere around $48 per month. But the same virtual machine in Mumbai region would cost me $58. So you can see there is $10 difference per month in these two regions. So these are the factors you need to keep in mind before selecting an availability zone and region. So these were some of the general Google Cloud Platform questions. So let us move on to the next set of questions on compute and hosting services on GCP. So the first and basic question they could ask is, what is Google Compute Engine? Because Google Compute Engine is a primary compute engine in GCP. So you can explain this in a very simple term. It is a secure and customizable compute service that lets you create and run virtual machines on Google's infrastructure. So now moving on to our next question, what is Google App Engine? So App Engine is a fully managed serverless platform for developing and hosting web applications at scale. It allows you to choose from several popular languages, libraries, and frameworks to develop your application, and then the App Engine takes care of provisioning servers and scaling your application instances based on the demand. So now when you answer this question, they might ask you, what is serverless computing? So serverless computing is nothing but a cloud computing execution model in which the cloud provider allocates machine resources on demand, which means they take care of servers on behalf of the customers. So the customers can only focus on building your application where the servers and all that is taken care of by the cloud service providers. So I guess you have some idea about serverless computing. So now let us move on to our next question. Now this question is a frequently asked question. How are Google App Engine and Google Compute Engine different from each other? You can answer this by saying Google Compute Engine and Google App Engine are complementary to each other. Google Compute Engine is an infrastructure as a service product, whereas Google App Engine is a platform as a service product of Google. So now if you want the underlying infrastructure in more of your control, then Compute Engine is a perfect choice. For instance, you can use Compute Engine for the implementation of customized business logic, or in case you need to run your own storage system. On the other hand, you can use Google App Engine if you do not want to provision and manage your servers or scale them. Now I guess you have understood the difference between Google Compute Engine and Google App Engine. So now let us move on to our next question, which is how does the pricing model work in GCP Cloud? So to generally answer this question, you can say, while working on Google Cloud Platform, the user is charged on the basis of compute instances, network use, and storage by Google Compute Engine. Now you can see here, I'm not specifically talking about a particular service. This is just a general overview. Google Cloud charges virtual machines on the basis of per second with a limit of minimum of 1 minute. Then the cost of the storage is charged on the basis of the amount of data that you store. The cost of the network is calculated as per the amount of data that has been transferred between the virtual machine instances while communicating with each other or over the network. Over the network means the internet. You should prepare yourself with the questions on Google Cloud Platform pricing models, as these are among the most common Google Cloud interview questions. So moving on to our next question, what is Google Kubernetes Engine? Google Kubernetes Engine or GKE provides a managed environment for deploying, managing, and scaling your containerized application using Google infrastructure. Basically, in simple terms, it's a platform to deploy and manage containerized applications. So this was the definition of Google Kubernetes Engine. The next question is a scenario-based question. So if I want to run my application on GCP, which product would I use? You can answer this by saying it depends on the application requirements. GCP basically offers 4 means for application deployment, such as Google Compute Engine, Google Kubernetes Engine, Google App Engine, and Cloud Functions. You can use Google Compute Engine if you want to run your application on a customizable virtual machine platform. Next, if you want to run a containerized application, you can use Google Kubernetes Engine. You can use Google App Engine if you do not want to manage the infrastructure and just deploy the application without worrying about scaling your servers. Next, with Cloud Function, it will run your application after an event-driven function. That means only after a particular event occurs, your application will be deployed. So these were the 4 primary means for application deployment model. You can also tell the interviewers you can use a combination of these services. So let us see the next question. The next question is how to migrate servers and virtual machines from on-premises or another cloud to Compute Engine on GCP. So if the interviewer asks you this question, you can just say Google provides a cloud software known as Cloud Migrate for Compute Engine. The software is used to migrate the virtual machines from on-premises data centers or any other cloud service providers into Compute Engine in the GCP platform. You can also mention the software is provided by Google itself and it comes with no additional cost. Now they can also ask this question as what is Cloud Migrate for Compute Instances? The answer would be the same. So now let us move on to the next question and see why should you opt for Google Cloud hosting. This question is usually asked in Google Cloud consultant interviews. The interviewer may ask this question to check your knowledge and explanation skills about Google Cloud. So here talk about the advantages of choosing Google Cloud hosting. The first advantage is it provides a better pricing plans. Next, there is a benefit of live migration of virtual machines, which means you can migrate a running virtual machine to and from any cloud service providers or on-premises also. The next benefit is it provides enhanced performance and execution. It also has strong control and security of the cloud platform. The next benefit is it has inbuilt redundant backup, which will ensure data integrity and reliability. So these were some of the benefits of Google Cloud hosting. Let us move on to the next question and see what are shielded virtual machines. Shielded virtual machines are virtual machines on Google Cloud which are hardened by a set of security control that helps them defend against threats such as malicious project insiders, malicious guest firmware, and kernel or user mode vulnerability. Using shielded virtual machines help protect enterprises' workload from threats like remote attacks and malicious insiders. So these were some of the questions on compute and hosting services in GCP. So now let us talk about the interview questions in storage and database services in GCP. So our first question in storage and database section is, what is cloud storage? Well, cloud storage is the primary storage service in GCP. It is a service offered by Google for storing your objects in the Google Cloud. Now, an object is an immutable or unchangeable piece of data consisting of files of any format. Now, object can be unstructured data such as music, images, videos, backup and log files, or archive files. Also, objects have two components, which are object data and object metadata. While object data is typically a file that you want to store, and object metadata is a collection of name-value pairs that describes the various object qualities. Now you store these objects in containers called buckets. So when you mention about buckets, there is a high probability of the interviewer asking you, what are buckets in cloud storage? Well, buckets are nothing but a basic containers that hold your data. Now everything that you store in cloud storage must be contained in a bucket. You can use bucket to organize your data and control access to your data, which means you decide who has access to your data. You can create a bucket by specifying a globally unique name for your bucket, also specifying a geographical location where the bucket and its contents are stored, and also a default storage class. So this was about buckets in cloud storage. The next question we're going to discuss is, what are the types of GCP storage available and in what scenarios do we use them? Now here we've already talked about cloud storage, so we'll move on to the other GCP storage services. Now it offers Google Drive, which can be used to store, manage, and share your personal files. Next we have cloud storage for Firebase, which helps you manage data in your mobile applications. The next storage service is persistent disk. Now this is a block storage which can be added to your compute engine virtual machines. And last we have file store, which allows you to store files or create a file-based workload. So these were the GCP storage services. Our next question is, what is object versioning in GCP? Well, object versioning is used to retrieve objects which are overwritten or deleted. So let's say I have updated a file in cloud storage. Now the updated file and the file before updating, both versions will be available to me. So if the updated file gets deleted by mistake, or I want to check what was the file before the update, I can do that with the help of object versioning. One disadvantage of this would be it increases the storage cost, but it would provide me security for objects when they're deleted or overwritten. And on enabling the object versioning in GCP bucket, a non-concurrent version of the object is created every time when the object is overwritten or deleted. So the next question in storage and database section is, what are the libraries and tools for cloud storage on Google Cloud Platform? Well, you can answer this question by mentioning the libraries and tools such as Console, GSUtil, Client Libraries, and REST APIs. Now, Console is nothing but the Google Cloud Console, which provides a visual interface for you to manage your data and perform basic operational on objects and buckets. Next, GSUtil is a command line tool that allows you to interact with cloud storage through a terminal. Next, we have the Cloud Storage Client Libraries, which allows you to manage your data using one of the preferred language, which would include C++, C#, Go language, Java, Node.js, PHP, Python, or Ruby. The next tool for accessing cloud storage on GCP is REST APIs. Now you can manage your data using the JSON or XML APIs. So these were the libraries and tools for cloud storage on Google Cloud Platform. So now moving on to our next question, how can I maximize the availability of my data, or how can my important data be more secure and available to me? You can answer this by saying you can store your data in multi-region or dual region bucket location if high availability is a top priority. This ensures that your data is stored in at least 2 geographical separated regions, which will provide you continued availability even in the rare event of a region-wide outage, which includes anything caused by natural disasters. So this is what GCP offers for more availability of their data. Moving on to our next question, what is Cloud SQL? Well, Cloud SQL is a fully managed database service that helps you set up, maintain, manage, and administer your relational database on the Google Cloud Platform. We can also mention you can use Cloud SQL with MySQL, PostgreSQL, or the SQL Server. Well, Cloud SQL is one of the core database services in Google Cloud Platform. The next question is, how would you choose the right Google Cloud Database Service? Well, this would definitely depend on the requirement. You can select from any of these options. You can select either Cloud SQL, Cloud Spanner, Cloud Firestore Data Store, Cloud Big Data, or Cloud Memory Store. You can choose Cloud SQL when you need relational database capacity but do not need storage capacity over 10 TB or more than 4,000 concurrent connections. Next, you can select Cloud Spanner when you plan to use large amount of data, which is typically more than 10 TB and need transactional consistency. Next, you can use Cloud Firestore or Data Store when you plan to focus on application development and need live synchronization and offline support. The next option is Cloud Bigtable. Now, Cloud Bigtable is a good option if you're looking for large amount of single key data, in particular, which is good for low latency and high throughput workloads. And the last option is Cloud Memory Store. Now, this would be a good option if you're looking for key value datasets and your primary concern is transactional latency. These were some of the Google Cloud Database Services. So now let us move on to our next question, which is a scenario-based question. So the question is, can my app engine in one region access the Cloud SQL instance which is present in a different region? Well, the simple answer for this is yes. If you're connecting to a MySQL instance, your App Engine application does not need to be in the same region, and it can be running in either the standard or the flexible environment. However, a larger distance between a Cloud SQL instance and your App Engine application causes greater latency for connection to the database. Now, latency is nothing but a delay in the transmission of data. So the next question in the storage and database section is, can I import or export a specific database in Google Cloud Platform? Well, the answer for this is also yes. For MySQL instances, you can import and export either a single database or multiple databases. And for PostgreSQL instances, you can only import or export a specific database. Now, these were some of the questions in storage and database service in GCP. Now, let us move on to the next set of questions in networking. So the first question in this section is, what is Google Cloud VPC? Now, if you're applying for any Google Cloud job, you're expected to know this answer. Virtual Private Cloud in GCP is a virtual network that provides connectivity to all your virtual machine instances. It could be your compute instance, Google Kubernetes Engine clusters, or your App Engine flexible environment, and any other Google Cloud products which are built on the compute instances. So you don't have to talk in detail about VPC. You can just define it so the interviewers knows that you have some knowledge about VPC. So the next question is, how is Google VPC different from any other cloud service provider's VPC? So as you can see in the diagram, in the traditional VPC or the VPC provided by other cloud service providers like AWS, the architecture would look something like this. Now here in the first diagram, you can see there are two VPC built with two different subnets in two different regions, which are US West and US East. Now the virtual machine in one region can access the internet and communicate with the other virtual machine only through the VPC gateway. Now this gateway acts as an interface. So now in a traditional VPC, one virtual machine cannot directly communicate with the other virtual machine. Now in Google version of Virtual Private Cloud, it follows a global construct, which means instead of creating a VPC in US East and US West, you can just create one VPC and put the subnets in different regions within that VPC. Now in this case, the virtual machines present in one region can directly communicate with the virtual machine in the other region without the help of VPN gateway. Now I guess you have some idea about how Google VPC is different from the VPC of other cloud service providers. Now if you have understood the concept, you can put the answer in your own word and explain it. The next question in networking is, what are routes and firewall rules? Now when we talk about VPC, this question comes tagged along. Now route tells the virtual machine instances and the VPC network how to send traffic from one instance to the destination. This destination can be either inside the network or outside of the Google Cloud, which is typically the internet. Next, firewall rules are rules which allow you to control which packets can travel to which destination. It lets you allow or deny connection to and from your virtual machine instances based on the configuration that you specify. So these was about routes and firewall rules in Google Cloud networking. So our next question is, what is load balancing? Now this is a frequently asked question in many GCP interviews. Load balancing is a process of distributing the computing resources and workload in a cloud computing environment to manage the demands. By spreading the load, load balancing will reduce the risk that your application will experience performance issues. By using cloud load balancing, you can serve content as close as possible to your users. We can also mention this point that cloud load balancing is a fully distributed, software-defined managed service. It is not hardware based, so you don't have to manage a physical load balancing infrastructure. So this was about load balancing. Our next question is, what is Cloud DNS? Well, Cloud DNS is a high performance, resilient global domain name system service that publishes your domain name to the global DNS in a cost effective way. Now, DNS is nothing but a directory of easily readable domain names that translate website names into numerical IP addresses which are used by computers to communicate with each other. For example, when you type a URL in your browser, DNS converts the URL into an IP address of a web server associated with that name. Like www.example.com is translated to the IP address of 72.220.193.173. Now I guess you have some idea about DNS. Now let us move on to our next question. Now next question is a scenario based question. How can I connect my existing network to Google Cloud resources? You can answer this by saying Google provides 4 options to do this. The first one is through Cloud Interconnect, the second one is through Cloud VPN, the third is through direct peering, and the fourth one is through carrier peering. Now Cloud Interconnect enables you to connect your existing network to a VPC network through a highly available low latency connection. You can choose Cloud VPN, which will enable you to connect your existing network to a VPC network through an IPsec connection. Next, direct peering enables you to exchange internet traffic between a business network and Google at one of Google's broad-reaching edge network locations. And the fourth option is carrier peering, which allows you to connect your infrastructure to Google's network edge through highly available low latency connection, which is provided by the service providers. Moving on to our next question, describe some of the security aspects that a cloud offers. Well, some of the important security aspects that a cloud offers is access control. It offers the control to the admin to decide the access of other users who are entering the cloud ecosystem. The next security aspect is identity management. This provides the authorization for the application services. And third is authorization and authentication. This security feature lets only the authenticated and authorized users to access certain applications and data. These were some of the important security aspects that a cloud offers. Moving on to our next question, list some of the GCP security services. GCP security services include Cloud Security Command Center, Cloud Armor, and Cloud Identity. Cloud Security Command Center is the tools that let users view and monitor their cloud assets and provides important security support functions like storage system scanning, vulnerability detection, and access permission reviews. Next, Cloud Armor is a DDoS and application defense system. It is built using the same major technology and infrastructure that Google relies on to protect its services, including Google Search, Gmail, and also YouTube. The third security service is Cloud Identity. Now this service controls and defines the users and groups and the GCP resources they have access to. Now these were some of the GCP security services. So now let us move on to a last set of questions on other GCP services. Now these other GCP services would include Big Data, Internet of Things, and Google Cloud Artificial Intelligence. So the first question in this section is, what is Google BigQuery? BigQuery is a Google Cloud's fully managed, petabyte scale and cost-effective analytics data warehouse that lets you run analytics over vast amount of data in near real time. You can say Google BigQuery is a replacement of the hardware setup for the traditional data warehouse. You can also mention how the BigQuery organizes its data. We can also mention the BigQuery organizes the data table into units that are known as datasets. Moving on to our next question, what are the big data services which are offered by Google Cloud Platform? Well, some of the services are Google Cloud BigQuery, Google Cloud Dataflow, Google Cloud Dataproc, Google Cloud Pub or Sub, Google Cloud Composer, Google Cloud Big Data, and Google Cloud Data Catalog. Moving on to our next question, what is Google Cloud Dataflow? Well, this is one of the important GCP's big data service. You can answer this question by saying Google Database is a managed service for executing a wide range of data processing patterns. It provides a managed service and a set of SDKs that you can use to perform batch and streaming data processing tasks. It works well for high volume computation, especially when the processing task can clearly and easily be divided into parallel workloads. Next, moving on to our next question, what is Cloud AutoML? This is one of GCP's machine learning service. While Cloud AutoML is a service that enables developer with limited machine learning and programming expertise to train high-quality models specific. You can use AutoML to build on Google's machine learning capabilities to create your own custom machine learning models that are tailored to your business needs, and then integrate those models into your application or website or both. So this was about Cloud AutoML. Let us move on to the next question. Our next question is, explain Google Cloud AI Platform. Well, AI Platform is a suite of services on Google Cloud which are specifically targeted at building, deploying, and managing machine learning models in the cloud. AI Platform provides the services you need to train and evaluate your training model in the cloud. It is integrated with several easy-to-use tools like BigQuery and data labeling service to help you build and run your own machine learning applications quickly. You can store and manage the large amount of data with BigQuery and then prepare or label this data for model training using data labeling service. So this was about Google Cloud AI Platform. Now our next question is, what is Cloud IoT Core? Well, Cloud IoT Core is a fully managed service that allows you to easily and securely connect, manage, and store data for millions of devices which are spread globally. It provides a complete solution for collecting, processing, analyzing, and visualizing IoT data in real time to support improved operational efficiency. So this was about Cloud IoT Core. Now let us see the next question. Our next question is, what service would you use for text analytics in Google Cloud Platform? So the service which is used for text analytics in Google Cloud Platform is Cloud Natural Language. Natural Language AI enables you to analyze text and also integrate it with your document storage on cloud storage. You can extract information about people, places, and events and have a better understanding about social media sentiments and customer conversations. So these were some of the important and frequently asked GCP questions. So now let us move on to the next topic and see what are the skills required to become a cloud engineer. So cloud engineer is an IT professional responsible for performing technological responsibility concerning cloud computing. They are mainly responsible for maintenance and support, management, planning and designing of an infrastructure on the cloud platform. So now talking about the skills required to become a cloud service provider, the first skill is having knowledge about cloud service provider. So if you're thinking of taking the cloud computing career path, spend some time familiarizing yourself with at least one of the cloud service provider. The top 3 cloud service providers are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Now if you want to see a comparison between these 3 cloud service providers, I will leave a link to that video in the description box below. Now these cloud service providers offer end-to-end services like compute, storage, databases, ML, migration, and many more. It includes almost everything that is related to cloud computing, and this makes it one of the important cloud engineer skills. The next skill is programming skill. This is one of the important cloud engineer skills. Proficiency in programming language is essential for scaling web application. Some of the programming language you should be familiar with are PHP, Java, .NET, SQL, Python, and Ruby. You can learn all of these languages with the help of blogs, online videos, or either offline or online classes, but the most important of all is hands-on practice. Now talking about the third skill required to become a cloud engineer is having knowledge about the important cloud service domains. Now this cloud service domain would include compute, which involves virtualization and serverless computing. Next is cloud storage, which deals with data and information which is stored in the cloud. After that, we have networking and security. Now, a cloud engineer should be familiar with the basic cloud networking concepts and network security, which includes encryption, authorization, and different protocols. Moving on to our next skill, that is web services and APIs. Cloud architects are heavily based on APIs and web services because web services provides developers with method of integrating web application over the internet. XML, SOAP, WSDL, and UDDI open standards are used to tag data, transfer data, describe and list services available. Plus, you also need APIs to get the required integration done. Now, having experience of working on websites and related knowledge would help you have a strong core in developing cloud architectures. The next skill is Linux. Now, Linux is an open source operating system that can be customized to meet business needs. Linux is being increasingly adopted by many cloud service providers because of its various benefits. So as a cloud engineer, you should be able to architect, administer, and maintain Linux-based servers. Talking about the next skill required to become a cloud engineer, it is DevOps. Now, DevOps brings in the development and operational approach in one place, thus easing the work dependencies and filling in the gap between the two teams. DevOps approach is being increasingly adopted by many top companies and gets really well with most of the cloud service providers. Now, these were some of the important skills required to become a cloud engineer. Let us now move on to our next topic and talk about GCP certification. Now, cloud certification serves as a validation for your cloud skills. They can make your resume stand out during the hiring processes and can also result in larger paydays. Now, preparing for the certification will help improve your knowledge and can also be helpful during your job interviews, as organization needs certified people. This is because clients generally prefer companies whose employees are certified, as it gives them assurance with regard to quality. So I would highly recommend you to take Edureka's Google Cloud Architect certification training, which is curated by top industry experts. This Google Cloud training will enable you to design, develop, and manage a robust, secure, and highly available cloud-based solution for the organization's need. This Google Cloud Architect certification course consists of demonstration, assignments, multiple choice questions, and a certification project which will help you master Google Cloud concepts. And with this, we have come to the end of our session. I hope it was helpful. Happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you